Starry, starry night. Down on the summer day, now I'm so she knows I'm with you. Catch the dreams and catch the dreams and on the summer. How I understand what you try to say to me, how you suffered all your sins, how you try to suffer me through, even now I feel starry, starry night. Flaming clouds and brightly gray, swirling clouds and fiery winds, reflecting against the tide of shadow, changing morning fields and everything, where the faces lie. What you tried to say to me, how you suffered for your sin, how you tried to set me free with your perhaps there was all they did not know, but still your love was true. And when no hope is left in sight on that sorry star, you took your life as a gift. But I didn't know this world was never meant for us. What is brainless spent on aimless things, with eyes that watch the world, the stranger in the world, the ragged man in the black coat, the silver thorn of roses, my queen of my now I got what you tried to say to me, how you suffered for your sin, how you tried to set me free. It would not have seemed to me how this thing was still.
Oceans apart, day after day, and I slowly go with me. And I hear your voice on the line, but it doesn't stop the pain. I see you last and never. But how can we say forever? Wherever you go, whatever you do, I will be right here waiting for you. Oh, how my heart breaks, I will be right here waiting for you. I took for granted all the times that I thought would somehow. I hear the laughter, taste the fears, but I can't hear you now. Oh, can't you see it, baby? You got me going crazy. Whatever you do, I will be right here waiting for you. I will be right here waiting for you. I can't survive this way. With you, I'll take it. Oh, can't you see, baby? You got me going crazy. Wherever you go, whatever you do, I will be right here waiting for you. Say, oh, it's right here waiting for you. Waiting for you.
Precious. Okay, so this third one is going to be a poetry reading of some of my writings. And yeah, I actually like reading out loud to people. I read the whole Lord of the Rings trilogy out loud to my ex-girlfriend. It took me like a month to do the whole thing because I was emoting all the characters and everything. And hopefully one day I'll get to read to you in person so you can look at my eyes and see how much I love you. But I'm going to start with the first one. It's called Angel Hero Forever. As I was lying half awake, half asleep, in a bed of soft and fragrant grass, gazing up at the stars, my hands softly lit by the light of the moon, my mind began to drift away. I gazed at the stars and imagined the eyes of my angel sparkling down upon me. I, the hero, had been through many battles, had been hurt in so many places, so many times before. But that which had been hurt the most was my heart. It lay in pieces. But the hero's angel had been sleeping outside on the very same night, and in the light of the moon had noticed something sparkling. It was a piece of her hero's heart. She picked it up, and a little further away she found another piece, and as she kept walking she kept finding more and more pieces. Meanwhile, the hero noticed the grass was wet. It was wet with the tears of his angel. He carefully brushed the grass with his hands, collecting every single teardrop, and he crawled on his hands and knees, as far as the tail of the tears would lead him. Thus the two of them traveled day and night, never straying from the tale of tears or the road of hearts. The angel had picked up every single piece and carefully pieced them all together and added many parts of her own heart, the most beautiful parts that were not even there before his heart broke. and thus their hearts were joined before they even met. And the hero cried, because his angel had been crying. Her pain was his pain, and he wept his tears upon her tears. And because tears come from parts of the soul melting away, the angel's soul and the hero's soul were joined thus before they ever met. Then on the dawn of one beautiful summer day, the trail of tears and the road of hearts ended. The hero looked up from his crouched pose, and the angel looked down. The hero saw the blush on the cheeks of his angel, more beautiful than any dawn could ever be. Their gaze met, eyes locked, hearts joined, two souls as one. The hero held out his hands, full of the tears he had collected from his angel, plus his own tears, which had been shed, two souls joined as one. The angel held out her hands, full of the pieces of his broken heart which she had collected, plus the parts of her own heart which she had added to his, two hearts joined as one. Their hands reached out for each other. Their rings sparkled brightly against each other, and thus the hearts and souls of the hero and angel were joined, never to be separated again. And here's the second one, Sunrise Smile. Watching the moon rising from beyond the bubbling stream, which is steaming in the cool night air, is like looking into your eyes through the mists of distance. And you are so beautiful to me. And just like the moon, the distance cannot alter or diminish you in any way. I sit lurking under the darkness of murky shadows, waiting for the clear vision of your warm smile to bring light into the darkness of my soul, in nervous anticipation, like waiting for a beautiful sunrise over a darkened landscape, knowing in my mind's eye how beautiful it will be, the first blush of dawn reminding me of your tender rosy cheeks, yet the real wonder of your smile not fully revealed till it is before me, for not even the greatest mind can fully comprehend the joy of your sunrise smile until it is upon me. Wonders when I reach out my hands to you, if you can feel it, and when I hold my hands in each other, wrapping four fingers of my right hand under the four fingers of my left and thumb over them, if you can feel me holding your hands in mine. Wonders when I press my hands to my chest, if you can feel me touching your heart. Wonders when I shed my tears, if you can feel the rain falling down, although there are no clouds. Wonders if when I call out your name and say, sweet honey, I know it sounds so crazy to have these feelings so early, but I feel this from deep within my soul. I think I'm falling in love with you. If you can hear me. A deep heartfelt sigh as the cold west wind blows and dries my tears before they can touch your tender cheeks, taking my hand away from my chest to reveal a snow-encrusted long-stemmed rose, sparkling like countless stars in the first light of dawn, placing it gently upon your pillow and then slowly backing away, not wanting to disturb your sleep, gazing at you afar in appreciation and admiration for who you are, awaiting your smile like the first light of the morning sun after a long, cold, and lonely night, and the sparkle of your eyes like the twinkle of the morning star. Slowly departing across the endless emerald fields and grass, teary-eyed and overcome with the beauty and joy of what I just saw, my teardrops intermingling with the morning dew that you see when you venture outside, glittering with the brilliance of your sunrise smile, bringing light to all the shadows upon the landscape, and guiding me and keeping me warm upon my long journey home. The memory of you bringing me hope and comfort and something to look forward to till the next time we meet. And here's the third one. My one and only. Let me tell you this right before I start. At first sight, you part the door to my heart. A written rhyme that forever preserves is the least your breathtaking shape deserves. Before we met, I planned to run lonely. Now you're my true pet, my one and only. For you in my heart, there's no rival. Your true, unequaled love's my survival. When we meet, the sun glows into my soul. Then I greet the one who knows my heart whole. Every glorious day I glimpse your face. I see flawless beauty and swan-like grace. Your hair is a halo of flaming fire. Having your care is my deepest desire. My heart can soar when I hear your laughter. I know then you're my humor's clear master. When you're laughing, light glitters in your eyes. Then each dazzling bright diamond drops its disguise. The sad, twinkling tears streaming while you cry are like shooting stars shrieking through the sky. Your soft, rapturous, ruby-red lips green, twin strings of precious pearls fit for a queen. A kiss from your lips, my sweet darling love, is an angel's touch from heaven above. Your voice is sultry as a summer's night. To my soul's darkest depth your smile brings light. An unsurpassed face, the texture of cream, beauty from some place past my wildest dream. Your legs look like golden orbs at first glance, or eagles that soar when immersed in dance. Though seeing your splendid shape may entice, Only your love can bring me paradise. And here's why I love you so much. And this ends as it started, because true love is like a circle. It never begins and it never ends. It's perfect. At first meeting, you feel like it's been there forever, and it never ends because it always leads back to the beginning, and you fall in love all over again. Living life is like walking through a fog, except that you don't know that you are in the fog until a bright light cuts through it and shows you the way out of the darkness. And all of a sudden, that light not only illuminates the paths you had previously taken and all the wrong turns, pitfalls, and mistakes you made along the way, but it also shows you the right road ahead, the road to happiness, the path to the future you had always dreamed of but never dared hope could exist. A future with true love. One special day this light dawns in your eyes. It is the light of the smile of the one you love, your one and only. It is the light in her sparkling eyes, shining down upon you with love, making you feel so special, so happy, so protected, so loved. Your heart opens up to her full of love, blossoms like a rose, her sweetness overwhelming you like the sweet aroma of jasmine in the air, making your cheeks glow like the morning's dewdrops make rose petals sparkle. True love is like sight to the blind man. Unless you have it, you don't know what you're missing. I was that blind man until I met you. Every time you tell me I love you, it feels like the first time. It's because not only have you healed my heart and picked up pieces broken along the way, but your love has added new parts that were never there before. You have made my heart and my soul so much stronger and happier than it ever was. Stronger and happier more than ever before the first time it was hurt. This is so wonderful and rare. Not only have you given me back what I thought I had lost forever, you gave me something better and more special than I've ever had before, or even believed could be possible to have. Your love. And every time you tell me I love you, you touch one of those new parts of my heart, which you have created, a new and different one each and every time. That's why every I love you feels like the first I love you. You are like the blind man's first sunrise, the first light dawning on a new day, a day of hope, a day of love. You are like the first time a deaf man hears his own heart beating and feels life within him that he never knew existed. I used to settle for less, but being loved by you now, I know that true happiness only lies along the road which leads me to you. I've told you before, sweetheart, 1,000,000 years of pain and 1,000,000 miles of unhappiness are all worth it, as long as you're waiting for me at the end of that long road. I would climb the highest mountain barefoot, as long as I knew you waited for me on the peak. You, my love, being my warmth and my shelter, as the rest of the world falls away beneath us. I would dive into the deepest ocean without scuba gear, as long as I knew you waited for me at the sea bottom, your sweet, soft breath being the only air I would ever need to breathe. Like the morning sun rising over my garden, revealing more and more beauty with each passing moment, my love for you grows day by day, getting stronger and stronger in every way. Even though at any one particular moment it doesn't seem like it could go any greater. Just like the beauty of my roses, the very next moment exceeds all expectations, and every new moment I discover a new reason of why I love you so much. Okay, I'm just going to do the first one again, just one more time. As I was lying half awake, half asleep, in a bed of soft and fragrant grass, gazing up at the stars, my hands softly lit by the light of the moon, my mind began to drift away. I gazed at the stars and imagined the eyes of my angel sparkling down upon me. I, the hero, had been through many battles, had been hurt in so many places, so many times before. But that which had been hurt the most was my heart. It lay in pieces. The hero's angel had been sleeping outside on the very same night, and in the light of the moon had noticed something sparkling. It was a piece of her hero's heart. She picked it up, and a little further away she found another piece, and as she kept walking, she kept finding more and more pieces. Meanwhile, the hero noticed the grass was wet. It was wet with the tears of his angel. He carefully brushed the grass with his hands, collecting every single teardrop, and he crawled on his hands and knees as far as the trail of tears would lead him. Thus the two of them traveled day and night, never straying from the trail of tears or the road of hearts. The angel had picked up every single piece and carefully pieced them all together, and added many parts of her own heart, the most beautiful parts that were not even there before his heart broke, and thus their hearts were joined before they ever met. And the hero cried because his angel had been crying, her pain is his pain, and he wept his tears upon her tears. And because tears come from parts of the soul melting away, the angel's soul and the hero's soul were joined thus before they ever met. Then on the dawn of one beautiful summer day, the trail of tears and the road of hearts ended. The hero looked up from his crouched pose, and the angel looked down. The hero saw the blush on the cheeks of his angel, more beautiful than any dawn ever could be. Their gaze met, eyes locked, hearts joined, two souls as one. The hero held out his hand, full of the tears he had collected from his angel, plus his own tears, which had been shed. Two souls joined as one. The angel held out her hands, full of the pieces of his broken heart, which she had collected, plus the parts of her heart, which she had added to his. Two hearts joined as one. Their hands reached out for each other, their rings sparkled brightly against each other, and thus the hearts and souls of the hero and angel were joined, never to be separated again. That's why I wanted to close with that. Mwah. Love you. Love Precious and Priceless too. I hope you love us too. Wow, my voice is totally gone now, so I'm going to go get some water. This is going to be a 13-minute poetry reading. That was a long one. I'll do more songs for you later, and hopefully maybe sometime you can report something for me. I think that would be a great way for us to get to know each other better. If you could report stuff for each other, you can put it on my site. I set it to where you could write something to me or like record something to me and put it on there. And yeah, I love you. I love them. Yes, we will. Hope to talk to you soon. Okay, hope I talk to you later too. Hi everyone, I'm really excited to present to you my Space Engine channel on YouTube. Space Engine is a universe simulator that lets you explore the entire known universe. Not only real celestial bodies that we have already discovered, but also procedural worlds, which are generated using artificial intelligence based on known scientific laws and principles. And it's really good because it not only lets you travel via spaceship, using real spaceships that were created by both NASA and by private industry, but also freehand, which means you have no limitation for movement in any direction, go backwards and forwards in time, to any planet, galaxy, or sun that you wish. You can even travel into black holes. I am actually using Space Engine to confirm some of my theories and ideas which I have published and will continue to publish on the origin and future of the universe. Basically, in my book, I conjecture on a new theory of everything. In my theory, each dimension can be analog to a primary color. In other words, in our universe, each spatial dimension will be equivalent to an additive primary color, red, green, or blue, with time as the background, black. With a complementary space-time universe, which consisted of dimensions that analog to subtractive primary colors, cyan, which had been yellow, with complementary time as the background, white. As one space expands in the one universe, the other contracts, and vice versa, because of the arrow flow of time opposite to each other, but forward within each. It's been peer-reviewed, and it seems there's some excitement over this, as this would solve the dark matter, dark energy problem by unifying the strong nuclear force and gravity. The strong nuclear force is carried by gluons and color charge, and analoging dimensions to primary colors is gravity's version of color charge. So now we have a strong force gravity unification and electroweak unification which has already existed, so we just need to combine those two dualities. There are 4 layers to my omniverse, with universes of different dimensions in each layer. The number of dimensions in each layer bear a Pythagorean relationship to the other layers, and each universe has a parent superverse, from whose parent black hole it was created. If you loop through the entire hierarchy of universes, you end up back where you started. So the omniverse is not only cyclical in time, but also in space. By the way, if there are multiple timelines, they will be created right after the Big Bang by the force of inflation and the emergent diverging timelines along 2 dimensions of time, 3 Cartesian coordinates. Stephen Hawking has already conjectured about this in imaginary time, which consists of 2 axes of time which originated at the Big Bang. And if the cyclic model is correct, and dark flow does reverse the expansion of space, the timelines would converge once again with a big bounce, as the universe deflated, rinse and repeat. Antiverse, which is the complementary universe,
would have opposing cycles because the arrow of time is opposite compared to ours. And if there was some way to construct some sort of device, like Stargate, to tap into the barrier which separates the two universes consisting of light, which does not experience the passage of time, then both time and long-distance space travel will become possible through the second temporal dimension, which keeps each timeline intact. Like according to Einstein, the past, present, and future all coexist, and it is we who move through them, so theoretically this should be possible. He also stated that the universe, or omniverse on a larger scale, created us in order to understand each other, forming the framework for a cosmic collective mind, which encompasses not only humans, but animals, plants, alien life, even whole planets, which is a superverse form of Gaia theory. It's even stars and galaxies. The only difference is the density of the level of consciousness. For example, plants, are much larger than any single life form, but their density of consciousness is much less, with their memories or their fossil records spread out over a much larger area. So any one spot on our scale is seemingly lifeless, but it's not. The planet consists of a complicated series of checks and balances and delicate interplay between different parts that can and should be considered alive. I guess I'll leave that for a sequel. But I have some more exciting news. Now, this news that I have is confirmation of a large part of my theory. It was published in Scientific American, an article listed as two futures explaining time's mysterious past. It is based on research done at Oxford, in the UK, by Dr. Julian Barber. Julian Barber and his colleagues argue that it is gravity, rather than thermodynamics, that draws the bowstring to let time's arrow fly. Looks like they also caught on to my idea that gravity and time are directly related, since time is just as out of place with the other three dimensions as gravity is with the other three forces. And they published a carbon copy of my two-time-linked two-universe theory from 10 years ago, which is quite interesting. I am going to quote from the publication so that you can see the similarities to my theory. The theoretical claims put forward in the Physical Review Letters Journal could revolutionize the field of research into the origin and future of the universe. In the paper titled Identification of a Gravitational Arrow of Time, an international team of world-renowned scientists led by Oxford's Dr. Julian Barber challenged assumptions about the so-called arrow of time. The arrow of time is the theory that time is symmetrical and therefore time moves forward. They contend that there is no scientific reason that a mirror universe could not have been created where time moved in a distinct form opposite to our own. But in a quirk of science, it is thought that if a parallel universe did exist where time moved backward, any sentient beings there would consider that time in our universe in fact moved backwards. That is exactly what I wrote in my proof of concept for my book. So it is very good that colleagues have been finding out the same conceptual ideas that I had and actually developing a mathematical framework for it. Anyway, back to Space Engine. So besides using Space Engine to confirm some of these ideas in terms of how matter is clumped in the universe, and to come up with new ideas for what the future of the universe might hold for us, as well as how it originated in any past cycle that existed, we can use Space Engine to test warp drives. The reason why I want to test warp drives is because it has come to my attention that the Alcubra drive is actually feasible under some new ideas where it will require much less exotic matter in order to be workable. Basically, we're down from the mass of the planet Jupiter to the mass of the Voyager spacecraft. That is the amount of exotic matter that we need in order to make it work. So that is quite a sizable drop from what it was before. NASA has even drawn a framework for the Alcubra drive Starship. This is very interesting, and it's one of the practical starters that are included with space engine. It's completely consistent with relativity. Now, the concept involves warping space. You contract the space in front of the ship and expand the space behind it. It's sort of like having a dish on a tablecloth. Instead of using your force or your hands to move the dish, you can move it by bending and folding the tablecloth. Contract the tablecloth in front of the dish and expand it behind it. That will automatically cause the ship to move without using propulsion. Now, the ship in Space Engine that uses this idea is the Ixs Enterprise. It's a conceptual interstellar spaceship designed by NASA scientist Dr. Harold White. It was revealed in 2013 and was designed for the goal of achieving warp travel. It makes use of a modified version of the Alcubie drive, on which experiments are being run using interferometer to develop a proof of concept. The idea has been out since 2013, but in 2014, it was found that you could use less exotic matter in order to make this work. 1,600 hours have been spent on the conceptual artwork for it. CGI representation of the new vessel was designed, and the energy required to power the warp drive is approximately negative 700 kilograms. The ship has two thick outer rings to reduce required energy to generate the warp field, a contraction of space and an expansion of space behind it. The space inside the rings is optimized to put more space for cargo, crew, and equipment. I have used this concept to journey to not just interstellar targets, but intergalactic targets. I've been to M31, the Andromeda Galaxy, M33, the Triangular Galaxy, and two other nearby galaxies, NGC 300 and NGC 55, which are both between 6 and 7 million light years away. That is the most I have gone so far, and I can do that in somewhere between 12 and 18 hours. 12 hours for the nearer targets that are within about 5 million light years, and slightly more for the ones that are around 7 million light years. And the way to do it is to have two engines on the ship. There's conventional engines which are responsible for acceleration, and there's the warp engines which are responsible for the bending and warping of space. So first you use the conventional engines, and you aim them in a proper direction to get them out of the solar system. And once you're out of the solar system and out of the gravitational force of the sun, then you can go into warp. Now you have to make sure you aim correctly at the target and use the conventional engines in order to fix any delta V or velocity errors that might be present. Now, you can, with the ship that I was using, you can go all the way up to warp 12. It's a logarithmic scale, which means that each increase is an exponent level over the past. So in other words, if you had, let's say, warp 3, it's twice as powerful as warp 2, and warp 4 is 4 times as powerful, for example. Warp 12, which is the highest speed, is what I use for intergalactic targets. And that is the fastest that this ship can achieve. I use that in conjunction with the conventional engines, and when I get to the target, I get out of warp, and I just use the conventional engines to do a tour of the galaxy, which proves to be quite interesting. So there are different things that this ship can do. The particular ship I picked can also do orbital travel. For example, you can do a tour of Saturn's rings or any other planet's rings, and you can also do a tour of the planet itself by flying over it. Using the procedural generator in Space Engine, I was able to locate what could be considered grassy planets in the Andromeda Galaxy, and I did a trip over one of these planets for 48 hours using this ship. It was quite interesting, and I found it to be very Earth-like. So if such a planet does exist, it will quite possibly be a second home for humankind. So So I hope you enjoyed Space Engine and all its features. I will try to update this intro every so often when I become aware of new features. Like, for example, I have not yet tried out some of the features involving docking spaceships or transitioning from one spaceship to another, because the spaceship I'm using currently is an all-in-one that can use both for planetary travel, interstellar travel, and intergalactic travel. So, I hope that you enjoyed Space Engine, and if you have any questions, feel free to leave comments for me. I will answer them as quickly as possible. And you can find Space Engine at spaceengine.org. It is a free download, and I hope you enjoy it as much as I do. Thank you. Part 7 of the Msi intro is just a quick update of sort of the features you might see on planets. For example, besides grass, you can find different colored minerals and rocks, especially if you find anything that's purple or green, that indicates plant life. Sometimes you'll see glowing lights. That I've only seen on Earth, but if you do find another planet with that, that is actually the algorithm for the AI that runs the program. Indicates that's technological. So, but yeah, not natural. Other things that you might see are beautiful displays of aurora, both northern lights and southern lights, as well as different cloud formations. Weather is not currently simulated as far as things like rain and snow are concerned, but you will find puddle clouds and tornadoes and things like that. And we do also do different kinds of light effects, like halos or things like that, which involve ice crystals in the atmosphere. So you might find that of interest also. You can explore them with the station. You can basically fly right through any of these things, including the northern lights or the halos, the clouds, the tornadoes, or whatnot. Anyway, so hope you enjoy the program, and when I need to update, I will. Hi guys, this is an extra addendum. It is Msi Intro Part 8, and this has to do with the default menus in Space Engine on the left and the right panel. On the left panel, when you want to look for an object, like in Andromeda Galaxy, for example, M31, you would go to the magnification glass icon on the left side. That's Find Object. And you can find any object in there just by typing its letters. You can start typing it, and the list of objects and beginning with those letters will automatically show up, and then you can choose amongst them. It also has other things like looking at particular planetary systems of certain stars, map of the universe. You can save your locations there, and various other functions. On the right side, you can select which objects you want to see, for example, nebula, comets, galaxies, star clusters, things like that. And the other thing that you can do on the menus is actually also select the screenshots to save. So, for example, if you like the view that you see, you can save it. There's also function key combinations that save them, or a quicker way to do it. For example, for the screenshot saving method, you use F11. That saves it without the heads-up display information on each object. But if you want to save it with that information, you would do Control F11, for example. And so that is the way that you save your screenshots, and they would go into your screenshot folder. Okay, that's it for this update. So guys, this update is the 9th update in the Space Engine series, and this is for external programs that I like to use along with Space Engine. I do use Starry Night Pro, because it connects to my telescope, which is the Celestron 8 SE, and I can find any object on there going backwards and forwards from 1 million years in the past to 1 million years in the future, so you can see eclipses and other historical events at a very good time. That's Starry Night Pro Plus version 8, along with Space Engine Pro. The other thing that I like to use is I have my own program to make videos. It is OBS Studio. It is a free program, but it is feature-packed. It's probably the best one out there. and you can also save in surround sound audio as well as full screen video. And then I upload everything to YouTube. I have made 12-hour videos using that, and it's completely automated. I don't have to be at the screen for 12 hours. I can just let it run, and it does its thing, and then it automatically shuts off at the end of 12 hours. And it completely filters out external noise like fans, air conditioners, TV sets, even people talking in the background and whatnot. You only get the sound coming from your computer. Speakers are turned on. It sort of closes out that it goes directly through your sound card, which in my case is the Creative Audio RX 7.1 along with the Creative 7800 7.1 speaker set. And as far as the video is concerned, it will support multiple monitors up to 8K resolution, which is also the maximum resolution on space. So you can basically set everything up to high. I use ultra settings on my Space Engine, which is a preset, and everything records just fine. It doesn't really pick up that much storage for this 12-hour video that I made using MP4 format and OGG for the audio. I only took up 15 gigabytes, and that's very impressive. 15 gigabytes for a 12-hour video, and that's well within YouTube limits for how big the file can be that you can upload on it. And it takes about an hour to upload, which is fine. Maybe go to sleep while it does it. And then I can share that all across social media, Twitter, Facebook, anything basically. Even my website. Okay, that's it for this edition, which is the 9th in the Space Engine intro series. See you next time. Okay guys, this is the 10th installment of the Space Engine intro series. And in this one I'm going to cover another thermal program, and that is Msi Afterburner. Now what this does, it will keep track of your frame count, so you can actually set how many frames per second you want the program to be able to keep track of how much memory it is using, both video and regular RAM, and also temperatures on your CPU and your GPU. You have to also install DLL3, by the way, in addition to Msi Afterburner, Reader Tuner. And they both work really well together, and both give you the heads-up display on the upper left-hand side of your screen, and which does not, by the way, show up in your videos using OBS or your screenshots for that matter, so you don't have to worry about that. And also, you can upload your screenshots, of course, to Steam using the F12. So that's something else that you can do with CPUs. And so this is my 10th installment of the SE Intro series. So I just wanted to give you a quick update on the warp system in Space Engine compared to my theory that I've been working on. I'm not really sure that the Space Engine model of warp problem would work as is. It seems like it would be more of an in-out thing rather than just going through it as if it was another dimension similar to ours. Because we are three-dimensional, spatial three-dimensional creatures, so any additional dimensions would not be something that we would be able to experience. But if other dimensions were traversable in hyperspace, since they wouldn't follow our concept of length, width, depth, etc., there would be no way for us to journey through them unless we carried our own bubbles that contain our own space-time. So in effect, we would have our own micro forces within these dimensions. And these bubbles would contain the three spatial dimensions of time that we're familiar with. This is the book I'm working on, and I'm actually at chapter 18 right now. In it, I created a story model of two universes with dimensions of one complementary to the other and reverse arrows of time, as I explained in the first part of this series. The reverse arrows of time are relative to each other, but both forward within themselves. It's like when you go to one of these airports, which you see in Europe, I've seen this in Frankfurt, Germany, where you have these conveyor belts. They carry people and luggage from one part of the airport to the other. Not all of these conveyor belts are going in the same direction, but everybody is faced forward relative to their own conveyor belt. This is what arrows of time are like. So basically, with these two complementary universes, it would be like two conveyor belts going in opposite directions, but within each respective belt, everyone was facing forward. Makes sense, right? So basically, everybody in the particular universe is going forward in time, even though each universe has a different arrow of time. And in this particular case, they're going opposite. Now, the dimensions in these universes correspond to the color model that I stated, which is the three additive primary colors, red, green, blue, corresponding to our spatial dimensions, and three subtractive primary colors, cyan, magenta, and yellow, which correspond to the spatial dimensions of the other universe in the toy model. Black corresponds to our time, and white to time in that other universe. As a complete unit, it would be cyclical. As one expanded, the other would contract and vice versa. As I had already stated, a few years after I started working on this, I actually saw a mathematical basis for the exact same model being developed independently by some physicists, and I reached out to them, and we have been corresponding on my work. Now, as far as the way these universes would work, I could envision both space and time travel. If we found a way, a bridge between these two universes, and to use the analogy of the conveyor belt again, we could actually go to an earlier point in time. How would we do this? We would leave our conveyor belt, jump to the other conveyor belt in the aforementioned bubble, space-time bubble, so we would still be within our own dimensions inside this other universe, in that bubble. We would jump to the other conveyor belt, which was moving in the opposite direction relative to ours, and then jump back into our universe right after that. So basically going from one conveyor belt to one going the opposite direction, wait a little bit, and then jump back to ours would put us in an earlier point in our own timeline. And it really sounds like a paradox, something that shouldn't be possible in Riley's reality, but I had a different way of looking at it because in my theory, we also have the two dimensions of time. Now, what that does is it means that we can nest multiple timelines in each universe. And these timelines are what I call time verses, since they're own universes in their own right. Each would have a different outcome. So basically, when you jump back into your universe, you would be on a different timeline, one in which you were always destined to be on. Now, this is called super reality as well as superdeterminism. Now, what superdeterminism is that every outcome is already planned out in advance. And this is something I had also heard on Cosmology with Neil deGrasse Tyson, where he talked about how quantum tunneling and quantum entanglement shows that two particles at opposite ends of the universe are connected. How is it possible? Basically, when something happens to one, it also happens to the other. There's only one way that this can be possible, and that is space-time itself is an illusion on the macroscopic level. On the basic fundamental level, everything is connected to each other. Therefore, these connections between two distant objects are entirely possible. And the other thing is with superdeterminism, this connection always existed because the past, the present, and the future all coexist. So basically, when they appear to be much closer in the past, that linkage has survived into the future because if all past, present, and futures coexist, that linkage still exists today because it has always existed. Because the future has always existed. Now, you may say, what does this do to free will? Free will itself is an illusion of sorts, because we think that we have the power to decide what we're going to do, but really we've already made that decision because the future has already happened. Therefore, the illusion of choice doesn't exist, and the illusion of a future that hasn't happened yet doesn't exist. This also explains certain things I'm getting over in intuition. With regards to, let's pick the time of the landscape. Time of the landscape with pillars and values in it. Sometimes, some of us may be able to climb some of the hills and see further ahead in time. That's the future. The future has already happened. If we climb the hill, we see further ahead to that future which has already happened. That's how we experience it. Because the elevation of time is different for different people, for different parts of the time space that you're on. For example, in noetics, there's a way to predict when bad things are going to happen. You measure the general emotional state of the human population. Predicted things like 9/11, predicted things like the big tsunami in 2004 in Indonesia. The way it does it is it records people's emotional states in advance, and when you see a big dip, it shows that people are dreading or anticipating certain events, certain big events that are going to happen. You also see this in the animal kingdom. For example, we had an earthquake here on the East Coast back in August of 2012. Animals, the Washington Zoo, was documented on video, were apprehensive, basically going crazy. Specifically two species. One was the orangutan, and the other one was a species of bird, one of those parrots that come from Africa, I believe is the African great parrot. Pretty intelligent. Language, more than mimic, can invent their own words and understands the concept of zero and things like that. Now, these animals were going crazy 30 minutes prior to the earthquake as documented by tourists who were then wondering what was going to happen. Of course, 30 minutes after that, there was a 5.8 earthquake that was felt on the island. The other big example was the tsunami in 2004 in Indonesia. Elephants and other animals were actually heading for the hills hours prior to the tsunami, where people were setting themselves on the beach globally without the world. The reason why people are less in touch with these feelings and intuitions of these things is because as we grow up, we become more tainted by our society and lose our basic instincts that we had when we were little. If we could find a way to have benefits of society and still preserve those natural instincts, then we would be much better off as a species, probably much more survivable in the long run. Okay, that does it for this video. And I also want to add that now survivability is a great filter, and one reason why if we don't find any other sentient species in the universe, ecological species, because we do have sentient species on our planet. Animals are, and many plants are sentient. Trees nurture each other through their roots and support each other when one is sick. Basically, they're intelligent and sentient in a different way compared to us. And bees and flies are intelligent because of their culture in terms of hives and how they communicate with each other and communicate advanced scientific techniques as in meteorology, wind direction, astronomy, star position, etc., the position of the sun in regards to where their new hive is located. So yes, there is definitely animal intelligence. Of course, elephants, with the way they mourn for their dead, they're going to return to the same site year after year, and the social structure, of course, primates, and already mentioned parrots, and many other creatures are highly intelligent. But we're talking about technological species. Dolphins in the water are also extremely intelligent, but they don't have hands in the water, so they can't create technology, obviously. And all these creatures have at least 4 or 5 real level of intelligence. And of course, their intelligence is so we can't really rank it. But if we don't find any technological species in the universe, it probably means that most of them die out and they're unsustainable before they reach the level that they can actually travel through the universe. So that is a dire warning against things like climate change, and ignorance of science in general, overpopulation, and short-term instant gratification and things like that that our species has been guilty of, and is actually even more guilty of in the past century, where we created massification where 2/3 of the species on the planet, plant and animal, are expected to be extinct by the year 2100. We need to stop all these things and be more sustainable, basically, in a way, combining the benefits of industry and also of indigenous cultures, which sought to preserve the environment, and we're not as polluting as we are. Of course, it's not as plastic, or fossil fuels, at least in a large quantity, like we have been doing. And also we can go into health, things like processed food, obesity, diabetes, things like that. Organic farming's far better. The way we used to do it had far less health conditions back then, or BMI index, of course. and things like that. So all these things will be discussed in the future. This is my 11th recording for Space Engine videos. See you all soon. This is the 10th update to my intro series, and in this one I will discuss even more proof for the cyclic model of the universe. Now, the cyclic model of the universe, of course, not only do artificial universes, our own universe had previous states before the Big Bang. That's why it's called the Big Bounce. It solves the singularity problem, which is also, by the way, solved by the fact that in quantum cosmic loop cosmology, we have space-time as discrete units of 10 Planck size. What that does is when a black hole collapses, or a universe collapses, there is no singularity because there is a minimum size, so there is never an infinite density to the universe. Basically, gravity becomes a repulsive force, which is also predicted by relativity. When the universe gets to a small enough size and goes from the 3-spatial dimension to 2-spatial dimension, as well as the fact that we have evidence of this in high energy cosmic rays from the universe, which only seem to have 2 degrees of freedom, usually existing in 2 dimensions, not 3. And that's spatial dimension. So basically, you have a previously collapsing universe that then Big Bounce and created ours, which is still cyclic and will keep doing the same thing. Now, in this case, what happens is, as the universe expands, we go through a period called inflation, you'll reach homeostasis, where it'll stop expanding and then will contract again. What will create this contraction or deflation is going to be dark energy, which sounds counterintuitive because dark energy is supposed to do the opposite thing. It's supposed to cause unlimited expansion. But as the universe expands, it would actually reach a level where everything was so far away from each other that dark energy became an attractive force, not a repulsive force that would draw everything back together again. It's like a seesaw going back and forth. Now, the way that this would work is, and the way that we showed it is with quantum gravity, would be the time before the Big Bang. And it's the oscillatory universe of the Big Bounce theories. Now, the proof is that the cosmological constant, the kind of value 1 or 0, which is what we expect if it was a single universe. It actually has a very low non-zero value, which is more of something we expect if it is something that changes with each cycle of the universe and is gradually winding down. Once it reaches 0, then the universe will no longer expand, but then the universe will create so many baby universes inside black holes. They will basically carry on the cosmic DNA of our universe. That's another idea for another time, because then we can connect that to Sloan's idea of basically having the ability of the universe to be passed down from mother universes to daughter universes. Now, one of the main problems with the Big Bang theory is that at the moment of the Big Bang, there is a singularity of zero volume with infinite energy, but this is solved with this minimum size of space-time, 10 Planck lines, which gets rid of infinite energy, infinite density, and things like that. So this would not be the end of physics as we know. And this is why we expect for quantum gravity to become important in avoiding the singularity. Quantum cosmology shows that previously existing universe collapsed, not to the point of singularity, but to the point where the quantum effects of gravity became so strongly repulsive that the universe rebounds back out, forming a new branch, a new cycle. Throughout this collapse and bounce, the universe and the evolution of it is unitary. Some properties of the universe that collapsed form ours can also be determined. But some properties are determinable due to uncertainty. The uncertainty principle, of course, is important. It's been partially weakened. It's an idea that we can actually determine both position and property and location of an object, but it still is at least somewhat workable. Now, with time being cyclic, our universe will eventually stop expanding and then contract. Before becoming a singularity, as you would expect from black hole theory, the universe would bounce. The reason why it bounces is because singularity violates the law of thermodynamics, so it has to bounce in order to avoid that. And the big crunch would be avoided because gravity becomes repulsive at those small sizes and create a new Big Bang. In this case, actually, it bounce. Now, just because the universe is cyclic doesn't mean the exact same thing is happening in each universe. Each cycle of the universe. The histories of all these pyramids. The reason why is, there's certain random things that change from each cycle. So there's no reason why you would have an exact copy. It's at different timelines. There's something that's going to be a little bit different. Nikodime Popolowski was one of my favorites in terms of being able to show that quantum mechanics and relativity can be combined. Showed that black hole cosmology universe and black hole cosmology universe actually unifies relativity and quantum mechanics. This creates a way for an interaction to avert the Big Bang singularity, replacing it with a cusp-like bounce and a minimum scale factor of 10 Planck lengths, before which the universe is contracted. This scenario explains why the present universe at its largest scales appears spatially flat, homogeneous and isotropic, providing a physical alternative to cosmic inflation. Now, cyclic models do the universe in different states. To simplify the view uses two states, high energy and low energy. Possible energy. One is the expanding state and one is the contracting state. Now, once the universe contracts far enough, it gets re-energized, causing a big bounce. The entropic state of energy will reside in a lower energy state, meaning that the act of energy moves to the true vacuum. This would cause the universe to spontaneously tunnel to the true vacuum, and this is the energy that's actually fueling the big bounce. Now, string theory, and specifically the string theory landscape of 10 to the power 500 different universes, also predicts with each cycle of the universe taking about 1 trillion years, 10 to the power 12. The amount of matter and radiation in the universe is reset. But the cosmological constant is not. Instead, the cosmological constant gradually diminishes over many cycles to small values where kilograms continue to decrease. One of my favorite models that I've been working with is the Compton model, which uses dark energy. Now, the way it works is this variety of dark energy is called phantom energy. In this model, just before the universe gets torn apart, a turn-on occurs and only one hollow patch is replaced. That's our universe. This scenario has no particles, no quarks, no leptons, no first only dark energy. And this entropy thereby vanishes. The adiabatic process of contraction in this much smaller universe takes place with constant vanishing entropy of no matter, including no black holes, which disintegrating will turn around. This is the general idea of the universe coming back empty, and avoids many difficulties confronting matter and contracting things, such as excessive structure formation, proliferation, expansion of black holes, as well as going through phase transitions, or quantum thermodynamics, or electroweak symmetry restoration. Any of those would have produced an unwanted premature bounce simply to avoid violation of the second law of thermodynamics. This surprising condition may be logically inevitable in a truly infinite cyclic cosmology, which is the entropy problem. Now, black hole cosmology, which is the idea of the universe inside a black hole, is popularized by Nikodem Pawlowski. And this argues that the Hubble radius of the observed universe is equal to its Schwarzschild radius, product of its mass. This is indeed known to be the case, and is not a coincidence, even though some have considered it as such. Nikodem Pawlowski showed how this unifies quantum mechanics and relativity. The observable universe is the interior of a black hole existing as one of many, possibly many, inside a large universe, or multiverse or omniverse. According to general relativity, the gravitational collapse of a sufficiently compact mass forms a singular Schwarzschild black hole. It actually forms a Einstein-Rosen bridge, or wormhole. Schwarzschild wormholes and Schwarzschild black holes are different mathematical solutions of general relativity. For distant observers, the exteriors of both solutions, same mass, are indistinguishable. Einstein theory extends general relativity by removing a constraint of the symmetry and its asymmetric part, and it becomes a dynamical variable. Torsion naturally accounts for the quantum mechanical intrinsic angular momentum spin of matter. The minimal coupling between torsion generates a repulsive interaction. This interaction prevents the formation of a gravitational singularity. This is what creates the big bounce. The always is connected. Black holes, big bounce, cyclic model, everything is connected. Instead, the collapse of matter reaches an enormous but final density and rebounds, forming the other side of the wormhole of the Einstein-Rosen bridge, which grows as a new universe. Accordingly, the Big Bang was a non-singular big bounce, at which the universe had a finite minimum scale factor. So all of this is brought together by quantum cosmology, 10 minimum Planck discrete size for space-time. This is all has been discussed in my book, going all the way back to when I first started writing it back in 2009. 4 years now. So, what do you mean? Nikodem Pawlowski actually studied at Indiana University to give a background on him. And this is what he's most widely noted for, that our universe may be located within a black hole, which is itself consists of an even larger universe, or superverse as I call it. This proves that black holes are not gravitational singularities and solves a lot of the paradoxes in physics. And also the quantum, the cosmological constant problem, which low non-zero value is solved by the universe being cyclic. It provides a theoretical explanation based on space-time torsion for a cosmological scenario of universes that was also for Lee Smolin in his quantum evolutionary or cosmic evolutionary formula. This was why our universe has life in it. It's basically something that it inherited from a previous universe and it can pass down. Now, based on the analysis of Einstein's theory of gravity, as a result of torsion and particle spin, Pawlowski suggests that when matter density reaches more than about 1,050 kilograms per cubic meter inside a black hole, torsion manifests itself as a force that counteracts gravity. And that rather than forming a singularity, it quickly rebounds like a coiled spring to which pressure has been applied. Pawlowski theorized that this extraordinary level of torsion may account for what is observed as the current extension of a flat, homogeneous, and isotropic universe, the prevailing explanation for which is known as cosmic inflation. So this all takes place. Inflation. The rotation of a black hole will influence the space-time inside it. Black holes, remember that, black holes, which I discussed in the first part of the series, resulting in the preferred direction within our universe. And of course, if there was a complementary universe, it would be the opposite direction. Also explains the arrow of time being in opposite directions. And therefore, Pawlowski suggested that observable anomalies in the rotation of spiral galaxies and violations of symmetry, Lorentz symmetry, might provide evidence for his theory. Neutrinos, which have been observed oscillating from one type to another, have been suggested as the occurrence of such a violation. The theory further suggests that every black hole becomes the wormhole, and that contains a new expanding universe, which forms from the big bounce in the black hole. Which is part of the experimenter. Remember that. The black hole. Black holes at the center of the Milky Way and other galaxies may thus be bridges to other universes. Accordingly, our own universe may be the interior of a black hole existing inside another universe. This is mind-blowing. I will give you some time to absorb all this, and perhaps read my series. It's on Scribd. It's called the Origin series. It's also on my WordPress blog and on my show blog. So feel free to read it there. I have published the first 17 chapters on all those sites. And once everything's stuck together, there will be a full-form book. I expect it to be at least 30, maybe even 40 chapters. So I'm about a little bit less than halfway done, probably. But feel free to read what I've already written and comment on it if you want. I will continue this series at a later time. I think it's just enough for now. So have yourselves a great day. And I will update you when I think to add more. Stay tuned. Hi all, this is Lucky Part 13 of the FE Intro series. And in this, I will discuss a couple of things that I was remiss not to mention earlier. One was the actual shape of the universe. Now, going through different types of shapes of possible ideas that the universe was, we came across two that were particularly interesting. One of them was a sphere, which would be expanding outward from the center, the so-called center, which actually does not exist. The sphere would only be the universe on the surface, and the center would be where the big bend or big bounce occurred, and expanding outward from that point. Now this would be a four-dimensional sphere, also known as a globe or hypersphere. The other shape is a torus. Torus is a donut. Again, the center would be where the big bang or big bounce occurred, and it would actually be the surface of the torus and expanded outward. Basically, the shape of the universe depends upon whether you look at it as something that has a boundary, in other words, it ends somewhere, or it does not have a boundary. Now, the fact that the universe, if it doesn't have a boundary, does not mean that it could be a four-dimensional version of the Earth, which is that if you keep going in one direction, you end up back where you started. That's my theory. And looking at the different shapes, one that particularly stuck out to me was one that Roger Penrose, the famous physicist, found interesting as well. It is the Hopf vibration. It is a shape that comes up again and again in quantum mechanics. And the reason why it called out to me is when I looked at this shape, it basically looks like a bundle of fibers extending outward from the center, emerging, getting further and further apart from each other, each fiber separating, going to a maximum length as it expands, and then slowly converging back in towards the center again. What does this remind you of? It starts telling me like what the different fibers of timeline of the universe would be like as we expand outward with a big bang, a big bounce, reach a maximum point, and then converge back in. This is exactly what I believe the universe looks like. Looking at it as a whole from the outside like that clearly shows that all versions of time, all the timelines, past, present, futures, all coexist. But this is not something that can be experienced unless you're outside the universe. It also shows that the different timelines are separated in second dimension of time. And the center, it's not just where the big bounce occurs, that links us to our parent universe or superverse, just like string theory predicted. When you look at the universe that way, larger universe. So making them velocity predicted. And of course, our universe is regenerating its own daughter universes that would spin similarly and have similar shape to ours. All universes like this, we don't know. There can be some random conditions or other situations, mutations even, just like there's biological mutations. The universe take different shapes. Some of them might not be so stable, might not last very long, might collapse that but it's all quickly, depending upon their own air conditions, like the four forces and having different values, states, etc., etc., etc. But this is what I believe our universe is like. Alright, that was the shape of part 13. What do you know? Next time. Hi, this is part 14 of my SE intro series. And in this part, I also have to make correction to warp scale in space engine spaceships. Earlier, we had talked about the logarithmic scale, which is true, it is a logarithmic scale, it's just not based on the number 2, it's based on the number 10. So, for example, warp 6 would be 1 followed by 6 zeros, or 1 million times the base speed. Not the speed of light, the base speed, which is the speed of the conventional engine. So multiply that by 1 million, and you get a warp factor of 6. The conventional limit of the spaceships is the warp 12, and 1 followed by 12 zeros is 1 billion. So that would be 1 trillion times the conventional speed of the engine, of the main engines in the ship. Conventional. The highest I found is 10 to the power 20 number is that would be trillion is 10 to the 12, you know, quadrillion is 10 to the 13, and trillion 10 to the 18, that would be 100 quadrillion times the speed of the conventional ship. We only found a couple of ships that are at speed the highest, the latest, and highest end ships. The Enterprise, the these ships are strictly for interstellar space travel, will not be used to fly planets because they're I don't go crash right into the planet. You don't want to go little. Okay, thanks. See you all next. Alright, so this is part 15 of the Ixs intro series. In this one, I'll just postulate about what actually causes the universe to be generated inside a black hole. Now, it could just be the spin of a pure black hole that causes it to happen. Or, there is another theory out there which has been supported by supercomputer simulation. The collision of two supermassive black holes, which often happen when two galaxies interact. For example, the galaxy energy it is the largest galaxy we know of, being over 1 trillion stars. Giant galaxy. It has swallowed so many galaxies whole. And what happened is their black hole collapsed into the black hole of the sun. So the energy, the action of these large galaxies colliding and coalescing, the black holes combined, receive, could be the force of energy that is needed to generate enough spin. Here's a torsion necessary to generate black holes inside the second conventionalized particular inside the black hole. Supermassive black hole that you got. It could also happen with super ordinary black holes. Swallowing club for partner star. And that's I mean, maybe the amount of matter that this amount of energy that they consume can decide what type of university. So they're asking to classify it as one of this what do you like? The blue, the probability, and the simple mathematical background as simple. That might be going away. And to grow in you got to see that one of the black holes will keep coming superstructures to make it to 2,050 million over for a feeding cycle. Example, with DNA. Of the creators of the cycle. We will have something like this. What is over from the cycle? Alright, that was for 15 series. This is part 16 of the Ixs intro series, and just a quick update. The hot vibration we discussed earlier, part 14, and the wormhole at the center of it. Now, is this reversible or not? Possibly. Don't know yet. Your simulation show that if you open energy, that actually happens. But other studies have shown that it hasn't been especially if you have plenty of examples. But that's another possibility. The other interesting is you could actually have, instead of just two universes that are complementary, you could actually have four. So you would have a universe, obviously you have a complementary universe, like the antiverse, with the antimatter, with the first principle, and the complementary dimension would stay some time, CMY for RGB, so light back like light and dark. So it would be subtracted while R is added. But then you also have mirror matter. So you can have a mirror matter universe and a complementary mirror matter. In other words, mirror matter universe. R is the state for time, RGB for the spatial dimension, for time dimension. You have one for the spatial dimension for light, for the time dimension, for the first layer of time, in the negative mirror universe. That way, instead of two universes, you have four universes of the same form. And at least between these four, you should be able to theoretically converge them. So that is indeed a possibility. Now, perhaps going outside of this, if we're different, the universe outcome or the Clover structure will differ or Clover. That is like a possibility. Yeah, we will further explore. Thank you all for part 16 of the Ixs intro. Part 17 of the Ixs intro series. After the 17 chapters of the book I have completed so far with the origin series. In this part we discuss the four-way railroad shape of the local omniverse that I just described in the previous chapter. Now, each of these, the universe, the antiverse, the universe, and the anti-universe, would all be leads and slowly further follow their shapes to the top vibration connected to the center of each, which is where the original Big Bang, Big Bang, etc. But each of these will be hot vibrations with their own separate timelines emerging and converging by infinite. The universe and the universe would, since they both flow in the same direction, they would go through that out at the same time, while the antiverse and anti-universe would undergo it on outdoors. So these are conventional. Usually here, journey through the different timelines, through some timelines, as well as their dimensions, especially going into the anything outside of that, local omniverse, it might be either 4 or 6 according to string theory, and it would still likely be bubble the energy to go to the center. Speculative and how is this necessary? Chapter 17 of the Adscft. Hi guys, I just wanted to describe the way starry night classifies planets that are habitable. Now, we're talking about planets that contain Earth similarity, like say Iona, to be habitable in the southern moon. You'll find that in the header comes up display there are 4 different types of habitable planets. There's unicellular, typical life, unicellular conventional life, multicellular conventional life, which are both organic types, and unicellular and multicellular exotic life. The difference between the unicellular and multicellular is self-explanatory. Unicellular simple, single-celled organisms, multicellular would be like plants, animals, etc. Now, conventional life and exotic life, the exotic life would be inorganic life, like carbon, like arsen, working treated to do silicon, which is the same periodic element as carbon. So we have to look out for that, any kind of life that looks like it's a mineral, that's standing out, different colors, like purple, etc. We would kind of look for where on Earth that would likely be exotic life. It could be like in the air, aerial life in the atmosphere, which could even be organic. So you have the unicellular organic, organic, unicellular exotic, and basically, like I know the one, honestly, we can't tell what that. We have a problem, we have limited exploration, area. We got to know first is people who have. As a matter of fact, also we would show that other kinds of animals will likely to know better suitable for like the purpose of basically read those kinds of the surface, like maybe like doing more about that than your mission. Hey, so I'm doing a new version of part 19 of the SE intro series because I have some exciting new information to add. This is concerning the Alcubra drive and the fact that new information has come to light that it no longer requires negative energy. Now, let's go back a little bit. The Alcubra drive gets around the relativity limit of the speed of light by compressing the space in front of the drive and expanding the space behind it. Therefore, you reduce the distance to your target without exceeding the speed of light. That way, you get to your destination faster than light would because the amount of space in front of you is decreased since it's compressed. The only issue, the only barrier was you need negative energy in order to do this. Now, to create negative energy, a warp drive would use a huge amount of mass to create an imbalance between particles and antiparticles. For example, if an electron and an anti-electron appear near the warp drive, one of the particles would get trapped by the mass, and this results in an imbalance. This imbalance results in negative energy density. Alcubierre's warp drive would use this negative energy to create the space-time bubble. But for a warp drive to generate enough negative energy, you would need a lot of matter. Alcubierre estimated that a warp drive with a 100-meter bubble would require the mass of the entire visible universe. The Harold Light we talked about before reduced this amount by changing the shape of the warp drive into a ring with a different amount of volume, larger volume compared to the surface area on the outside. So now, with the updated numbers from 2011, you now only require the amount of negative energy that's the mass equivalent of the spacecraft Voyager, which is a significantly more attainable goal than the mass of the entire visible universe. Trust me on that. But now, we have a new update. Based on research conducted over the past year, and a couple of recent papers, you might not require any negative energy at all. Eric Lentz provided a solution that seems to bring warp drives closer to reality. He proposed a solution that does not require negative energy. He used a different geometric approach to solve the equations of general relativity, which, after all, rely on geometry, the shape of the universe, the curvature of space-time. And that geometry changes depending on perspective. And this is exactly what he did. By changing his perspective and using a different geometric approach, he found that a warp drive wouldn't need to use negative energy at all. His solution, Eric Lentz's solution, would allow the bubble to travel faster than the speed of light without negative energy. Very important. Now we have to point out that these exciting developments are mathematical models. You can't fully trust models until we have experimental proof. Yet the science of warp drives is coming into focus. It's getting clearer by the day. This is innovative thinking in the highest form. And in the words of Captain Picard, things are only impossible until they are not. Now, I wanted to quote from this paper. It's an excellent paper published on March 9th, 2021. Breaking the Warp Barrier, Hyperfast Solitons and Einstein-Maxwell Plasma Theory. This is the paper that I'm talking about. And here's an abstract from it. Solitons in space-time capable of transporting time-like observers at superluminal speeds have long been tied to violations of the weak, strong, and dominant energy conditions of general relativity. The negative energy sources required for these solitons must be created through energy-intensive, uncertainty principle processes, as no such classical source is known in particle physics. This paper overcomes this barrier by constructing a class of soliton solutions that are capable of superluminal motion and sourced by purely positive energy densities, so no negative energy required. The solitons are also shown to be capable of being sourced from the stress energy of a conductive plasma in classical electromagnetic fields, also very important, very conventional sources. This is the first example of hyperfast solitons resulting from known and familiar sources, reopening the discussion of superluminal mechanisms rooted in conventional physics. This is truly groundbreaking, and that's why I quoted it for my series. And this will be the next breakthrough in warp drives that I can't wait. Hopefully the engine that I designed will be able to take advantage of this new breakthrough, and we can hit the ground running. Or flying, in case it goes that way. So that is the exciting portion of the update. Now, we're going to get to the more, I would say, mundane part of the update, but also pretty interesting. And in this part of the update, I am going to talk about Space Engine's bottom right menu, which I had not discussed previously. Bottom right menu gives us the ability to do certain things to the display. Now, basically, when you look at the display, it's a type of camera, virtual camera, actually multiple cameras. But the display itself, the main display, you can change its settings as far as HDR, auto exposure, and exposure compensation are concerned, using the plus minus buttons in the bottom right menu. So you can suit the exposure to taste. I usually leave it on auto exposure and HDR because I like the maximum dynamic range. I love it down and adjust the exposure accordingly. But you can change it, like if it's nighttime on the planet and you want to see your surroundings, you can adjust the exposure and compensation to account for that. Or decrease it if you're near a really bright sun and you want to decrease its brightness to reduce the glare. Now, there are other plus-minus indicators in that bottom right menu. One of them is for the field of view, which is another camera term, or telescope eyepiece term. If you increase the field of view, you're zooming out, so you see more with the camera. If you decrease the field of view, you're zooming in. It's like using a zoom lens. And there, you actually see a smaller field of view, but everything is magnified. Now, the magnitude, plus minus, refers to the magnitude of stars or other celestial objects. When you increase the limiting magnitude, you see more stars, dimmer stars. The field can become crowded, also have a bit of an impact on resources. And more memory is required to display the extra stars. And likewise, when you decrease the limiting magnitude, you only see the really bright stars, and that's less impactful on resources. Use less memory. Now, back to FOV for a second for the field of view. This also applies to spaceships. So when you're like in the cockpit of your spaceship, and you decrease the field of view of more of a zoomed-in view, so you don't see the borders of the cockpit windows, for example. And if you increase the field of view, you zoom out. So basically, your console and things like that look smaller because they seem further away. And you see more of the cockpit area. That might give a more pleasant view. A lot of the ships in space engine, while it does have a default view of 45 degrees, if you're doing a cockpit view, they look a lot better from, let's say, 65 to 80 degrees. The maximum, of course, is 120 degrees. And the minimum is you can pretty much go down all the way down to 1 degree. And as far as the magnitude, the default limiting magnitude is 7, and you can go that as you want. I have my Gaia add-on installed for 13th magnitude, so that's the highest that I would go. Or you can go all the way down to what's called first magnitude, so you only see the 20 brightest stars in the sky. Alright. That's very important here. You only see the brightest stars. Okay, guys, so that is a summary of the exciting new breakthrough in our Q-Braze warp drive, and also the stuff about the bottom right menu, which I don't use a lot, so I decided to update that part now. Now, as far as the exciting new developments with the warp drive are concerned, I will put all that information, the articles, papers, on my WordPress blog, on my Twitter, on my Shutterfly, and on my script. And those are the locations where you can find my writing, my book, 20 chapters, with a ground treat introduction and conclusion, and other material, reference material, and sources for my writing. Everything is kept up to date, and since this is a quickly evolving field, keep checking back, because it will always keep changing. Okay, thank you all for watching the series, and next will be for the time being, the last part of the series, part 20. And please forgive me, I know I sneezed a couple of times in the episode. I was suffering from ragweed, since I have been recording this in my garden, and the ragweed is active. But as you see now, since this was recorded after part 20, I am going to just, I figured I'd leave the sneezing part in part 20 because it was pretty amusing. I would wake any of you up who were bored by my solo 3. So, we'll talk to you soon, and I will keep updating this as time allows, and new information is provided. See you all later. Feel free to comment on any of my social media about this link. Oh, and my YouTube videos. Take care. This is part 20 of my healthy intro experiment. And this will be the last one for a while because I just wanted to complete the last chapter that I've done in my book so far. This one is about the Fractal Universe. Now, when you look at the universe, it seems similar on many different scales, which is quite intriguing. For example, the structure of the atom, the structure of the solar system, the structure of the galaxy. They all have a small, dense nucleus. In the case of the solar system, it's the sun. In the case of the galaxy, it's the supermassive central black hole. And in the case of the atom, it's the nucleus, with the proton. And in all three cases, they are orbited by even smaller bodies. In the case of the atom, electrons. In the case of the solar system, it's the planets. And in the case of the galaxy, it's the stars. So you see, they're all very similar on different scales. Now, different forces do this as far as keeping everything intact. In the case of the atom, it's the nuclear force. In the case of the solar system, it's gravity, and it's gravity and dark matter in the case of the galaxy. But it's interesting that this structure is what the universe has settled upon as being the one that is basing everything off of. This practicality also extends to our brain. When you compare the substructure of the brain to the structure of the universe, the superclusters of galaxies, they are startlingly similar, especially in terms of how matter is arranged and how synapses and neurons are arranged in our brain. It actually matches what dark matter has done as far as organizing the structure of our universe, and dark energy with large gaps or synapses in between. What does this all mean? Well, I've been saying for a while how the universe, in order to understand itself better, this is how. With structure that's practically built so similar, intuition could work in this way, because our brain structure resembles the structure of the universe so remarkably. The universe understood itself through us, and used intuition to achieve great leaps of logic. And not only that, also be able to tell when something might happen before it actually happens, since all past, present, and futures coexist. So it should be able to climb the temporal landscape and see further ahead. In addition to that, you notice how clusters of galaxies are networked and connected to each other? Human brains could be like that also. Our brains could be nodes connected to other humans. The humans who are closest to us, our family, our close friends, etc. We can tell when something is about to happen to them first, because they are the ones who are connected most closely to us, even if not physically, emotionally. And this is exactly how quantum entanglement works. Two particles so closely connected, and when something happens to one, it immediately happens to the other, no matter how far away it is. And this brings me to the concept of how this occurs. Micro wormholes in the quantum form at the very basic level of the universe, these tiny holes that can transport virtual particles basically anywhere in the universe, no matter how far away the entry point and the destination point might be. This is how quantum mechanics works. Why space and time don't really mean anything at the very basic level, because everything is connected through quantum tunneling and information transfer, microtubules, and quantum entanglement. This is how our brain could work also, and how we could actually get information, and why we separate sources in an instant. Another example of this is a neutrino particle called the sterile neutrino. The sterile neutrino actually can travel backwards in time, it is theorized, because it makes use of quantum flow. And neutrinos come in three basic flavors. It's sterile neutrino, it's the fourth flavor, which might be a kind of dark matter. And it can travel through quantum flow, but actually be able to reach its destination before it left. It's not like a paradox, but it actually works with multiple timelines. Causality wouldn't be violated because it could usually travel between the timelines in the second temporal dimension. Which would explain how and where dark matter hasn't been detected if it comes from other timelines, and maybe even other parts of the fully clover multiverse. We just don't have the need to detect particles like that. Yet. But with our dark matter detectors, eventually we should be able to detect changes in causes in its surroundings. Now, I want to also illustrate how all principles are connected that we talked about. The universe being inside a black hole, inside a larger universe in particular, is actually closely connected to the holographic principle. The holographic principle states that the universe is a 2D surface on a black hole in a larger universe. How does this work? Well, think of the universe as a simulation. The third dimension was actually created on the surface of this black hole. That's perplexing, but think about it. If the universe is expanding, maybe it's expanding into this larger universe's next dimension. If it's a 2D surface, then the point of origin or the big bounce would be in the middle of the black hole, and the surface expanding outward, and the actual universe itself. Now, for this surface to be two-dimensional, it means the other dimension is created by the superverse. And so we cannot experience that directly, at least not yet, until we create our 3D space-time bubble. It would be very much like the allegory of the cave. We are shadows. That's how our information is transmitted. We are shadows of the world of the cave. That's how we experience reality. We don't get to see everything. No, we see things. What lies beyond it. The underlying elegant universe. Created in simplicity, eloquence, arising with elegance. Now, another point of how everything is connected is the Hopf vibration. The Hopf vibration is composed of linked choruses, as I have discussed in the 4-week global multiverse. This is how everything gets transported between our local multiverse. All the 4 Hopf vibrations connected to each other through the central wormhole, the big bounce area, is how everything gets transported, and the different time verses are the time rates and particles. Yes! So everything gets transported back and forth through the time verses. which makes it really interesting and how everything works. Another interesting point is that black holes unify all forces within, which is why they seem to be singularities. Now, going back to the idea of black holes containing universes, black hole cosmology, the reason why they seem to be singularities is because start of the universe, everything was unified. The first symmetry broke. All forces are dimensional one. Since we can't see that far back yet, listen what they seem like. Listen what the universe looked like at the beginning. And when we look into a black hole, we are seeing the beginning of a new universe, frozen in time, because we are on the outside looking in, so we cannot see what's happening inside as the internal universe, the big universe is expanding and changing. That symmetry is breaking. We have our frozen moment in time from the outside looking in, just like anyone who is in the superworld looking at the black hole that's spawned our universe would see us. They would see us as a hot vibration at the very beginning stages of development. That is what our computer simulations have shown. This is why, at that instant of time, black holes duplicate everything. That's what they look like. And back to the idea of the hot vibration being composed of linked toruses or linked over multiverses. The greatest evidence of that is the fact that our Planck family and our other studies have shown that torus is exactly what a universe looks like. And vibration is a link, connection between different toruses. In this case, there will be four, which makes it so intriguing. And of course, the center would be the wormhole that we have been talking about. That transports everything throughout the local or-leaf multiverse. Actually, we should be calling it a super wormhole, which is bigger, greater, than the original wormhole of the entire structure. And I would like to thank everyone for listening and watching. And there is a particular thing I would like to say about how magnificent our universe is. It takes our breath away. How great it is. And you can extend that to the omniverse. It has a beauty of its own. Like a fractal, whose repeating patterns create unexpected combinations of complexity that retain hints of the underlying original. Based in simplicity, yet evolved into elegance. Thank you all, and remember to watch me on the Science Channel. I will have a 20-part series that summarizes the 20 chapters of my new book about the universe and beyond, the origins of the omniverse. Also find me on Scribd and WordPress and Shutterfly, and be sure to read the comics. Oh, and don't forget to watch my YouTube videos and read the comics there too. And you can also find me on Twitter and Facebook. So I hope that you enjoyed this series, and will read the book and watch my videos. Thank you all. Hey guys, I am doing an unexpected but much needed part 21 update to SE Intro and my book, origins of the omniverse. Because I realized that there were a few things I left out. When I was talking about the algeometric warp drive, I need to mention that there is no time dilation associated with it. Because there is no acceleration to or past the speed of light. Dimensional speeds happen inside the space bubble. The way that simulated cyberluminal velocities are done is by contracting space in front, expanding it behind. It reduces the travel distance, so FTL is unnecessary. Now, this is good news because it means that time passes at the same speed for those outside and inside the bubble. So it would be just like any conventional trip. Time would pass at the same rate for the astronauts and for those who stayed behind. Now, I also need to discuss the model that shows how this is possible. It comes from a discovery from a few years ago about negative absolute zero temperatures. This is very important. And it sounds like an oxymoron. How could you have temperatures below absolute zero? Well, this is how it happens. It basically creates a simulated antiverse, which is opposite to ours, but instead of with regards to time flowing in the opposite direction, it's temperatures. The more energy you add from our perspective, the lower the temperature seems to go. This is the other side of absolute zero, just like the antiverse is the other side of the speed of light. This provides a model that shows how we can do hyperluminal velocities without actually going faster than the speed of light. What we do is we jump from our universe to the antiverse inside the space-time bubble and then back again. This will give us a simulation of faster than light travel. It's like a tangential curve. The tangential curve goes up, doesn't quite reach the asymptote. In this case, the asymptote is the Luxon wall or the light speed barrier. In the case of a negative absolute zero temperature, it's actually absolute zero, which cannot be reached or crossed. It has to be jumped over. So we need to jump over that, because that is the asymptote, get into the antiverse, and then jump back again. Using this, not only can we do FTL, but we can also do time travel, since time in the antiverse moves in the opposite direction. And the way we avoid the paradox is we just re-enter the timeline. Because time has two dimensions according to the Cartesian coordinate system. And when you jump back, time has already flowed, and then you end up in a different timeline. So there are no paradoxes. Now, speaking of the Cartesian coordinate system, we can apply it to the four-leaf clover multiverse model as well. The way you do that is you consider each axis, instead of them being both for time, for imaginary time and for conventional time, it would be for space-time itself. So the upper right quadrant would be our universe. Positive space and positive time. That's the additive RGB color model of space, and the black model for time. All additive. The antiverse would be directly opposite ours if you do a reflection on the origin, which is where the bounce of the wormhole are that connects everything. Diagonally opposite to ours, negative space and negative time, the complementary dimensions. So C and Y for the spatial dimensions and white for time. So time flowing backwards according to our perspective, but still forwards relative to themselves. It's like that conveyor belt model I talked about, basically facing forwards in the direction in which time is moving. which is relative forward, just like ours is. Then you have the other two universes as part of the model, which I've already talked about, the mirrorverses. There is the normal mirrorverse and the anti-mirrorverse. In the normal mirrorverse, you have minus space and plus time. So you would have CMY for space and Y for time. Now, since this is positive time, this is the universe directly under ours, so it shares our positive time value and expands and contracts and bounces right along with ours. But since it's below ours, it's the negative space. Then you have, and that would be, by the way, that is the lower right quadrant. Then you have the upper left quadrant universe. This is positive in time. Oh, sorry, it's negative in time. Sorry about that. Negative in time, but positive in space. So this would have right as the direction of time, and RGB as the dimension of space. So plus space minus time. This syncs up with the anti-verse or the anti-mirrorverse. And this one would extend and contract and bounce with the antiverse. So basically you have the universe, the mirrorverse, the antiverse, and the anti-mirrorverse. If you go counterclockwise starting with ours. So quadrant 1 is our universe, quadrant 3 is the antiverse, quadrant 2 is the mirrorverse, and quadrant 4 is the anti-mirrorverse. And the origin point is the master wormhole. It connects everything together in the middle. And that's the point which is never reached. Big bounce basically contracts close to it, and then gravity becomes a repulsive force in 2 dimensions and expands outward again. So 1 and 4 are in sync, and 2 and 3 are in sync. So they expand and contract and bounce together. So, and by the way, so these are 2 different Cartesian coordinate systems. One is for the multiverse, and the other one is for the origin point of our universe as it bounces, and all its time verses as they expand with inflation. As they're expanding with inflation, the reason why these time verses were created in the first place is because inflation expanded space faster than the speed of light. And so everything separated outwards, and this is where all these time verses come from. They are separate from each other. It's a second composed dimension which runs perpendicular to our time and keeps the singularity from happening at the origin point. And this would be the y-axis, or our time is the x-axis. Just like in the other case with the fully multiverse, the x-axis was time itself, our time, and the y-axis is space, the spatial dimensions. So imaginary time in this case is the y-axis, while dimensional time is the x-axis. So all the timelines separate because of inflation, expansion faster than the speed of light. They diverge, they reach a maximum point as our universe expands into a fourth spatial dimension and the hypersphere globe, and then they hit the wall of the couching horizon of the black hole, in which all 4 of our universes are nested, according to black hole cosmology and Nicolas-Bobrowski's unification theory of relativity and quantum mechanics. And then the universe starts contracting again, and the timelines converge in the second temporal dimension of imaginary time according to Stephen Hawking. And when we have deflation and we finally all combine back again, the bounce when gravity becomes a repulsive force in 2 dimensions. This is why Roland's idea of entropic gravity controlling everything is correct. The universe basically comes back empty with its dark energy. The band fractal model combined everything connected together, all the different models. And this happens in sync with our universe and the universe. While the antiverse and the anti-universe are in some people. Quadrants 1 and 2 working together, 3 and 4 working together. They're in sync. So 1 and 2 and 3 and 4. They expand together, inflation and contract together, deflation and bounce together. It's like a 4-way seesaw, where 2 of each are in sync with each other, doing things at the same time, and the lever in the middle is the master wormhole that connects everything together. The traffic cop, the backbone of the fully polar multiverse. Yeah, we can journey within in order to go to different points, and maybe even outside into the superverse and other baby universes, branches of that with their own wormholes inside supermassive black holes. Now, this model, since everything's connected together, it's basically nested on top of each other. And there's no singularity because the big dots result from a previously contracted universe, just another iteration of the cycle, with a cosmological constant draining downwards with each iteration, but it keeps winding down. So eventually we'll stop expanding and contracting, and then basically, for lack of a better word, it'll die, but it will have the baby universes to transfer the cosmic DNA to. Now, with the superverse, of course, the superverse is the umbilical cord, and its DNA transferred over to our multiverse, and that also will have its own folder, whether it's 4 leaves or more, or maybe even less, maybe even 2. We have no way of telling at this point. We will one day, and maybe one day we'll travel there. And who knows, maybe we'll figure out that our universe was generated by a hyper-intelligent alien race inside that superverse. I mean, it's not God, but it's a serviceable concept of a cardinal scale 3 race within its own universes. Maybe if we don't extinguish ourselves, we will reach that point one day also. One can only hope. So, once again, we don't cross over the light speed barrier, we jump over it, just like with absolute 0 temperatures. You jump over and everything is reversed relative to ours, but forward relative to itself. Important point. Now, as far as the wormhole is concerned, there's actually new evidence that we don't need negative mass or negative energy to hold the wormhole still open. It's a new breaking evidence that's really interesting and something I'll be looking into for future editions. So if you can hold the wormhole open without negative energy and negative mass, that makes traversable wormholes a lot easier. And maybe we can even make our own except the large hadron collider, so we can make micro black holes. At least just to test it out and then maybe scale it up to something that we could use. So that would be an interesting point and something I will tackle in future editions of my work, my book and these audio files. So I hope you enjoyed the latest update. I will try to make this one the last one for this edition. 21 parts is quite enough. Basically 7 days a week for 3 weeks in case you don't listen to one every day. And I hope you enjoyed the series. We will converse again when I decide to continue this series, which will hopefully be when the sequel will be great. Thanks for your time, and please feel free to leave comments on my WordPress, my Twitter, my Shutterfly, Facebook, etc. And my YouTube, of course, when you watch these videos and listen to me. Alright. Done for now. I need to do a quick update after I just did part 21, so this will be part 22. Still going. Now, in part 22, I realized that I haven't completely described all the dimensions that we're working with, so I'm going to go into that now. We had already discussed the additive dimensions and the subtractive dimensions of space. So basically that's 6. RGB, CMY. Symbolize those. Then we have the 2 time dimensions, which would be white and black, flowing reversed compared to each other. So that's 2 dimensions of time. We have a total of 8 dimensions using this. So we got both dimensions of time covered, but in M theory and S theory, there's a total of 12 dimensions. There's 10 of space and 2 of time, so we still have 4 more to account for. So where do these 4 extra spatial dimensions come in? Now, first of all, I also need to mention that there's been research done in JCER, Journal of Consciousness, where it's discussed that the mind, by analyzing brainwaves, seems to function in 8 dimensions. That covers our 8 dimensions, 6 of space and 2 of time. But there's an additional 4 spatial dimensions to account for, to cover M theory and F theory. By the way, that JSON article, it's quoted in my origin. These 4 extra spatial dimensions. Well, there's also other color models that we can use, for example, complementary colors for these 4 extra spatial dimensions. Could comprise these, and as such they would still have either white or black, but these universes, white or black for time, but these universes would have a different geometry compared to ours. And likely they would not follow the 4-clover multiverse model because they have a different number of dimensions, so different number of universes in each set. It could be that we have even more dimensions than these 4 extra ones. We could have 4 complementary sets, in which case we would have a total of 14 spatial dimensions and 2 dimensions of time. Now, if that was the case, then we have a total of 15 dimensions. And that would be interesting because each of those universes would comprise 6 total dimensions, 4 space and 2 of time. It's quite possible you could see these extra dimensions manifest themselves along a z-axis, so a 3-dimensional Cartesian coordinate system, in which case those multiverses would consist of 8. Since there's 2 for each axis, so basically it's 2 times 2. For us that's 4, so we only have x and y, our Cartesian coordinate system. And for these other universes, if they're on the z-axis, it would be 2 times 2 times 2, or 8. Inversion. Since of course we haven't detected any such things yet, it's a sheer speculation, but it would be really interesting if this were the case. Because string theory does promote 4 and 6-dimensional universes. Even though it did not originally predict the extra dimension of time, we could get those 4 and 6 in another way. This is the way to do it. And then you add the extra dimensions for the complementary colors as well as complementary time, white and black. So, to summarize, we have our universe, which is 3 plus 2, is now measured space and time. Space plus time. So, always holds true throughout our local multiverse and the other multiverse. You would have 4 plus 2, 4 plus 2, 4 plus 2, 4 spatial, 2 temporal. Different geometry, different number of universes, each multiverse. 4 hours, 8 of that one, extra dx. It will be x and y, space of time. There will be x, y, and z. What the z would stand for, I'm not sure, but that's 2 times 2 times 2. They will be complementary to each other. So basically, the space axis, the time axis, will be complementary. Or complementary space time axis, if you want to put everything together. So I will leave that for future cases. Now I'm actually going beyond my origin series, which is a sneak peek at what the sequel will contain. Now, how I will use a color model, and even additional primary colors, like for example, certain species of shrimp have 12 primary colors. That's absolutely amazing. You can see far more into both the infrared and the ultraviolet than we can. They're called mantis shrimp. And we'll analyze the extra colors and how they could create new multiverse units. And how many multiverses they might contain, what the shape of those universes and multiverses might be. We won't be able to folders. And if they're traversable through our multiverse unit, and how our wormhole could actually connect to other wormholes in these other types of multiverse units, just like we have small wormholes in our own universe that connect to our master wormholes. So the rivers basically form through the ocean, to the ocean. The bulk that contains all the different multiverses being the ocean, and each multiverse unit being an island in it, and these master wormholes being rivers that flow through the island into the sea, connecting everything together like a vast highway system. It almost reminds me of how slime molds actually build architecture similar to our own on a much smaller scale, of course, everything being fractal. But the fractal brain mimics the universe and the multiverse, everything is connected together. All creatures are sentient, even inanimate objects like the rocks in the planet itself are sentient. Just the consciousness spread out over a larger area. The planet's fossils are actually its memory system. Stars are like the heartbeat, blood circulation, the galaxy itself, it's like a fractal huge version of the human body. Each star is a blood vessel. Central black hole would be the brain. Each star would be its own life-supporting blood vessel capillary system. Arteries, veins, capillaries. We even have stars of both colors. The blue stars, veins, the red stars, arteries. And black holes of our moon, the red stars are the ones that are much more likely to support life as they last much longer. The blue stars here. Star classification system ODAFG came M on M back. You would remember this O be a fine draw to see right now, so it's going for blue violet, blue, which would be O green, A is white, F G yellow, K orange, M on and S red, go all the way to carbon stars. Examples, blue would be Red and Rigel, and green, and type O would be Nalos and orange, Rigel, and then type N would be sort like Beetlejuice. It's also one. Our seventh source of type G would be yellow. Series, the white star, the brightest star in the sky. Type A, white, and Proceo, the little dark star, to Sirius, big dark star, little white, type F. Arcturus, Greeks, diverter, orange, type K. We already discussed Beetlejuice, type M, and then RNS, which is sort of like the garnet star. And I can see everything type S, and Granite star leaves at N. Here's a carbon stars. Those are charcoal red. The light support stars are, of course, type F, G, K, and M. Like as we know, there could be like other type stars even in interstellar space like minerals, dust, inorganic, organic life, etc. That's with the statement of the series. So, we can go to the beam simulation and see where I think this even in the upper atmosphere gets transferred. Or it can be either organic, inorganic, multicellular, or unicellular. Or it can be just interstellar space, where we have found organic molecules like formaldehyde and hydrocarbons. So life can be completely anyway. And the one components of Compton, the sun is formed. Maybe from supernovas, where you get elements that needed iron, even some synthetic elements that we can only separate from the lab or formed by supernova explosions together in prisms. And you also have, of course, ultraviolet radiation permeating through space, exciting electrons, creating new atoms. All very interesting natural radioactivity. Other source, fission, fusion, hopefully something we get fusion power, similar to the way the sun and other stars work. It's the helium, and then to carbon, nitrogen, and oxygen, and finally to iron, which is where it all constitutes a halt. It's too much energy to go beyond that. You don't see that in stars. And once you get to supernova explosion, in which case everything fuses, and then you get the levels above 100, like Emirates, like Kitty in California, etc. There's also the case we have natural radioactivity on Earth as well, which is interesting. Those are natural fission reactors, which we already have. And now, as far as these elements are concerned, a lot of these elements inside our bodies, I mean, even gold, silver, precious metals, form inside supernova explosions. Hydrogen is only more prevalent throughout the universe. They're very common. These other ones are created inside stars, either through natural fusion processes or through a supernova exchange. That's where we get our oxygen and our nitrogen. And when you look at the nebula, you can tell by the different colors what the energetic, for example, nitrogen and what the green, red, oxygen. Those are the two most common. Hydrogen is also there. Helium is yellow. I'm sorry, it's yellow. Because has so much helium after hydrogen fusion. So anyway, we're getting off topic here. We'll just close segment 22 and encourage you to read the origins of the Omniverse series on Squid, on Shutterfly, on WordPress. Please feel free to leave comments, and of course on YouTube to the audio version. Thank you very much. I hope to see you on my social media, Twitter, Facebook, etc. Interact with me at any time. Okay, so part 23, since I forgot to include something in part 22, of course I forgot about type W stars, which go in front of all the violet purple color right there. Maybe green stars are the only ones that don't exist because color green is right in the middle of the spectrum. So stars that are supposed to be green, like type F, actually end up being white. You can take all the different colors and add up to white. Type W stars, those are like star Gamma Velorum. Wolf-Rayet, it's the hottest stars. Purple colored right instead of O, so it becomes wow, O, you find Europe kissing right down sweet, starts with W instead of O. Okay, so what this update was actually all about was, since we discussed universe or multiverse units with 8 together, or octaverse, compared to our tetraverse, the octaverse would have a total of 6 dimensions, it needs a 4 plus 2 instead of our 3 plus 2. Now, what this could also mean if there would be more fundamental forces. We have space-time for 4 dimensions without including imaginary time. 4 fundamental forces, the electromagnetic force, probably nuclear force, and gravity. So the universes, they have a different number of fundamental forces. We just don't know. The gravity would have to be fundamental in all universes across the omniverse. If it comes from the bulk, the outside, or the middle displated, why it has to be unified the inputs that will theory of gravity. But aside from that, these extra universes, these off-universes, they also have a different number of fundamental forces aside from gravity, of course. We just don't know, and hard to speculate on something that we never experienced yet. But, if you ask me, I would say that if we have 4, since we have an extra spatial dimension, they should have 5 fundamental forces, 1 that we don't have. Beyond that, speculate, and I think I will be doing a part 24, so look out for that in the very near future. Hi all, this is part 24, which is most definitely my last recording series. For this, this is the first book, the sequel will start later, so we'll get to that. But I wanted to grab something on the last original origin design, library and triple, and identifying the number of total dimensions. So now that we have, if we combine the tetraverse and the octaverse, we have a total of, let's see here, I believe it adds up to 15 dimensions. Let me count the spatial dimensions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14 spatial dimensions and 2 dimensions of time. And we know triplets are arrangements of continuity. So the way that we get to the Pythagorean triplets in this is we create the z-axis that creates the extra axis. Form a Pythagorean triangle. So basically, the type of universes that you have, 3 and 4, which 2 of the basic Pythagorean triplets are covered. 3 spatial, 4 spatial. Now you have 5. Where does the 5 come from? That is 3 plus 2. That's our universe. But you also have the 6. Where would that come from? Well, since that is an octaverse, we would use that a little bit differently. So basically, 6 squared is 36. 8 squared, the octaverse, is 64. That adds up to 100, which is the square root. So basically, we have a whole new system. 3, 4, 5, 6, 8, 10. They're all triplets. We already know where the 8 comes from, that's the octaverse. Where does the 10 come from? Very interesting. So we have 2, 4 plus 2 universes. 2 dimensions of time in each of those octaverse universes. 4 plus 4 is 8. So 8 spatial dimensions, 2 temporal dimensions, that's 10. That's where the 10 comes from. It's like our 3 plus 2 and 5. 3, 4, 5, 6, 8, 10. Everything works according to Pythagoras. Each dimension being perpendicular to the one before. XY tetraverse and XY the octaverse. That's how it all works. Everything being connected together. We have the basis for a real workable design theory. So after 24 2 dozen parts. I hope you're happy with the range of the series. In my origin sequel, we will cover different types of consciousness and intelligence. Everything from elephants, morning to dead and burying them, to dolphins communicating. Chimpanzees and bonobos and gorillas make tools and keeping their own pets. So we will examine and parrots, after great parrots, who can count, even understand the concept as well, and see if I can now just go question. We will outline different types of brain, what could be out there in terms of both organic and exotic life, intelligence, cellular sentience, both planets, on planets, moons, and in space, and the sharing of genetic material with intelligent species on many different intelligent species of multiple planets in a system of the TRAPPIST, one system. Very difficult with all those different planets, including 7 or 8 now. So we will go more into detail about that, and go into more detail about what the octaverse might be like and some other concepts I haven't printed, as well as more updates on the Adscft Correspondence and space entry. And my own plan for how to extend the series in the future. More about the Hertzsprung Russell diagram, colors of stars, their classification, evolution of galaxies, supermassive black holes growing in the universe, and superstructures growing in the universe that indicate we come from the previous cycle of the universe, DNA holdovers from that universe, as well as how the DNA gets passed down from parent to baby universe, or from superverse to multiverse to baby universe. And the river of material, how that gets transported through hormones, which are the circulatory system of the universe. And about gravity and how it functions in the bone and is the muscle of the universe. So, this is all fascinating stuff. And of course, one of the fundamental forces where we came from the constant, how they changing them might create different types of universes, different shapes of universes, which don't, which get on the arrival, which very much align, and with different cycles, all of that will be covered when they start learning Untitled, which will be the origin of it all. Hope you stay tuned for that and enjoy it. And when I get started on that, I will let you all know. And you can give me some feedback on how the series should proceed. Thank you all. Please feel free to leave comments on my Scribd, my Shutterfly, Facebook, my Twitter, my WordPress, of course, and my YouTube videos. Here, we'll see you. One quick update, I wanted to do a promise that's going to go out for part 25. This is for the original Omniverse series. This is about cosmic strings. An interesting topology of the universe that we have actually discovered these cosmic strings. It's the part of space that are one-dimensional in the early part of the universe, which shows how our universe is one-dimensional with cosmic strings and two-dimensional with very high energy cosmic rays that are only at 2 degrees of freedom. This is the stage in our universal history where gravity was a piece of force, and that's what the universe was supposed to be understanding. All this will be analyzed further in my sequel origins. And we'll also talk about exotic objects like quartz stars, which are basically in between neutron stars, black holes. Stars only composed of quartz, and maybe even Creon stars, which would be quartz with matter. So you have quartz, 3 different types of quartz, and gluons which connect them together. Of course, the 3 have their complements, so it's almost like dimensions. So the 3 ratio and their complements, the 2 types of quartz. So that's and then you have prions, which are more fundamental than quarks and are basically building blocks of quarks. And one of those might be 3, or they can be like the octolobes at the 4 the top of the tree. That would be another layer to the omniverse. 3 for quarks and their complement 3, and then 4 for prions and their complement 4. That would be very interesting. And if they have their own bunch of particles, which would be more basic for the gluons, and I don't even know what they would want to call them. Maybe call those gluons, which would be very interesting. So yeah, so basically it's that, and if that, it actually there are 8 total pairs, including layers, including the complements. We have the 3 plus 3 for the quarks and the 4 plus 4 for the prions, and you get 14 right there. And then you have the 2 the gluons, which would be for time, and then you would have the truon, which to my point, for what keeps prions together. And then basically a microcosm version of the tetraverse and the afterverse right there. And of course they would both be functioning according to strong, which would force which is like the rubber band, or maybe the prions that take the extra force that we're talking about. That would be still things like the afterverse. Basically they're like a rubber band, those forces. Very tightly pack those together, but the further away you get, the stronger the forces get. That's why you can never actually see 3 quarks or 3 prions for that matter. Because unless you have enough energy to make that rubber band snap, like maybe you don't want to try to call it the other they don't exist as free particles. But analog to this is the few corresponding conventions, that this is the reason why we have space-time around the tetraverse and afterverse. Because these particles, it could be these particles in parts of the tetraverse and the omniverse and the octoverse on its own. So each particle could be its own universe. So being in the black hole cosmology, because you have micro wormholes and micro black holes and these particles exist. And therefore, the universe on many different scales. Typical space-time. Back to the original. Space, time, sign, matter, all of that is relative. So you can start in one universe, go down in scale, but pick up right back where we start. So like, you start at the North Pole, you go south at the North and South Pole, you go back around, and you end up right back where you started. That's what we play with the whole time including the other. Including all the different words and okay, so this is really the end of 2025. Feel free to leave comments on my social media, or you know my WordPress, YouTube, Scribd, Facebook, Twitter, Enterprise, and YouTube, of course, where my videos are. Okay, and I'll have to do the special part in a sequel dedicated to the number 137, which seems to be very special, but it's not just for the value of the electromagnetic force or gravity, or the fact that that's the new number of where we'll get qualified with definitely very limited because many implications with physics and cosmology, which I will get into in a minute. By the way, wait, we get 137. That will look pretty. Everyone, I talk to you soon. Hi, I just needed to do one last quick update, part 26 of the SE intro series, and wanted to reiterate that according to the Pythagorean triplets 3, 4, 5, 6, 8, 10 are the 2 that we're working with, and the 4 and the 3, 4, 5 signifies the tetraverse, which is the multiverse we belong to, and the 6, 8, 10 signifies the 8 in it signifies the octoverse, which is another possible combination with 4 plus 2 dimensions in each universe, inside it. So basically, you would have a total of 8 spatial dimensions and 2 time dimensions. That's where you get the 10 from, of course. And then in our universe, we have the 3 plus 2, which is where you get the 5 from, and the 3, 4, 5. And of course, the 3 spatial dimensions. And in the Octoverse, you would have a total of 8 spatial dimensions. So you also got that in the 6, 8, 10, plus the 2 time dimensions, of course, in the 10. And this is not to say that there are other combinations possible. As a matter of fact, Bosonic string theory has 26 spatial dimensions. And this is part 26, so it's very fitting that we concluded with this. So there could be other Pythagorean triple combinations, and of course those universes would have their own number of fundamental forces and their own number of universes in their multiverse, etc. Different shape, of course, not the 4-leaf clover, or the octagon, or the 8-leaf octagon of the Octoverse. But basic wormhole, master wormhole idea, and the timelines, and the bulk, of course, all of that would, and the wormhole and all of that would be the same. And of course, you have to add dimensions for the bulk. The way gravity works, gravity would connect everything together through the wormholes, which are the rivers, the lifeblood of the entire omniverse. So yes, that is the way that would work. And look for my sequel to Origins, which will show how all of this is put together and how everything is connected together, cyclical in both space and time. Gets you right back to where you started. Okay, thanks for listening and watching, and feel free to comment on any of my social media, of course. And look for the book on my script, Shutterfly, and WordPress. And of course, the audio is on YouTube. And my social media, Twitter, and Facebook. Okay, thank you for listening and watching. We'll keep you updated. Okay, so doing a quick part 27 and part 28. Part 27 is once again going to clarify Pythagorean relationship in the Tetraverse and the Octoverse. 3, 4, 5. 3. Number of spatial dimensions in each member of the Tetraverse. 4. Number of universes in the Tetraverse. 5. Total number of dimensions in each member of the Tetraverse. 3 plus 2 is 5. Okay, now 6, 8, 10 for the Octoverse. 6, the number of total dimensions in each member of the Octoverse. 4 plus 2, 6. 8, number of total universes in the Octoverse. 8. 10, total number of dimensions in the Octoverse. 8 dimensions of space, 2 dimensions of time. Again, there could be other possibilities of the Bosonic string theory. We have 26 dimensions. You could have more triplet combinations with their own shapes for the universes, numbers in their combinations, and also different fundamental forces. They all have gravity and wormholes in common, and timelines. People are there, of course. Okay, this is the end of part 27. Going to do one more, and then call it a day. The final part of the first book of the Origin series, part 28. Just want to make one more thing clear about the Pythagorean triplets. The numbers can stand for multiple things. Since our Tetraverse has 6 spatial dimensions and 2 temporal dimensions, This is a total of 8. You can also put that into the 6, 8, 10. So in addition to the octaverse, it's also symbolic of the number of dimensions in our tetraverse. And it goes right alongside the 10 total dimensions of the octoverse. 8 plus 2, 8 space 2 time. Okay, so that goes there. And of course, the other options we already had. So 3, 4, 5, 3 spatial dimensions in each member of our tetraverse, 4 spatial dimensions, and 3, 4, 5 for each member, spatial dimensions for each member of the octoverse, or of course it could also be symbolic of the tetraverse. So we made that clear, so we have multiple options for each number. And of course we also have the 6, 8, 10. And in that, we already did that. So we have 4 plus 2 for the octoverse numbers for the 6. And of course, the 6 could also stand for the total number of spatial dimensions in each member of the tetraverse. So the 3 RGB and the 3 complementary CMY. So we sorted that out, and that should do it for part 26. Contact me on social media, you already have it, and leave comments, YouTube, WordPress, Scribd, Shutterfly, Twitter, Facebook. Remember to watch the videos on YouTube. Thank you very much. And just another note real quick. The sequel to Origin is now being worked on. I gave you some nice little nuggets in here, some Easter eggs for what might be coming up in the sequel. Where you talk about lots of different things on how they're connected to each other, lots about fractals, of course, universal building blocks of the omniverse, wormholes, distribution of matter, virtual particles, bumping, how it resembles the structure of our brain, as far as the structure of the omniverse goes. Wormholes are like our capillaries, arteries, and veins, etc., etc. And of course, Gaia and the nature of collective consciousness that includes planets, stars, the whole omniverse, and how the omniverse created us in order to understand itself better. And when we're creative, we actually fulfill its ultimate purpose. Since that was what the omniverse does. So we're more closely connected to it and to each other. Of course, quantum mechanics, quantum tunneling, quantum brain theories, quantum consciousness, quantum biology, also linked to photosynthesis, and inheritance, DNA, genetic transfer, of course. Lots and lots and lots coming up. So look out for that. That will probably also be another 20+ chapter book and audio version, as well as videos. Thank you, take care, and hey guys, it's part 29 of the SE intro series. This one is about string theory landscape. String theory landscape predicts that there are a large number of bubble universes that exist throughout the book. As a matter of fact, the string theory landscape predicts that there are 10 to the power 500 of these universes. Is it accurate? We don't know yet, but at least it makes a prediction. And string theory landscape has been right about many things, including the idea of a multiverse depending upon these bubble universes expanding into their own space. So, stay tuned. String theory landscape will also be correct about the prediction of 10 to the power 500 universes. So back in. Hi guys, this is part 30 of the SE intro series, and this will be the last one for the first book of the Origin series. This one we're going to talk a little bit about Technicolor and color theory. Now, as you know, we talked about the color narrow being used to describe strong nuclear force with regards to gluons, keeping quarks together. It's like protons and neutrons. Basically talking about a third of a charge, third of a whole. And as the three quarks are combined, the gluons keep them tight, like a rubber band. The further apart they get, the tighter the bond. You need a lot of energy to snap that rubber band. You also have positive and negative quarks, quark and anti-quark. So, same charge, different time. These make up mesons, so there are two of them. These are also located like gluons. Now, when looking at the color model, we understand that there's more than 3 primary colors when it comes to some very sharp-sighted creatures, like the mantis shrimp that have 12 primary colors. Not only can they see into the infrared and the ultraviolet, they also see polarized light. And they can also detect colors with human beings either cannot see or can only see for a short instance of time, called the possible colors and imaginary colors, and the special kind of colors called chimeras. For example, for the color planets complement like red and green at the same time, or blue and yellow at the same time. We just don't have enough of the right kinds of clones of it on to see these colors together. But mantis shrimp do, they have enough for 12 different primary colors, so they can see possible colors and imaginary colors of chimeras. Very much like a second dimensional time imaginary time. It exists perpendicularly to our conventional time, and these colors perpendicularly to our conventional colors that we see. Given that, technicolor theory and also quantum thermodynamics are theories in quantum mechanics that describe how these tiny particles called quarks behave according to the color model. We also have quantum electrodynamics, which shows how the electromagnetic force behaves on a quantum scale. All very, very, very interesting. Now, all this will be covered more in my next edition of the Origin series sequel, so be sure to stay tuned for that. It was a pleasure doing this 30-part series. I hope that it was very informative, meaningful, and be sure to check out my social media. Twitter, Facebook, WordPress, Skype, Spotify, and of course my YouTube videos. Leave comments, and we can interact. Until next time, this is the conclusion of the first part of the Origin series, with information about space engine profession. By the way, with space engine, don't forget, you can use a resolution up to 8K. Don't forget to get into the Pro version, unlock those extra features. Take your high resolution videos and screenshots. Take care. Hi guys, I was supposed to end the Ixs Intro series after 30, but I needed to add a couple more thoughts, so we're doing a quick number 31 and a number 32. And then this is the first about the universe and its relationship to the antiverse, and also the asymptote, which is a Russell wall. Now, I had explained earlier that the antiverse has reverse time compared to ours, or ours in reverse compared to them. The residents of each universe experience time to go relatively to themselves because they are facing forward in the direction they stare about this. In a similar way, the Fractal sees us as tachyonic, superluminal, while we like that. Which means we can jump there and then jump back and appear to be traveling superluminal. Well, they can do the same thing. They can jump to our side and then jump back. And so, create a time machine which creates a paradox because we land in a different timeline, because we're going across 8 seconds to 12 dimensions, but also superluminal, because our timelines can variables and move opposite world of each other. Of course, you would have to carry a bubble with their own space-time, and they would have to do a similar thing to be able to make this trip and also avoid matter, antimatter, annihilation. And to meet each other for both space and time warp. The other thing I want to talk about is stellar neutrons. Speaking of backwards time travel, they are unglued from space-time. They only respond to gravity, not the other three forces, so they can travel backwards in time. We also have universes at different energy levels, and basically the universe being both cyclical in time and space. We can actually collect energy from a higher energy universe to such low energy universe and then create a time pump, which is something that actually has an outlet in the gods themselves. They choose to simply more about that. Very interesting. Now, back to quantum mechanics. Quantum spatial and temporal entanglement existed since the cosmic age of the universe, and maybe even previous cycles of the universe. That's why they still continue after the universe expanded and will continue indefinitely. There are 4 layers of omniverse and the 4 people very much number of dimensions and fundamental forces. We have another layer of 4 axes, which would be 16 numbers of multiverse, and they would this axis the A-axis. That would be another layer beyond the Afterburner. And maybe 15, 20, 25 billion triplets for bosonic string theory, only including the spatial dimension. So, this is the latest update. I will be doing one more, and I assure you, until the sequel is written, we'll be done. Thank you, and hope to read your comments. Okay, this is Part 32 of the Ixs Enterprise Origins of the Omniverse, and I will make this the last one until I make the sequel. This one is specifically dedicated to quantum entanglement. The experience of fast-moving travel and quantum mechanics that occurs across the entire universe, with brilliant significance connection shared across both time and space, and might also cover other universes which would be like the quantum entanglement. Quantum bridging, which would mean that each universe is its own quantum. This would especially occur within each multiverse that might be afterwards and 16 months, but could occur also outside of the quantum bridge established will go. Now, there's both spatial and temporal particle universally and continues and expands when new particles are made. So more connections, just like brains, are developed and connected to each other. This is through a network where the quantum mind theory gives us a tuition at the Institute. And this is an example of the universe of the omniverse itself being fractal compared to our own brains in its own way, which we already mentioned earlier in terms of how matter is current. It's similar ways neurons and synapses throughout the algorithm. Additional matter, additional content was also developed and will have its own collection of information by the trace of very easy. But primordial black holes and supercosmic galaxies are very old so really quickly. Even with the memory of these structures from the past state. Which would be really interesting because it would repeat the way the universe reincarnate itself with the memory of its past. Practically, we know what that might mean for us as well. But that would be extremely interesting. Or if the practice of dark matter and dark energy is to do with this into the future of moves that we could travel freely throughout the universe. Or it's gravity and and now in the 16th verse, we could possibly have additional forces, additional constants, and should not possibly possible. That is something to think about. There's also the basic order. The basic order is symbolic. The fundamental dimension that's the most quantum order. Not all of these universes and omniverses and tetraverses and octoverses, 15 verses, multiverses are built on. And everything is just like quantum verses. Which is a fractal representation of quantum stuff. As well as quantum quantum teleportation, microworlds and quantum form. All these things that can transport particles both spatially and temporal. If we can limit ourselves with large particle shapes, that would be really special connections. You look like micro black holes from the outside, which are also where matter, energy, seemingly opposite into and out of the world journey traveling with the whole universe throughout the structure. It makes me wonder if it just simply kept going and then it would come on its own and create its own dimensions. Maybe that's how our universe itself is after being created. Filling the universe with purpose. Wouldn't that be something? I would tend to think that that is the case. And the way that it was done when we were created, we will do when we see this new artificial multiverse. It does the word artificial really be created. Mainly, the reason why we consider artificial is usually because that's how our universe is created. Nothing is very artificial because we are all a part of it. And the universe created this understanding. Therefore, we would all be. It's all natural. We don't know if the structure of this would work or if it could do with that. I suspect it can, but it would involve some kind of instrumentation or we would penetrate these dimensions and the whole realm space time. Cyber is not a matter either. Cyber world. So they look like a tiny little particle or a massive black hole, but in reality, it would be a universe created from the wrapping stuff around each other with no boundary. We could journey inside it just like with our own universe. Space-time bubble. Create our own dimension inside it. Perhaps we could do something through the modeling and see how it works, and tweak the parameters of the special constants which of course is not relative to each other, and see if the interactions like our sequential other stuff. Perhaps by tweaking these parameters, we it like I use the words or not like I use the words? And that might even be very but I'm excited. With the image be transferred from our universe to that universe. It would be much more iconic. Okay, so I am done with type 32. This will be the last one before I get to go to the Origin series. I hope you enjoyed it. And leave comments on my Facebook, Twitter, etc. WordPress, and YouTube. Which are my videos. So if you're reading them, hope to communicate with you. Hi everyone. I am doing a part 33 of the Origin series and Msi intro update. The reason why is I have been doing a lot of analysis of some recent theories that have come out, and they are in the Origin series. I can proudly say I anticipated many of them, and they're also going to be discussed in more depth in the sequel, which basically picks up right where Origin 17 left off. So first of all, I wanted to once again reiterate my multi-layer structure to the omniverse that consists of formulations of Pythagorean triplets, beginning with the 3, 4, 5 basic triplet, which is the 3 plus 2, total 6 plus 2 tetraverse, and is also covered by Karuza-Klein theory, Randall-Sundstrom 1 and 2, and Yang's Mills. These are all multi-dimensional theories of everything. Now, the next layer is the 6, 8, 10 octoverse, 8 plus 2, which covers supergravity, superstring theory, M theory, and 6-dimensional Calabi-Yau manifolds. That is where the octet exists. Now, 9, 12, 15, which is the next level up, includes the previous layers plus the bulk. Now, the interesting thing here is that besides the bulk, it also includes F theory, which has 2 dimensions of time. But the fact that there are 8 total colors in quark gluon pairs means that must be left for a different level to incorporate. So we go into the next layer, which is 12, 16, 20. Now 12, 16, 20 is another multiple of 8, so that 8-color quark gluon pair, which is covered in the 6, 8, 10 configuration, is also covered in the 12, 16, 20 configuration. This is where the 16-verse F theory with its 2 dimensions of time resides. And there is an extra axis. There's the x-axis, the y-axis, the z-axis, and the a-axis. So 3, 4, 5 only have the x-axis and the y-axis. 6, 8, 10 has the x-axis, y-axis, and z-axis. And 12, 16, 20 has x, y, z, and a. Now, when you combine all of these 4 layers and include the bulk, you get the 25 and 20, the 25 spatial dimension bosonic string series. That is covered with the 15, 20, 25 final triplet. That incorporates the entire omniverse. These are energy levels with universes on each level having similar levels of energy, and also factually similar to electron shells and atoms. Now, you also have the fact that these resemble quarks and gluon pairs. And normally we only think of 3 quarks in an elementary particle like the photon. But you can also have combinations of 4, which is a tetraquark, 5 pentaquark, and 6 hexaquark. And these are reflected in the 3, 4, 5, and the 6, 8, 10. Now, each higher triplet is a higher energy version of the basic 3, 4, 5 triplets, which is at the lowest level. And this explains why gravity is so weak at a basic level versus the others. The more dimensions you have, the stronger gravity gets. Now, going back to quantum chromodynamics for a second, because this theory is very related to that. Remember, we developed a duality here with a strong force and gravity. And let's go into that now. There are 12 total quark-antiquark pairs. They can switch between any of 3 RGB colors for quarks and 3 CMY colors for antiquarks. Very related to my theory of dimensionality in the universe, which also uses cosmology. Now, gluons contain both RGB and CMY paired together. That's how they mediate the interaction between quarks and other quarks and antiquarks and other antiquarks and quarks and antiquarks. Now, this is the core part of the discussion. PR equals BPR is something I anticipated 3 or 4 years before it happened. I anticipated it in 2009, it happened in 2013. It combines with the holographic principle as entanglement between boundary space of exterior black hole interior describes our whole 3-dimensional space in 2 dimensions. This is very important. It's like a quantum bridge between the boundary, between the superverse, which exists at the boundary of the black hole that we reside inside, and our universe. And this is why that surface of that black hole contains all the information of our entire universe. Now, many worlds theory combines with quantum superposition to produce multiverse time verses across both dimensions of time. So basically, each universe is like a quantum particle. It's the same quantum particle in multiple positions, which is called quantum superposition. The time-verse multiverses casually separate as they become entangled with their own environment, so they become their own distinct versus separated from each other across the second temporal dimension. Now, we have to go back for a second to EP, or ER equals EPR. What this stands for is Einstein-Rosen bridges, which is wormholes. Basically, wormholes solve the EPR paradox that Einstein conceived to try to figure out why quantum entanglement exists. The answer is that microscopic wormholes in quantum foam enable spooky action at a distance, which is what quantum entanglement is. That's how action can happen instantaneously, but space-time is causally connected with each other. And as it combines with the holographic principle, which shows that 3D space can model on a 2D exterior, it shows how everything combines together to produce this result. And that is the most important part of it is quantum entanglement. Let's remember that. We can still travel across timeless multiverses from the second dimension of time, which separates the different time-verse macros. Basically, we travel between these time verses. There has to be a way to travel across that second dimension of time. So we land on these different islands, so-called islands, which are really different time space-time manifolds. They're all basically the same universe, but in quantum superposition of each other, so they're different parts of the same layer that they exist on different manifolds. If you picture different islands in the same sea, and each sea is its own layer. Space-time is produced by quantum entanglement, which results from micro wormholes across quantum foam. And quantum entanglement is fractal with wormholes, which means that quantum entanglement is the same thing as a wormhole, just on a different scale. Smaller scale wormholes to larger scale. or macro wormholes at the larger scale, and quantum entanglement is a micro wormhole. Gravity is emergent. That is important. With EPR, ER equals EPR, gravity is emergent and entropic and naturally arises from quantum entanglement of spacetime. So ER equals EPR, what does it do? It combines gravity with quantum entanglement. This is exactly what we've been seeking, a theory of quantum gravity. And where does it come from? Quantum entanglement. And it arises naturally. It's not something forced like classical gravity would be. It actually is there right from the beginning. This was first formulated by Juan Maldacena, who is previously well known for also figuring out the Maldacena conjecture duality. And of course the holographic principle, which is related to ER equals EPR. Now, Maldacena's conjecture was actually the first step towards ER-EPR. This duality, what it did was combine gravity with quantum field theory. And it was one of the most quoted papers in the last 20 years. Why? Because it showed a way for a theory of everything. It wasn't the theory of everything, but it showed the pathway towards developing one. And this was the duality that showed the relationship between gravity and quantum field theory. The other important duality it showed is the Adscft Correspondence. Now what this is also extremely important. This relates to Maldacena's conjecture in the sense that it shows that gravity can naturally arise from quantum mechanics. So you don't have to go looking for it. It's a magical additional thing that came from some other manifold. It actually arises naturally from quantum mechanics. And that is what the Adscft duality proves. All of it related. All of this combined under the umbrella of the holographic principle, which is really interesting, because that shows how the holographic principle actually works. Because the boundary, the outer layer, is quantumly entangled with the inner layer. This, by the way, also solves the black hole information paradox problem. So basically, all the dominoes are falling. How does it do that? Well, if the particles on the outside of the black hole's event horizon are entangled with each other, they can also be entangled with the particles inside the event horizon. And how is that? It's because they were entangled from the beginning. And so what happens is they can actually mirror each other's state, even though one set is outside the event horizon and the other is inside. In other words, no information is lost. That connection holds. So that solves that paradox. And that is a very easy solution to something that many have been searching for decades. Which, by the way, it was interesting. ER and EPR, both formulated by Einstein and a couple of his colleagues. If he had lived maybe another 10 years, he would have probably come up with the same conclusion. But it took another 80 years after him for someone else to do it. Also a very brilliant theoretical physicist. Juan Maldacena. Now, the important thing about quantum entanglement is it solves this issue which quantum mechanics has with space-time. Because quantum mechanics shows that space-time is dynamic, if quantum entanglement didn't exist, space-time would be torn apart. Obviously, it's not. It's stable. And the reason is that quantum entanglement is the glue which holds everything together. Otherwise, space-time would tear apart because it is dynamic and always moving. Now, the other interesting thing is, with all these timelines, it means more entropy. And in a way, entanglement and timelines can be considered as increasing entropic energy. With time, the timelines become more numerous and the entanglement becomes stronger. That corresponds to a rise in entropy. So the three are intrinsically related and can possibly be considered different expressions of the same thing. Now, as we've discussed before, because of the degrees of freedom, we've discovered very high energy polarity of quantum cosmic rays. Space-time is two-dimensional at the time scale. And space is fractal, and time is an emergent property that naturally arises from it. Big news. Negative mass has been discovered by Washington State University in plasma. I'm going to read that article in a bit with the details to follow. Negative mass makes it possible for micro-wormholes to stay stable, and those formed early on in the universe could be expanded to traversable sizes by inflation. Total energy in multiverse always stays the same, as amplitude of each time verse gradually drops with time, the total energy inside each time verse is conserved. In higher dimensional space-time, gravity is much stronger, and black holes become more important in the structure of space-time and can be produced by particle colliders like the LHC and, naturally, by cosmic rays, which makes it interesting for black hole theory. Which, by the way, it seems that there is a possibility that micro black holes and wormholes could contribute to the issue with dark matter, and could also contribute to why we can't see it, because they're so small, but they add up across the entire universe. Now I'm going to go ahead and read some excerpts that are cogent to the issue. First one being extra dimensional space. In higher dimensional space-time, the strength of gravity increases more rapidly with decreasing distance than in 3 dimensions. With certain special configurations of the extra dimensions, this effect can lower the Planck scale to the TeV teravolt range. Examples of such extensions include large extra dimension special cases of the Randall syndrome model and string theory configurations, like G2T solutions. In such scenarios, black hole production could possibly be an important observable effect of the LHC. It would also be a common natural phenomenon induced by cosmic rays. Interesting. Like some more dark matter issues. ER equals EPR is a conjecture in physics saying that two entangled particles, a so-called Einstein-Podolsky-Rosen or EPR pair, are connected by a wormhole, or Einstein-Rosen bridge, and may be the basis for unifying general relativity and quantum mechanics into a theory of everything. Now, quickly going into the Higgs boson, which I hadn't discussed earlier, but there are interesting issues with that now, because there is a composite possibility that it's not an elementary particle. The composite Higgs boson arrives naturally in top color models, top quark, basically. These are extensions of the standard model using a new force analogous to quantum chromodynamics. To be natural without excessive fine-tuning, to stabilize the Higgs mass from large radiative corrections, theory requires new physics at a relatively low energy scale. Placing new physics at 10 TeV, for instance, the model predicts the top quark to be significantly heavier, 600 gigavolts versus 171 gigavolts. Now, there are other models called top seesaw models that are based on top color that circumvent this difficulty. The predicted top quark mass is improved agreement with the fixed point if there are many additional big scalars beyond the standard model. This may be indicating a rich spectroscopy of new composite Higgs fields at energy scale that can be produced at the LHC and upgrade. The general idea of a composite Higgs boson connected in a fundamental way to the top quark remains compelling, though the full details may not yet be understood, so stay tuned, as always. Now, very important, since we have been talking about fractals, and they're a big part of my origin story. Fractals in theoretical cosmology. In the realm of theory, the first appearance of fractals in cosmology was likely with Andre Lim's eternally existing, self-reproducing, chaotic, inflationary universe in 1986. In this theory, the evolution of a scalar field increases and creates peaks that become nuclei points that cause inflating patches of space to develop into bubble universes, making the universe fractal on the very largest scales. Alan Guts, to be the father of inflation, in 2007 paper on eternal inflation and its implications showed that this variety of inflationary universe theory is still being seriously considered today. Inflation, in some form or another, is widely considered to be a best available cosmological model. Now, since 1986, quite a large number of different cosmological theories exhibiting fractal properties have been proposed, while Lim's theory shows practicality at scales likely larger than the observable universe. Theories like causal dynamic triangulation and the asymptotic safety approach to quantum gravity are fractal at the opposite extreme, in the realm of the ultra-small near the Planck scale. These recent theories of quantum gravity describe a fractal structure for space-time itself and suggest that the dimensionality of space evolves with time. So basically 3D becomes 4D, 2D becomes 3D, and 3D becomes 4D. Specifically, they suggest that reality is 2D at the time scale and the space-time gradually becomes 4D at larger scales, and that explains the accelerated expansion of the universe as this new fourth spatial dimension is created. French mathematician Alan Comte has been working for a number of years to reconcile general relativity and quantum mechanics using non-linear geometry. Practicality also arises in this approach to quantum gravity. An article by Alexander Helen in the August 2006 issue of Scientific American Correspondence linked that the next important step towards this goal is to try to understand space with fractional dimensions coupled with gravitation. Try to understand how space with fractional dimensions coupled with gravitation. Work of Kant's and physicist Carlo Rovelli suggests that time is an emergent property or arises naturally in this fourth direction. The same way gravity arises naturally from ER equals EPR. The interesting connection between time and gravity again. Whereas in causal dynamical triangulation, choosing those configurations where adjacent building blocks share the same direction of time is an essential part of the recipe. Both approaches suggest that the fabric of space itself is fractal. Now, interesting thing about the Casimir effect, which is a way to show negative energy density. and traversable wormholes. The Casimir effect shows that quantum field theory allows the energy density in certain regions of space to be negative relative to the ordinary matter vacuum energy. And has been shown theoretically that quantum field theory allows states where energy can be arbitrarily negative at a given point. Many physicists such as Stephen Hawking, Kip Thorne, and others argued that such effects might make it possible to stabilize a traversable wormhole. The only known natural process that is theoretically predicted to form a wormhole in the concept of general relativity in quantum mechanics is proposed by Leonard Susskind in ER equals EPR again. The quantum fold hypothesis is sometimes used to suggest that tiny wormholes might appear and disappear spontaneously at the time scale. And single versions of such wormholes have been suggested as dark matter candidates. It has also been proposed that if a tiny wormhole held open by a negative mass cosmic string had appeared around the time of the Big Bang, it could have been inflated to macroscopic fields. Like cosmic string, that could still be around. Now, we also talked about Penrose diagrams. Penrose diagrams, which I had discussed earlier, shows how time and space coordinates can interchange within the horizon of a black hole. Space is unidirectional within the horizon, time is unidirectional outside the horizon. They're used to illustrate the hypothetical Einstein-Rosen bridge connecting two separate universes. In the maximally thin Schwarzschild black hole solution, which refers to the Penrose diagrams, or classical Schizery diagrams. These show the method of aligning the event horizons, past and future horizons oriented at 45-degree angle. Split the singularity into past and future horizontally oriented lines since the singularity cuts off. Now, the interesting thing here is it does say that you can travel faster than light before crossing the Schwarzschild radius black into flat space, and this is not entirely true. Because in a rotating or spinning black hole, you could actually have the mouth of the wormhole open outside the event horizon. That makes that wormhole traversable. But you would also need negative mass or negative energy to hold it open, but we can do that. There's actually been new evidence that shows that can actually happen. And having that wormhole open outside of the event horizon can be key to making it traversable. And of course having the negative energy density to keep it open. Now, the maximally extended solution of the Penrose diagram for the black hole, it doesn't describe a typical black hole created from a collapsed star, as it serves the collapsed star replaced with the center of the solution containing the past-oriented white hole geometry. Basically, we're talking about supermassive black holes. This is what we need to have the traversable wormhole. Now, the Penrose diagrams for solutions representing rotating and/or electrically charged black holes illustrates these solutions' thinner, couchy event horizons lying in the future and vertically oriented singularities, which open up what is known as a time-like wormhole, allowing passage into future universes. In the case for the rotating black hole, which is the curved black hole, there is also a negative universe with a complementary dimensions, the antiverse, and also the anti-mirrorverse, that is entered through a ring-shaped singularity, still portrayed as a line in the diagram. When we pass through, entering the hole close to its axis of rotation. So again, this places the opening of the wormhole just outside the event horizon. and that is because the black hole is rotating. Very interesting. Now, when describing parallel universes, the approach that suggests that there are different parallel universes where things are roughly the same and each one is mathematically on a separate space-time manifold. You can go between those manifolds when you travel back in time. Multiple timelines would allow you to travel to a different timeline without causing a paradox, but the number of timelines doesn't necessarily have to be infinite for this to work. Okay, now we get to the really big article. This is the one about finding negative mass. Washington State University physicists have created a fluid with negative mass, which is exactly what it sounds like. Push it, and like every physical object in the world we know, it doesn't accelerate in the direction it was pushed. It accelerates backwards. Ooh, reminds me of negative absolute zero temperatures. And also the Luxon wall, which separates the universe and the different directions of time's arrow. Opposite. Or forward world. Or to themselves. Opposite world. The phenomenon is rarely created in laboratory conditions and can be used to explore some of the more challenging concepts of the cosmos, said Michael Forbes at WSU Assistant Professor of Physics and Astronomy, and an affiliate assistant professor at the University of Washington. The research appears in the journal Physical Review Letters, where it is featured as an editor's suggestion. Hypothetically, matter can have negative mass in the same sense that an electrical charge can be either negative or positive. People rarely think in these terms in our everyday world sees only positive aspects of Isaac Newton's second law of motion, which of course is equal to the mass of an object times its acceleration, or F equals ma. In other words, if you push an object, it will accelerate in the direction you're pushing it. Mass will accelerate in the direction of the force. That's what most things that we're used to do, said Forbes, thinking at the design is to come. With negative mass, if you push something, it accelerates towards you. Conditions for negative mass. He and his colleagues created the condition for negative mass by cooling rubidium atoms to just a hair above absolute zero, creating what is known as a Bose-Einstein condensate. In this state, predicted by Titania, Max Bose, and Albert Einstein, particles move extremely slowly and, following the principles of quantum mechanics, behave like waves. They also synchronize and move in unison in what is known as a superfluid, which flows without losing energy. Led by Peter Engel, WSU Professor of Physics and Astronomy, researchers on the 6th floor of Webster Hall created conditions by using lasers to slow the particles, making them colder. Now, hot, high-energy particles to escape like steam, cooling the material further. Lasers trap the atoms as they were in a bowl measuring less than 100 microns across. At this point, the rubidium superfluid has regular mass. Breaking the bowl will allow the rubidium to rush out, extending as the rubidium in the center pushed outward. To create negative mass, the researchers applied a second set of lasers that kick the atoms back and forth and change the way they spin. Now, when the rubidium rushes out fast enough, it behaves as if it has negative mass. Once you push, it accelerates backwards, said Forbes, who acted as a theorist analyzing the system. But it looks like the rubidium hits an invisible wall, avoiding underlying defects. The technique used by the WSU researchers avoids some of the underlying defects encountered in previous attempts to understand negative mass. What's the first here is the exquisite control we have over the nature of this negative mass, without other complications of forms. Their research clarifies in terms of negative mass similar behavior seen in other systems. This heightened control gives researchers a new tool to engineer experiments to study analogous physics and astrophysics like neutron stars and cosmological phenomena like black holes and dark energy or experiments are currently in progress. It provides another environment to the fundamental phenomenon that is very peculiar to itself. So this is very interesting and could have application for traversal of wormholes, negative mass, or it could be release mass, negative mass equivalent to the Voyager. But hey, this is the beginning. So this is very interesting. It's also interesting that you push an object that will accelerate towards you. That's the thing. It's something that we have to get used to because it's not something that we see every day or at any time. Usually, unless experience all this experiment proved it. It's also interesting that you have to do it near absolute zero, which I expected because that is where all the weirdness begins. That's how we get negative absolute zero. Now, this phenomenon, I believe, will be replicated on a larger scale after it becomes easier to do. And then when that happens, that's when the real fun begins. We can use it to more exotic applications like traversable world, or even artificial traversable world. Now, I'm looking at string theory and different dualities, and extension of key duality produces mirror symmetry. And in many string theory models, this is where mirror matter comes in that aspect of the tetraverse and octaverse. The extra dimensions form a six-dimensional shape called a Calabi-Yaw manifold. 6 dimensions, interesting because it's part of the 6, 8, 10 triad. Now, there are millions of different Calabi-Yaw surfaces, each with a slightly different structure. The properties of the Calabi-Yaw manifolds affect the 4-dimensional physics. So we must put down the correct possibility for the physics we observe. This also will change the values of constant and the relative strengths of the fundamental forces and many other aspects. This requires a lot of calculation. Math is hard in 6 dimensions, as you might guess, but here where mirror symmetry comes in. In the late 80s, it became clear that Calabi-Yaw shapes come in pairs. For any given pair, both lead to the same physics. Very interesting for universe and antiverse, and mirrors and antimirrors pairs. We have a duality, perhaps even a double duality. Physicists could chop and change between mirror pairs, making computations more intractable. Now, we were talking about something called the Wick rotation, which is a way to illustrate imaginary time. It's a way of finding a solution to a dynamic problem of n dimensions by transposing their description in n plus 1 dimensions, by trading 1 dimension of space for 1 dimension of time. Both methods substitute the mathematical problem in Minkowski space to related problem in Euclidean space by means of transformation that substitutes an imaginary number variable for a real number variable. It's called a rotation because when complex numbers are represented as a plane, the multiplication of a complex number by I is equivalent to rotating the vector representing that number by an angle of pi divided by 2. Radians about the origin. For example, Wick rotation could be used to relate a macroscopic event temperature diffusion like in a bath to the underlying thermal movements of molecules. We attempt to model the bath volume with the different gradients of temperature, we would have to subdivide this volume into infinitesimal volumes and see how they interact. We know those infinitesimal volumes are in fact water molecules. If we represent all molecules in the bath by only one molecule and attempt to simplify the problem, this unique molecule should walk along all possible paths that the real molecules might follow. The path integral formulation is the conceptual tool used to describe the movements of this unique molecule, and Wick rotation is one of the mathematical tools that are very useful to analyze a path integral problem. Very interesting background. Now, this is from Sean Carroll's blog, where he discusses quantum mechanics and its relations to general relativity. The distinction between position, space, and momentum is not a fundamental aspect in classical mechanics or quantum mechanics, but instead reflects the particular Hamiltonian aspect of our world. It's like a holography implies that space is emergent, but in a very subtle and non-local way. This latter point is one reason why many of us are skeptical of approaches in which there are independent degrees of freedom at each space-time point. And quantum gravity doesn't seem to work that way. Now, this is an interesting thing. First time I read this about how energy is conserved in multiple timelines. So even though there are more and more branches as time evolves, the contribution of each branch to the total energy is weighed by the factors squared, and those numbers go down, amplitude squared, and those numbers go down over time as branches fill. The effect precisely cancels so that the total energy of the universe, all branches included, is constant. It's just that individual branches get thinner over time. Their amplitude gets smaller. So they make smaller and smaller contributions to the total. The thinning process is completely invisible from inside. You have no way of knowing what the amplitude of your particular branch is. It's invisible to you. The fact that the amplitude goes down doesn't mean that the world around you looks somehow less tangible or energetic. The energy you calculate by adding up the individual energies of all of the stuff in the universe, stars, planets, black holes, dark matter, etc., goes into the energy of your particular branch. There's no reason for that number to systematically diminish over time. Given the tiny changes in average energy that can happen at measurement events, the energy of the world as seen from inside will undergo a gradual random walk of gradually diminishing steps, but honestly the changes are so incredibly tiny that you never notice. This change of the average energy of the universe as seen by observers of individual branches potentially observable in experiments? In principle, absolutely yes. In practice, maybe, but it would be hard. Not particle accelerator the size of the galaxy hard, but a challenge. The trick is that one, it's extremely hard in practice to construct superpositions of very different energy states. So any hope for changes in average energy will be very tiny. Any measurement generally throws a lot of energy all over the place. It's hard to keep track of. I won't go into detail, but we can just suggest a general protocol and also specific implementation where one spinning particle is kept stationary where another travels by it and they become entangled. Then measuring the spin of the moving particle, we can change the spin of the stationary one. By measuring the spin of the moving particle, we can change the spin of the stationary one, hopefully changing its energy in the process. Not sure how feasible this kind of experiment is, but it's interesting. It's a nice example of how thinking carefully about the foundations of quantum mechanics can lead to interesting outcomes. Another interesting aspect of this is the ever-increasing number of ever-radiant branches of timelines as analogous to the ever-increasing entropy of the universe. That makes me wonder if entanglement is entropy increase, or is related in some other way. Also, similarly, if local fluctuations in energy on an ever-radiant timeline branch is similar to local fluctuations in entropy. Okay, so we've gone through all of this. This is the basic nature of everything that I've been researching over the past couple of days. Yeah, it's about 150 different articles that I've read in a matter of maybe 6 hours. So that was quite the data download, so to speak. Still trying to wrap my head around this aspect of negative math that's been discovered. Very interesting. And if anything is good, we don't even need negative math. There's reversal of worlds to stabilize them, but even though it's discovered, why not use it? And it does seem to work in the same way as negative absolute zero temperatures. It's counterintuitive in terms of what happens when it's accelerated, like going towards you instead of towards the direction that it's being accelerated in. But that's the other side of the coin, which is positive. Now, I also wanted to get further into some of these other aspects of this theory. But one of them that I wanted to get into, which I didn't get into before, was that, well, because I don't know if this works this way, but I think that it's worth talking about. Now, when someone mentions different dimensions, we tend to think of things like parallel universe, alternate realities, like this parallel to our own. But when things work or happen differently, however, the reality of dimensions and how they play a role in the ordering of our universe is really quite different from this popular characterization. To break it down, dimensions are simply the different facets of what we perceive to be reality. We are immediately aware of the three dimensions that surround us on a daily basis, those are that one that define length, width, and depth of all objects in our universe, the X, Y, and Z axes respectively. However, beyond these three visible dimensions, scientists believe that there may be many more. In fact, the theoretical framework of superstring theory posits a universe that exists in 10 different dimensions. These different aspects are what govern the universe, fundamental forces of nature, and all the elementary particles contained within. The first dimension is that which gives length, the x-axis. The description of one-dimensional object is a straight line which exists only in terms of length and has no other discernible qualities. Add to the second dimension the y-axis or height, and you get an object that becomes a two-dimensional shape of a square. The third dimension involves depth. The z-axis gives all objects a sense of area and cross-section. And volume, by the way. The perfect example of this is the cube, which exists in three dimensions, has length, depth, and hence volume. Beyond these three lie the seven dimensions, which are not merely apparent to us, which would still be perceived as having a direct effect on the universe and reality as we know it. The fourth dimension is time, which governs the properties of all known matter at any given point. Along with the three other dimensions, knowing an object's position in time is essential to plotting its position in the universe. The other dimensions are where the deeper possibilities come into play, explaining the interaction with the others, where things get particularly tricky for physicists. Oh, by the way, time, which is changed in the other three dimensions, can also be viewed as a fourth spatial dimension. So it is the effect of the fourth spatial dimension in changing the other three, making them dynamic, and that is apparent to us and perceived by us as time. According to superstring theory, the fifth and sixth dimensions are where the notion of possible worlds will arise. If we could see on through to the fifth dimension, we would see a world slightly different from our own. That would give us a means of measuring the similarity and difference between our world and other possible ones. In the sixth, we would see a plane of possible world where we could compare and position all the possible universe and start with the same initial positions as this one. That is the Big Bang. In theory, if you could master the fifth and sixth dimensions, you could travel back in time or go to different futures. This is, by the way, covered also by the second temporal dimension, in which the timelines connect. In the seventh dimension, you have access to the possible worlds to start with different initial conditions. Whereas in the fifth and sixth, the initial conditions were the same and subsequent actions were different. Here, everything is different at the very beginning of time. The eighth dimension again gives us a plate of possible universe histories, each of which begins with different initial conditions and branches out infinitely. That's why they are called infinities. In the ninth dimension, we can compare all the possible universe histories, starting with all the different possible laws of physics and initial conditions. In the 10th and final dimension, we arrive at the point in which everything possible and imaginable is covered. This is the mathematical universe by Max Tegmark. That's what this reminds me of, the hierarchy of the omniverse or multiverse. Beyond this, nothing can be imagined by us lowly mortals, which makes it the natural limitation of what we can conceive in terms of dimensions. Very interesting. again, I believe that it has a chance to be true. So, getting back to what I was talking about earlier. It's this idea of negative matter and negative energy density plus breach. And we are well on our way to traversable or improving many of these theories, which is an exciting time to be around. Now, negative mass. In the article, they reminded us that electric charge can also be either negative or positive. But what it reminded me of is that electric charge is one of those mysterious properties that could be transmitted through microwormholes. I mean, why the electric charge exists? Of course, it's part of the electromagnetic force, quantum electrodynamics, but where exactly does that come from? That can come from entanglement. We've already seen how entanglement influences color confinement for quarks. So entanglement exists on every scale. It's fractal. Unfortunately, people barely think in these terms. But, I mean, every property of a particle can be seen as a quantum entanglement solution. Now, getting back to this issue of entangled states for quarks and for gluons. These are the signals I talked about where there's 9 different possibilities, which are basically quarks, RGB, antiquarks, CMY, and gluons, which are a combination of CMY and RGB. So you get 3 plus 3 plus 3, 9. And, but since everything needs to pair up, 9 is an odd number that does not even conduce to pairing up. So instead you have 8. 8 is the max. So there's an octet. Like the afterwards. So that's how that works. That's why there's 8 colors. And cool. Now, I'm going to wrap this up by quoting a couple more articles that I've been reading, which I found interesting. Which I thought you all would also find interesting. Let me just pop them up. I will start reading from it. also seems to me that this negative mass that flows like a superfluid might have superconductive properties, especially at this low temperature. So it might actually have another use. We might have superconductive fluid on our hands. Many practical purposes for this. Now, I want to expand further with Adscft. It's a deeply surprising example of duality. It relates two very different theories that at first sight seem very obviously wrong. It states that there is a duality between theories of gravity in 5 dimensions and quantum field theories in 4 dimensions. This correspondence was first formulated by Juan Malvicino in 1997. It was generally thought to be the single most important result in string theory in the last 20 years. Wow. The original example of Adscft linked two very important theories. The gravitational side involved a particular extension of gravity type 2b supergravity on a particular geometry, 5-dimensional anti-de Sitter space. QFT was a unique theory with the largest possible amount of supersymmetry. There is a specific dictionary that translates between the theories. This relationship has no formal mathematical proof. However, a very large number of checks have been performed. These checks involve two calculations using different techniques and methods of quantities related by the dictionary. Continual agreement of these calculations constitutes strong evidence for the correspondence. The first example has now been extended to many other cases with Adscft, and more generally referred to as the God-gravity correspondence. Formally, this is a statement that gravitational theories in n+1 dimensions can be entirely clearly equivalent to non-gravitational field theories in n dimensions. Again, the holographic principle comes into effect. The Adscft correspondence has a very useful property. When the gravitational theory is hard to solve, the QFT is easy to solve, and vice versa. Wow, they're complementary. This opens the door to previously untractable problems in QFT through simple calculations in gravity theories. Moreover, Adscft allows a conceptual working of the classical problems of general relativity. Indeed, if general relativity can be equivalent to a QFT, then neither one is greater than the other. Yin and yang, they correspond to complement each other. Finally, physicists can use it to develop new intuitions for both QFT and general relativity. Very, very, very interesting. I actually think that would work. other thing that I found really interesting and I wanted to discuss was this idea about five-dimensional black holes could break general relativity. Research has shown how a bizarrely shaped black hole could cause Einstein's general relativity, a foundation of modern physics, to break down. However, such an object could only exist in a universe with 5 or more dimensions. It would definitely work in the 6 8 10 later, the afterwards. The researchers from the University of Cambridge and Queen Mary University of London have successfully simulated a black hole shaped like a very thin ring, which gives rise to a series of bulges connected by strings that become thinner over time. These strings eventually become so thin that they pinch off into a series of miniature black holes, similar to how a thin tube of water from a tap breaks up into droplets. Ring-shaped black holes were discovered by theoretical physicists in 2002, but this is the first time that the dynamics have been successfully simulated using supercomputers. Should this type of black hole form, it would lead to the appearance of a naked singularity, which would cause the equations behind general relativity to break down. The results are published in the journal Physical Review. General relativity underpins our current understanding of gravity, everything from the estimation of the age of the universe to GPS signals we rely on, navigated based on Einstein's equations. In part, the theory tells us that matter warps with surrounding space-time, and what we call gravity is the effect of that warp. And in the 100 years since it was published, general relativity is practically testless. Practical level that can throw at it, but one of its limitations is the existence of singularities. A singularity is a point where gravity is so intense space-time laws of physics break down. General relativity predicts that singularities exist at the center of black holes without any are surrounded by the event horizon, the point of no return, where the gravitational pull becomes so strong that escape is impossible, meaning they cannot be observed from the outside. As long as singularities stay hidden behind the event horizon, they cannot cause trouble as general relativity holds. The cosmic censorship conjecture says this is always the case, and so the Marcus School should teach these students in Cambridge's Department of Applied Mathematics and Physics. As long as the cosmic censorship conjecture is valid, we can safely predict the future outside of black holes. Because ultimately what we're trying to do with physics is predict the future given knowledge of the state of the universe now. But what if a singularity existed outside of an event horizon? If it did, not only would it be visible from the outside, but it would represent an object that has collapsed with infinite density state, which causes the laws of physics to break down. Theoretical physicists have hypothesized that such a thing called the naked singularity might exist in higher dimensions. If naked singularities exist, general relativity breaks down. Also, PhD student from DNTP, and the general relativity breaks down, it would throw everything upside down because it would no longer have any predictive power. It could no longer be considered as a formal theory to explain the universe. We think of the universe existing in 3 dimensions plus the 4th dimension of time, which together are referred to as space. But in branches of theoretical physics, such as string theory, the universe could be built up of many 11 dimensions. The dimensions could be large and expansive, or they could be curled up. Tiny and large. Since humans can only directly perceive 3 dimensions, the existence of large dimensions, extra dimensions, can only be inferred through very high energy experiments such as those conducted in LHC. Einstein's theory itself does not say how many dimensions there are in the universe, but theoretical physicists have been studying general relativity in high dimensions to see cosmic sensitive circles. Discovery of ring-shaped black holes in 5 dimensions, then researchers hypothesize how they could break up and give rise to a naked singularity. What Cambridge researchers have found, along with Queen Mary University of London, have found that the ring is thin enough to lead to formation of naked singularity. Using the Cosmos supercomputer, the researchers were able to perform the full simulation of Einstein's theory in higher dimensions, allowing them to not only confirm that these black holes are unstable, but to also identify their eventual fate. Most of the time, a black hole collapses back into a sphere, so that the singularity would stay contained within the event horizon. Only a very thin black ring becomes sufficiently unstable as to form bulges, connected by thinner and thinner strings, eventually breaking off and forming a naked singularity. New simulation techniques and computer code are required to handle these extreme shapes. The better we get at simulating Einstein's theory of gravity in higher dimensions, the easier it will be for us to help with advancing new computational techniques. We're pushing the limits of what you can do on a computer when it comes to Einstein's theory. But if cosmic censorship doesn't hold in higher dimensions, then maybe we need to look at what's so special about a four-dimensional universe that's unique to us. But cosmic censorship conjecture is why it's supposed to be true in our four-dimensional universe, but should it be disproved, an alternative way of explaining the universe would then be identified. One possibility is quantum gravity, which approximates Einstein's equations far away from the singularity, but also provides a description of the for those close to the singularity. Very interesting. And I believe very instructive. And I think that these models are very instructive on how to create artificial black holes in extra dimensions. I would like to actually see that one day. Now, another interesting thing I found is that a random substrate model predicts traversable wormholes. Unfortunately, it comes with time dilation, which means that if you travel 10,000 light years, while it might, for you, take an instant in time, or outside observers, it would take the full 10,000 years. But the trade-off, the beneficial part is they are entirely safe. Ron China explained that traversable wormholes require special circumstances in order to exist. This includes the existence of negative energy, which is not permissible in classical physics, but is possible within the realm of quantum physics. An example of this, they claim, is the Casimir effect, where quantum fields produce negative energy while propagating along a closed circle. This effect is typically small because it is quantum. In our previous paper, Traversable Wormholes in four dimensions, we realized that this effect can become considerable for black holes with large magnetic charge. The new idea was to use special properties of charge massive fermions, particles like the electron but with zero mass. For magnetically charged black holes, these travel along the magnetic field lines. In a way similar to how the charged particles of the solar wind create the auroras near the polar regions of the Earth. The fact that these particles can travel in a circle that entering one spot and emerging when they started in ambient flat space implies that the vacuum energy is modified and can be negative. The presence of this negative energy then suppose the existence of a stable wormhole, a bridge between points in space-time that won't collapse before something has a chance to traverse them. Such wormholes are possible based on matter that is part of the standard model of physics. The only problem with these wormholes would have to be macroscopic in size, and would only exist over very small distances. For even travel, the wormholes would have to be large, which requires that physics beyond the standard model be employed. This is where the random Sunstrom true model, five-dimensional warp geometry theory comes into play. Named after theoretical physicist Lisa Randall and Raman Sundram, this model describes the universe in terms of five dimensions and was originally proposed to solve the hierarchy problem in particle physics. The Randall Sunstrom 2 model was based on the realization that this five-dimensional spacetime could also be describing physics at lower energies than the ones we usually explore, but that it would have escaped detection because it couples with our matter only through gravity. In fact, its physics is similar to adding many strongly interacting massless fields to the known physics, and for this reason give rise to the required negative. From the outside, Malchina concluded that the wormhole would resemble intermediately sized charged black holes that would generate similarly powerful tidal forces that spacecraft would need to be worried of. To do that, they created potential travel would need to use a very large boost factor, like space engine has, and attach to the center of the wormhole. Assuming that can be done, the question remains of whether or not the wormhole could act as a shortcut between 2 points of space-time. And Daniel Jeffries at Harvard showed that while it's possible stable wormholes would actually take longer to traverse than normal space for outsiders. According to Maldacena, however, the wormhole would take almost no time to traverse from the perspective of the traveler. From the perspective of an outsider, the travel time would be much longer, which is consistent with general relativity. Where people traveling close to the speed of light will experience time dilation. Time slows down. For astronauts going through the wormhole, it would take only 1 second of their time to travel 10,000 light years, 1/10 of the Milky Way size. An observer who does not go through the wormhole, if outside, is taking more than 10,000 years. And all this with no use of fuel, since the gravity accelerates and decelerates the Star Trek. Just like space engines. Another bonus is that traversing these wormholes can be done without the use of fuel, since the gravitational force of the wormhole itself would accelerate and decelerate the station. In a space exploration scenario, the pilot would need to navigate the tidal forces of the wormhole at the position of their space-time just right, and then let nature do the rest. A second later, they would emerge on the other side of the galaxy. While this might sound encouraging, those who think wormholes could be means of space travel, some of the Malachina's work presents some significant drawbacks. For starters, they emphasize that traversing wormholes would have to be engineered using negative mass, which is just a stellar rush. It should be updated. Since no plausible mechanism exists for natural formation. While this is possible, at least in theory, necessary space-time configurations would need to be present beforehand. Even so, the mass and size involved are so great that tasks would be beyond any practical technology we can project at the moment. Second, these wormholes would only be safe in space where cold and flat, which is not the case beyond the random model. On top of all that, any object that enters the wormhole would be accelerated, even the presence of pervasive cosmic background radiation would be a significant hazard. Now, the study shows that study included the purpose of showing that traversing the wormholes can exist as a result of the subtle interplay between general relativity and quantum physics. They might be practical for a Type 2 or Type 3 counter civilization, but that's speculative. Not beyond the realm of possibilities, certainly encouraged. So, this pretty much concludes part 33. I'm just tying up some ends right now. So that everything done. And I will leave this as the last part, since it's obviously gone extremely long, and I'm not sure if there's anything else to add at this point that will be included in the sequel to the origins of the Omniverse after part of the key course. So, this should pretty much cover it. And looking through, pretty much everything. Well, oh, just wanted to add, we have some more evidence of stellar neutrinos being detected. I'm just waiting to get an update on that, but it seems like we basically have two studies that they have over 6 sigma degree of certainty, and we need 5 for it to be worthwhile. So there's less than 1 in 6 billion chance of it, not being true. So, that will do it for this update. And I think this will be the last one in this series for now, until I complete more of my second book. But this is pretty exhaustive and covered pretty much everything that I needed to cover. I can't think of anything that I left out. If I did, God help me, we're going to rip this through. Oh, it's already too much. So, I will leave it here. Part 33. Finally done with this. And hopefully you enjoy the entire series, which is now over 4 hours long. So yes, quite a series. Okay, everyone. I will catch you in my comment section on my Twitter, Facebook, WordPress, YouTube videos, as well as Shutterfly, Scribd, etc., etc. We'll be updating those to reflect this new information so that I can have a good starting off point to continue my origin series. Take care, everyone. We'll talk to you soon. Okay, so I apologize for how long parts 33 and 34 were. I'm going to try to summarize through the details in them. As you know, this is part 35, by the way, of the Origin and SE Info series. And I'm going to do a quick summary of what we discussed. One was, of course, the ER equals EPR breakthrough, which I have been writing about for a few years now, actually before it became well known, or known at all. And ER equals EPR is basically wormholes in quantum foam are carrier of quantum entanglement. It's brilliant. It is a connection between quantum mechanics, gravity, and general relativity. Gravity naturally emerges from it, as well as the fact that it's directly connected to the holographic theory, which I have my own catchphrase for catchphrase as a maybe, and that's n equals n plus 1. Because any number of dimensions can be described by the boundary of those dimensions or one less dimension. Because of quantum entanglement and wormholes. So ER equals EPR and N equals M plus 1 are closely related. It's the combination of general relativity, quantum mechanics, gravity, and holographic theory. This has very many applications, not just with entanglement, but also with some quantum mind theories, including intuition, which you can take all the information from your environment and process it subconsciously, because we all have outside stimuli that affect our brains, but we can process this on a different level in terms of fight or flight, etc. Know when we're in danger, know a loved one is in danger, etc., something big and bad is going to happen. This would be an explanation for intuition, for ESP, for precognition, for all of it. Because space and time would emerge from this. So this could be something that actually could be in our environment, in our surroundings, and we would gather the information subconsciously and act upon it. So that would be a quick summary of ER equals EPR and N equals N plus 1. Now, I also wanted to talk about cosmic strings for a little bit. And the reason why I wanted to talk about cosmic strings is because I came across a theory, or actually a blueprint, for creating a wormhole, a stabilized wormhole, using cosmic strings, two cosmic strings connected together, and basically have them inside a wormhole, and it would keep the wormhole open. It's a very far-fetched idea, because first of all, cosmic strings probably did exist in the early universe. We don't know if they exist anymore, and secondly, it takes a lot of energy to bring them together. Probably extremely difficult to do that. They're one-dimensional objects that were formed in the early part of the universe during the first spontaneous symmetry breaking when the universe first started to expand. Basically, it's like having a crystal. Part of a crystal has a defect in it. As the universe is expanding, that defect stays frozen in. So this topological defect is one-dimensional, about the width of a proton or less, etc., etc. Extremely localized, very high gravity. And this is the way it would be discovered, by the way, through gravitational lensing of a distant galaxy, quasar, etc. We actually might have discovered one. So, reading this article here, basically they talk about a possible discovery of the quasar, good quasar, double quasar, Q0957 plus 561AB. This is a double quasar. It creates a double image. Now, quasar was studied at Harvard between 1994 and 1995. The two images, the double image, the gravitational lens, appeared to have no time delay. Changes in the brightness of the two images occurred simultaneously on 4 separate occasions. The team believes that the only explanation for this observation is that a cosmic string passed between the Earth and the quasar during that time period, traveling at very high speed and oscillating with a period of about 100 days. We have 2 gravitational telescopes, LIGO and LISA, out there. a search for gravitational waves, they are sensitive enough to detect signals from cosmic strings. So hopefully we'll get an answer soon enough. So basically, these one-dimensional topological defects that formed during the signature-breaking phase transition in the early universe, I mean, they were probably pretty common back then. So there might be a few still left over, and if they are, they're actually relics and basically fossils from that time period. They occurred right after cosmological inflation. Basically, from 10 to the negative 36 seconds after the Big Bang or Big Bounce to somewhere between 10 to the negative 33 or 10 to the negative 32. So it just lasted a while. So there's a relationship between cosmic strings and string theory also. F strings. And if we find one, it could actually be some observational proof of string theory, which would be really interesting. So, there's also a possibility of a negative mass cosmic string. We have been discussing negative matter, right? Dictated 2 articles that show that negative mass actually does exist, has been created in the lab, and that was very interesting. Very interesting properties of being the exact opposite of normal mass. Basically, you push on it and it comes towards you instead of going in the opposite direction. The standard model of a cosmic string is a geometric extension with an angle deficit, which thus is in tension and hence has positive mass. In 1995, it was proposed that cosmic strings could theoretically also exist with angle excesses, and thus negative tension and hence negative mass. So it's exotic matter. They suggested that if a negative mass string were to be wrapped around a wormhole in the early universe, such a wormhole could be stabilized sufficiently to exist in the present day. Very interesting. So this could be something that would work. I would actually be quite interested in something like this. Okay, so this is from the original article submitted on September 20, 1994. We have suggested traversable 3-dimensional wormholes that could plausibly form naturally during Big Bang inflation. A wormhole mouth embedded in high mass density might accrete mass, giving the other mouth a net negative mass of unusual gravitational properties. The language of such a gravitationally negative anomalous compact halo object, it's a G NATO, will enhance background stars with a time profile that is observable and qualitatively different from that recently observed for massive compact halo objects, machos, or positive mass. We recommend that macho search data be analyzed for G nachos. Well, that's interesting. So, there's another article, basically, the sort of more of a layperson's summary of the abstract that I just read. Now, in here it says such wormholes could have been created in the distant past, in the time just following the Big Bang that created the universe. What we discovered at the workshop was that if such wormholes did exist, they could be detected by gravitational lensing. So their telescopes are searching for massive compact halo objects, machos, that have positive mass. That could help explain the vast amount of dark matter in our galaxy, or the whole universe. Now, they haven't turned up enough of it to explain the amount of what's present in the universe. So you want to search for this thing called G-Notch, or the gravitationally negative anomalous contact POL. So theoretically, they're consistent with the theory of relativity wormholes, but they're unstable. Now, previous scientists have detailed the theory, but never suggested plausible means by which one might be created. In this work, we realized that during the formation of the universe, the Big Bang, wormholes could have been stabilized by loops of negative mass cosmic strings. Cosmic strings are discontinuities in the structure of space that have been theorized by cosmologists, and so they could still be here, and it's worthwhile to look for them. If we find one, the implications are enormous. Wormholes provide one possible way to create astronomical objects of negative mass. A key element of the theory is finding that as mass passes through the wormhole, the entrance and exit mounts of the hole gain and lose mass. According to theory, either end of a wormhole can swallow mass, ejecting it out the other end. But a wormhole mouth in a dense region of matter, so near dark matter, swallows mass faster than its other end if that end is in a sparse region. Mass, this all makes sense. Because obviously more of a concentration of mass swallow factor. Mass emerging from an end curves space-time oppositely. It's as though the end loses mass, finally reducing to zero mass and then to negative. Gravitationally, that negative end looks like a negative mass, maybe even a large stable one. So basically, they want this telescope lens experiment, OGLE expanded, search for these and other possible negative mass objects. That will be relatively simple, because G-Notch is provide a distinctive light enhancement profile. Passing between us and the stars, this resembles a twinkling of starlight in the Earth's atmosphere. Ordinary mass causes the sun brightening of a star image, exerting gravitational focusing of light, like focusing of a lens. Ordinary mass causes a single peak in brightness because it focuses the light, but negative matter deflects the light rays, creating a shadowed umbra region where light from the source is extinguished. At the edges of the umbra, the light rays accumulate and form what they cluster, giving a very large increase in light intensity in two visible peaks of brightness. This light signature is unique. So basically, if they did discover a wormhole, it would be like a shortcut through space. Instantaneously traveling between two places that are spatially very distant without contradicting the theory of relativity. We go in one end and we pop out somewhere else. Finding one would completely change our view of how galaxies form, because it would mean that wormhole transport of matter from one part of the universe to another has been a significant evolutionary factor. But it would mean that space-time is intimately connected in a way we didn't know. Now, the interesting thing with this, it relates to ER equals EPR because wormholes are a fractal representation of that. And the way it all connects to holographic theory, it was found that wormholes and entanglement are exactly the same thing with wormholes in an extra dimension. So n equals n plus 1. N would be entanglement, n plus 1 is wormholes. So all of it gets brought back together into one umbrella. It's complete unification. This is how it happens. Everything is connected literally, like a network. This is the reason why our brains actually resemble the structure of the universe so much. But if all of it is connected, we are, in a way, a fractal representation of what the structure of the universe is, wormholes, entanglement, cosmic strings, string theory, all part of it. So getting back to this article that I was reading, and popped off there on my little tangent, it would mean that space-time is intimately connected in a way we didn't know. That the whole universe is knitted together. Knitted. And that's a profound result. It is profound. It's profound for us as a species. It's profound to our way of understanding things and how everything is connected. Not just all the life here, but the entire universe. Okay, so that's my thing on cosmic strings. I would also like to add that in addition to what we discussed about stabilizing the wormhole with two cosmic strings joined together, you could actually form a time machine by having two ends of the string parallel to each other and moving them back and forth to actually create negative energy between the two parts of the cosmic string, and would create a closed kind of like curve to close the whole thing together. Basically, you would relive the same way, like Groundhog Day, basically. You relive the same day over and over again. So that's a paradox, but we know that with time paradoxes, it can be resolved because you have different timelines, which by itself, which by the way, is quantum superposition. So that's another aspect of quantum theory affecting the relativity, different universes. You don't go to your ancestors, they're actually in different timelines. Due to the cause of the second temporal dimension. And the two are separating because the universe is expanding, and all the timelines will come back together again at X big bounce. Okay, so we discussed all of these. Now, look at the cosmic strings. The exterior geometry of a straight cosmic string can be visualized in a diagram with one dimension, focusing on the two-dimensional surface perpendicular to the string. And its geometry is that of a cone, which is obtained by cutting out a wedge of angle theta and then gluing together the edges. The angular deficit theta is linearly related to the string tension, equals mass per unit length. The larger the tension, the steeper the cone. Therefore, theta reaches 2 pi for a certain critical value of the tension, and the cone degenerates to a cylinder. In visualizing the setup, one has to think of a string with a finite thickness. For even larger supercritical values, theta exceeds 2 pi. In the two-dimensional exterior geometry closes up, it becomes compact, ending in a conical singularity. However, the static geometry is unstable in the supercritical case. Unlike the subcritical tension, small perturbation, which is dynamical space-time, which expands in axial direction at a constant rate. The 2D exterior is still compact, but the conical singularity can be avoided, and the embedding picture is that of a growing cigar. Interesting. Even larger tensions exceeding the critical value by approximately a factor of 1.6, the string cannot be stabilized in radial direction either. Realistic cosmic strings are expected to have tensions of around 6 orders of magnitude below the critical value and are thus always subcritical. However, the inflating cosmic string solutions might be relevant in the context of brane cosmology, where the string is promoted to a free brane corresponding to our universe in a 6-dimensional bulk. Very interesting. Okay. Oh god. Now, going into string theory and cosmic rays really quickly. Excuse me. Basically, jumping ahead to when the second superstring revolution in M theory happened. It is now known that string theory, in addition to the fundamental strings which define the theory predeterminedly, also contain other one-dimensional objects, such as D strings and higher dimensional objects, such as D branes, NS branes, and M branes, partially wrapped on compact internal space-time dimensions, while being spatially extended in one non-compact dimension. Possibility of large compact dimensions and large warp factors allow strings with tension much lower than the Planck scale. Furthermore, various duality has been discovered, points to the conclusion that actually all these different types of strings are just the same object, as it appears in different regions of parameter space. These developments have largely revived interest in cosmic strings. 2002 was predicted that the production of cosmic superstrings during the last stage of brane inflation. The string theory constructed of the early universe that leads to an expanding universe of cosmological inflation. It was subsequently realized by string theorists that the expanding universe could have stretched a fundamental string, so it was superstring theory considered until it was of intergalactic size. Such a stretched string would exhibit many of the properties of the old cosmic string variety, making the older calculations useful again. String theory cosmologists have discovered cosmic strings lurking everywhere in the undergrowth. Other proposals for rejecting cosmic strings could now be used to investigate superstring theory. Superstrings, these strings, or the other stringy object mentioned above, stretch to intergalactic scales to radiate gravitational waves, which could be detected using experiments at LIGO, especially the space-based gravitational experiment LISA. They might also cause slight irregularities in the cosmic microwave background, too subtle to have been detected yet, but possibly within the realm of future observability. Note that most of these proposals depend on the appropriate cosmological fundamentals, string, etc. Cosmic strings provide a window into string theory. If cosmic strings are observed, which is a real possibility for a wide range of cosmological string models, this could provide the first experimental evidence of a string theory model underlying space. Very. Okay, so that was very important. We discussed that. I discussed my Pythagorean layer theorem with 3, 4, 5 corresponding to our brain. 6, 8, 10. Well, our brain is the tetraverse. 6, 8, 10 is the octaverse. We discussed 9, 12, 15, and then 12, 16, 20, and then 15, 20, 25. 25 corresponds to 26, well, it's computational dimension, but non-string theory. For the 8, you know, that's the tetraverse, octaverse, 16 verse, etc. The 10, as you know, is for M theory, spatial dimension, and superstring theory, as supergravity and supersymmetry. All of those have that dimension. I had discussed the thing about quarks and gluons. Quarks, they have 6 flavors, 6 types, so they can be talking about top, bottom, strange, charm, up, down, and of course the RGB colors for the quark and the CMY colors for the antiquarks and the gluons. They're actually a combination of a color and an anti-color. It included 9 combinations, but since everything has to be cleared up, quark, gluon, quark, or quark, gluon, antiquark, or antiquark, gluon, antiquark. You get it down to basically 8 color combinations. So they get paired up separately, but there's 8 color combinations. So that's really 8. And yeah, the bulk is part of those layers, basically to undercut everything, and that way the wormholes and the entanglement and all that. So I discussed that. This magnetic wormhole that was made, I wanted to quickly get into that. The magnetic wormhole is actually not a real wormhole. Basically what they made is they used a cloaking device using metamaterial to send an electrical signal from one point to another. Because the signal is cloaked, you can't see it travel through the cloaked area. Basically it goes in at one point and comes out at the other point, so it looks like a wormhole, basically it's like an invisibility cloak. So that's what that is. It wasn't a real wormhole. It's like when they make toy black holes are not real black holes. Basically, you use fluids like water or whatever, and you can use ocean theory to create a de facto singularity and vectorize and all that. They use the same thing to create a fluid model for tornadoes and vortices and things like that. They're made similarly. So there's actually a connection on a fractal level between those things. Hurricanes and black holes and galaxies and solar systems and things like that. Even atoms. I mean, practically they all resemble each other. The more forces going on that create structures. the magnetism and the other gravity. Some cases, how you shows that the universe is fractal on many levels, on all levels actually. So I'm looking to see if there is anything else that I need to discuss, and I believe that might be it. We discussed the cosmic strings. Oh, just remembered. I have not discussed this new thing that I read, which actually resembles my theory quite a bit. Emergent dimensions. So this new idea of vanishing dimensions universe started as a one-dimensional string, expanded into a network that eventually all these different strings overlap, became perpendicular, etc., created a two-dimensional universe, a plane, and so on and so forth, until it became three-dimensional, etc., and now it's expanding into four dimensions, which is why the universe is expanding. I had previously talked about evidence for this. We found very high energy cosmic rays that only travel in two dimensions. And what that means is, the very early stages of the universe, that's what the universe was. It was a two-dimensional plane. And we found evidence for this with cosmic rays and Earth. They're making circular two-dimensional trails. But that, if they're three-dimensional, they're shaped like cones. So it's just the shape of the inflection of waiting come in. So three-dimensional would be cones, two-dimensional would be circles. What would be really interesting would get one-dimensional, which would be a point. So that would be really early stage of the universe. But yes, during the spontaneous symmetry breaking, we went from one-dimensional, two-dimensional, three-dimensional, four-dimensional. Now with the expanding universe, but the really interesting thing with this is in two dimensions there is no gravity. Two dimension, one dimension, no gravity. So what does that mean? It means there's no singularity. Exactly what it sounds. Universe in two dimensions, origin and gravity and quantum mechanics create this bounce. So what happens is, quantum bounce. Basically, when the gravity ceases to exist, this force, what we're calling force, takes over. And the universe. So basically, if you can imagine it, it's a contracting universe, previous universe to this one. The timelines all collapsing into each other, going from 4 dimensions, 3 dimensions, 2 dimensions, 1 dimension. Once this happens, no gravity, it stops contracting, closely expands again. But the dimensions come back, 2 dimensions, 3 dimensions, etc. The timelines come back. If you have any remnants from past universes, I discussed it, it's a possibility. We see some very huge black holes very early on in the history of the universe. That could be there. And it seems like that could be from a previous cycle. And of course, we talked about a cosmological constant, how that value is a weird non-zero value that seems to indicate that we're in one of the cycles of the universe. So, value is slowly going down with each cycle, of course, and the universe, the universe, maybe some of that is being transported there. Cosmic DNA of universes, we discussed different types of multiverses, Tegmark model, I think we had 5 layers, I think multiverse, I think it was, 4 layers in Tegmark, and, Brian Green had 9. Actually, Brian Green's a little bit more, but I do like both of them. Brian Green had more, they had the time verses separately, and the universes with different laws separately, different layers, etc. In mine, I had 5, so I guess I'm in between both of them, between the 1 and the 9. Some of them in their hierarchy seem like a distinction without a difference. In mine, basically, what I have is the tetraverse, the octaverse, the 16 verse. Now, I have 2 others. Basically, I have not gone into detail about those. One is the basic level, it's symbolic. It's not really universe, it's in the structure that underlies everything. Fundamental. So, that's the 4th. Now, the 5th, I had not discussed. It's not actually about universe, it's basically the connection between everything. One is the background. Well, background to everything. And I guess two would be like the wormhole, and entanglement that connects everything together. So basically, it's 3 layers of universes, 4, 8, 16, plus the underlying bulk as another layer, and then the wormhole entanglement as another layer, so that's 5. But I mean, I did go into the multiverses, the time verses, which is part of the superposition, all those really belong on the layer that the universe is making those time verses. So basically, our time verses are on our own layer. It's just a second dimension of time on our own layer. It's part of ours. And same thing would be the case with the Octoverse and Universe. I should call that the hexadecimal verse, because 16 is hexadecimal in computer code. So it's 4 and 16. And yeah, the other those 2 layers have their own laws of physics and their own constants and all that. But you're on a layer, everything in that layer is the same laws of physics, the same constants, even if they're reversing dimensions or negative dimensions. We will also discuss negative dimensions, so we're going to like a black hole. Well, Horizon Nordstrom black hole. A curved black hole would be a spinning variety. Horizon Nordstrom is a charged variety. Both of them you create extra event horizons, total of 4. 2 event horizons and 2 Cauchy horizons, and once you get out the other side, you end up in a negative and like that very bubble of your own space time with you. You get another universe at the lower before that. So, likewise for us, and as you know, when we discussed this whole structure with the tetraverse, it was the flow of time would be opposite. Very odd. They would be a tachyon universe to ours, and we would be tachyon to them. They would always be going back to the line of our only purpose for going there would be to come back to an earlier point in the timeline, and avoid the paradox, because we would be going close to the time dimension with a different timeline, or to use wormhole shortcuts to go to the points. You can use it both ways. Either come back, go to the timeline, or jump there and jump back to end up in a distant part space. So we discussed all that. We discussed the fact that black hole event horizons basically collect all of the information, the history of the universe, past, present, and future, which is all combined into one, which is the way I view the universe. So basically, you're talking about another victory for the holographic principle. Since you collect all the history, past, present, future, it shows that all times exist at every point on the boundary. When you're looking from the outside into our universe, through a half vibration, we see all of the timelines and all past, present, and futures. They would be on the outside of the black hole, looking at the event. And Einstein had talked about this century ago, basically saying that time is a landscape, all parts of it exist at the same time. So we can even say earlier that all timelines exist at the same time. And the other thing in association with that would be the fact that since all time exists at the same time, time is a landscape, we will see ahead further. The whole black hole, all the particles of the black hole are entangled. It's also interesting. So basically, nothing more information ever gets lost. Everything that's inside the black hole, outside the black hole, it's all entangled. So that's how all the information gets described. And basically, the black hole, we move wormholes all over the place, connected together. We actually hold space-time together. That's why it's not flying apart. Like it's dynamic, just quantum foam, and it's changing all the time. It would have broken apart. But with little wormholes, the quantum entanglement helps everything together. You have big wormholes that you can use to connect everything together, like the blood supply for the whole omniverse. So all of that is connected. And it's basically like, you can consider that either factor representation of a living being. So it's not just the brain, the entire body, it's the heart, the blood supply, all of it connected together. Anyway, so I guess that will do it. I'm trying to figure out how long I have actually wanted to have this go on for about, I would say 40 minutes, okay. Let me see here. So, the previous version that I did was, I believe, 3 hours. And then I did another one. Okay, alright, I'll end it. Okay. Alright, you know how to contact me on social media, to talk to you soon, leave comments, watch videos, etc. Quickly wanted to discuss the fact that part 33 was, I believe, an hour and 20 minutes long. Part 2 was exactly 3 hours. So that was like 3 hours and 20 minutes. And this is going to be hopefully shorter than either of them. So, I believe I started this at 1:20, it'll be 1:23. So basically, we are talking about, this is going to be almost 40 minutes. It will be 40 minutes if I keep going for another 2 minutes, so I'll just do that. So, it'll be 5 hours between the stories, basically what it adds up to. Yeah, that's a lot. And then I also have the other parts I did the first 3 hours. So it ends up being a total of 8 hours. Wow. Okay, so I'm going to probably edit some of these because 8 hours is a long time to hear me talk. So I'll probably edit these and try to shorten them a little bit. This one I think I'll keep because this one is the most condensed, with a condensation basically of the previous 2. So basically, instead of having the 3-hour one and the 1 hour 20-minute one, we're looking at the 40-minute one. So basically, if you see me going from part 32 to part 35, you know exactly why that happened. It happened because those 2 between were probably a little bit too long. And this is a good condensation of the 2 of those. Or summarization, I should say. Summarization. I will leave those 2 up though, because since they're more detailed, if anyone wants more information, they can always refer to those. Just a warning. 133 an hour and 20 minutes, and 134 fully 3 hours. And I don't like talking for that long of a time. I have to see my voice is burning. So I think that 40 minutes is actually the appropriate length, the maximum appropriate length for these videos. And so basically, I'm really excited. 35 parts. I think that will do it. I like the number 35 in this case because you just want to watch one every day. You'll be done in 5 weeks. 7 days a week. 7 times 5, 35. This would be a good place to leave off. I really don't want to go to the next level, which would be 42. That would be 6 weeks, 7 times 6. That might be a little bit beyond. But I'm sure I'll come with all the stuff that we've talked about. It actually goes beyond what I discussed in my book. And so I will be putting that in the sequel. I'm sure when I come up with the ideas that I have and put them down, I'll want to do much more. So basically, we'll leave it at 35, which will cover the first origin, second origin, the sequel. We'll start up from here. I'm really excited about this ER equals ETR and all of the n equals n+1. How many different implications that has in not just the universe, the omniverse, but in our everyday lives. The way we think, the way we behave, all of it. pretty hope for the future now with all these new discoveries being made, even though we're in pretty dark times right now. Hopefully this enthusiasm carries us through the next period of advancement of human history. Remember, if this proves anything, it proves we, all species, all life, all universes, everything, we're all in it together. So make it count. Alright. I am about to sign off, and hopefully you will engage me with the comment section and let me know what you think about everything. Read my work on Scribd. It's also on Shutterfly, WordPress. I can be contacted on Twitter and Facebook also. And it was nice. It was really nice being able to express my thoughts this way. Writing was awesome. I love writing. But I found that my mind also works well when I have to talk off the top of my head, come up with ideas, and engage in this way. So, I will leave it here. I just wanted to let you all know what my schedule is as far as book and everything is concerned. And also with SpaceX, with the engine that I mentioned, I am going to see them this week. Book, as far as I know, I have an appointment. They're supposed to call me. I'm supposed to be there on Friday, so we'll do that. And hopefully the editor won't do too much to it. I've already edited it a number of times. Seems pretty excited about it, so hopefully we'll just leave it mostly as is. And so everything is all set. Now, one other thing I wanted to say is I hope you look at my other space engine video too, with the new engine being installed, more efficient, higher speed. I'm going to be doing some gravitational screenshots to test the physics. It should be accurate. I've tested a number of different aspects of it, and everything seems to be in order, working. Okay, so we'll leave it here. Hope to talk to you all soon. Sayonara. Hasta vista. Adios. Okay, so that concludes part 36. Sorry about that. I just found a few more things I needed to summarize that I had left out in part 35. Now, we had discussed the Pythagorean triples, 3, 4, 5 tetraverse, which is 3 plus 2 and 6 plus 2 total dimensions. That works with through the Klein theory, Randall Sundstrom 1, 2, and Yang's Mills. We got 6, 8, 10, which is 8 plus 2 octaverse that works with supergravity, superstring theory, M theory, and 6-dimensional Calabi yaw manifolds. 9, 12, 15, the bulk. This is where the bulk resides. Well, part of the bulk are the ones with the lower levels of 3, 4, 5, and 6, 8, 10. And I talked about F theory, which has 2 dimensions of time. That actually resides here. And also, I discussed the gluon quark colors. 8 get used because you have to be in pairs. So it's not the 9 total, 3 plus 3 plus 3, 3 plus 3 plus 3 minus 1. Gluons. Then we have 12, 16, 20, which is the 16 verse F theory, 2 dimensions of time. So you can see where the 4, the 8, the 16 come into play. And then we have the 15, 20, 25, which is where the bulk and the entanglement of the wormholes are. That's 25 plus 1 dimensions in bosonic string theory. These are energy levels with universes on equal levels having similar levels of energy. also fractally similar to electron shells in atoms. Each higher triplet is a higher energy version of the basic triplet at the lowest level, and this explains why gravity is so weak at our basic level versus the others. 12 total quark antiquarks can switch between each of 3 RGB colors for quarks and 3 CMY colors for antiquarks. Gluons contain both RGB and CMY paired together. We already discussed ER equals EPR combining holographic principle as entanglement between boundary space and exterior black hole and interior describes all of 3D and 2D. And by the way, also experimentally confirmed that entanglement in 4 dimensions is the same as wormholes in 5 dimensions. And we have some very interesting things about wormholes in 5 dimensions, where they're much more traversable. And you can have taking singularities and all other fun things. And they become traversable because negative mass is more common, and the wormhole actually opens up outside of the singularity. And the wormhole is much more stable in 5 dimensions. That's awesome. Anyway, we're combining gravity and quantum entanglement, Msi Afterburner duality between gravity and quantum field theory. This is where Adscft duality for string theory comes in, proves it. Black hole information paradox solved. Many worlds theory combines with quantum superposition to reach multiverse timelines across both dimensions of time. The time-verse multiverse is causally separate as they become entangled with their own environments. Everything is connected through these worlds. Lifeblood of the omniverse. But we can still travel across the second dimension of time, which separates the different time-verse manifolds. Space-time is produced by quantum entanglement, which results from micro-wormholes across quantum fold. Quantum entanglement is fractal with wormholes. Gravity is emergent and entropic and naturally arises from quantum entanglement of space-time. It is the glue which holds everything together, otherwise space-time would tear apart because it is dynamic and always moving. More timelines means more entropy and entanglement, and timelines can be considered as increasing entropy or entropic energy. Space-time is 2D at the Planck scale. We already discussed this, not 2D. Space is fractal and time is an emergent property that naturally arises from it. Okay, so negative mass has been discovered in plasma. Negative mass makes it possible for micro wormholes to stay stable, and also the large wormholes to stay traversable. And those formed early on in the universe could be expanded to traversable sizes by inflation. Total energy in multiverse always stays the same, as the amplitude of each timeverse gradually drops with time. But total energy inside each timeverse is conserved. The higher dimensional space-time gravity is much stronger, and black holes become more important in the structure of space-time and can be produced at the LHC, and by cosmic rays. So all of this is very interesting. Okay, we had discussed the Adscft conjecture. Basically, it proves that gravity and quantum field theory are very close. They're very closely connected. And all the checks have been performed. This is the first big proof of string theory. 1997, it was formulated by Juan Malvicino. They were most important result of string theory in the last 20 years. Now, soon to be 25 years. So, really glad for that. And I hope you all stay tuned. Part 36 will for sure be the last one I do for a while until I get the second volume of my series in production. I'm going to start working on it soon, so once I have more done there, there will be more to talk about with this. So, anyway, I am very happy that it's now 3 dozen series. So, by the way, so basically, it looks like I am going to take 33 and 34, and instead of having them in the main section, it's going to be 35 and 36, because 33 and 34 add up to something like 4 hours and 20 minutes. 4:20. I feel there. And these two, it looks more like they're going to add up to 44 and 8 minutes. So basically, I'm replacing 4 hours and 20 minutes with, looks like it will be a total of 52 minutes. So that'll be good. At least a little less than an hour. An hour is a little bit too much. Or more than an hour would be too much. This is probably the right length. Okay, contact me on my media. You know how to get in touch with me. And be sure to listen to and watch my videos and read me on Script, etc. Twitter, Facebook, WordPress, and Shopify. Okay, guys. Have a good one. Talk to you all soon. Hey guys, I have to do one more update because I found another summary that I forgot to add. This is pretty exciting though because there's some new information in here which I wanted to add. Everything really is connected. I'm going to start with the first one that I wrote. This is actually from the research that shows how loop quantum gravity, loop quantum cosmology predicts big bounce. By combining quantum physics with general relativity, postdoctoral researchers at Penn State were able to develop a model that traces through the Big Bang to a shrinking universe that exhibits physics similar to ours. Research reported in the current issue of Physical Review Letter, the team showed that prior to the Big Bang, there was a contracting universe with space-time geometry that otherwise is similar to that of our current expanding universe. As gravitational forces pulled this previous universe inward, it reached a point at which the quantum properties of space-time caused gravity to become repulsive rather than attractive. Just like I had been saying all along. Using quantum modification of Einstein's cosmological equations, we have shown that in place of a classical Big Bang, there is in fact a quantum bounce. We were so surprised by the finding that there is another classical pre-Big Bang universe that we repeated the simulations with different parameter values over several months, but we found that the Big Bounce scenario is robust. It stays. While the general idea of another universe existing prior to the Big Bang has been proposed before, this is the first mathematical description that systematically establishes its existence and deduces properties of space-time geometry in that universe. The research team used loop quantum gravity, a leading approach to the problem of the unification of general relativity with quantum physics, which was also pioneered by the Penn State Institute of Gravitational Physics and Geometry. In this theory, space-time geometry itself has a discrete atomic structure, and the familiar continuum is only an approximation. This would be quantum, of course. The fabric of space is literally woven by one-dimensional quantum threads. We're back to that. Quantum, cosmic strings, quantum threads, quantum entanglement, and wormholes. All connected. Near the Big Bang, this fabric is violently torn, and the quantum nature of geometry becomes important. It makes gravity strongly repulsive. By the way, this would be 2 dimensions and 1 dimension, giving rise to the Big Bounce. So we got our single dimension stuff in there too. All connected. Our initial work assumes a homogeneous model of our universe. However, it has given us confidence in the underlying ideas of loop quantum gravity. We will continue to refine the model to better portray the universe as we know it and to better understand the features of quantum gravity. Research was sponsored by the National Science Foundation, the Alexander von Hope Foundation, and Penn State Everly College of Science. Great. We're off to a great start with this. And so, let it continue with this interesting article. The annoying mathematical roadblock of infinity may have a bypass. The inspiration for the bouncing universe came from a mathematical trick to avoid the formation of singularities and black holes. The idea was first formulated in 1968 by U.S. physicist James Bardeen. He found an alternative explanation for the general relativity equations used to describe black holes. What defines a black hole isn't a singularity, but an event horizon. Outside the event horizon, or regular black hole, there are no major changes, but inside it, the changes are deep-seated. There is a different space-time, think different universe, that avoids the formation of a singularity. It will still be super dense, but it will just not be constant. The black hole's density depends on how far from its center you are. This means mass, the stuff the universe is made of, still acts as though it has a physical volume, even though it is still squeezed into a singularity like space. It has a volume, because space has a minimum size, like group quantum gravity predicts. So there is no infinite or infinitesimal volume, or real volume. He says Bardeen's argument can be applied to the other known type of singularity, the one that produces the Big Bang. Another duality, commonality. In order to measure the rate at which the universe is expanding with standard cosmology, the model in which there is a Big Bang, mathematical function is used that depends only on the cosmological time, he said. He argues scale also plays a part, and once this is incorporated in the equation, the Big Bang evaporates. It eliminates the need for the infinitesimally small quantum universe to burst out into the physical space 13.82 billion years ago. These arguments this is the Big Bang segment. These arguments propose the universe without singularities would produce an eternal cycle of expansion and contraction. The universe races outwards until it reaches a tipping point. The space between the widely dispersed mass acts as a rubber band, reversing its motion. Now, in my theory, a rubber band is the innermost Cauchy horizon of the black hole in which the universe resides, inside the superverse. This rubber band also reminds me of, guess what? The strong force. Yes. Quarks, antiquarks, and gluons. The way gluons keep quarks together, and antiquarks, and the hybrids, quarks and antiquarks. Further away, let's them get a little bit away. But the further away they get, the tighter the rubber band gets, and then it snaps right back. And this is what's happening here. Just another duality, another fractal representation. This contraction would continue, with galaxies moving ever faster and ever closer towards a common point, light. And then the timelines will also converge after the word divergence. Then we have deflation now. Then they merge in a big crunch, which produces a rebound. Rebound comes from gravity becoming a repulsive force in 2 dimensions and 1 dimension. Never gets to the singularity point. Once again, it's not a new idea. Right. So space expands in 4 dimensions, which hits the singularity of the superverse. The black hole that resides with it, which might actually be in the same number of dimensions, comes right back. The application of Bardeen's mathematical argument gives it extra credibility. Why can't it be tested? There's a way to test it. He says, each contraction and expansion event may not eliminate all evidence of the previous state of the universe. There may be remains of black holes in the ongoing expansion that predate, or that date from the prior contraction phase and pass intact through the bottleneck of the bounce. Yes, as a matter of fact, we have a few candidates for that. Identifying these would clinch the argument and kill off the original Big Bang theory once and for all. What traces. The candidates include remnants of black holes from a previous phase of universal contraction that may have survived the bounce. Okay, excellent. Now, we have another thing that's extremely interesting. This combines with my theory of two-time universe. And it's interesting how it's a black hole in this case, and a wormhole, and it goes so well with the Big Bang, the Big Bang, etc., and the Tetraverse, and all of my layers. Does the intense gravity of black holes twist time and space so much that the future gets turned on its head? Some mind-bending new ideas by U.S. astrophysicists suggest so. Think of a holographic picture. Go back to the holographic theory again. Holographic principle. It's a flat, two-dimensional film that it contains all the information our eyes need to perceive a three-dimensional projection. That's how scientists think of black holes, and guess what? That's how they think of the universe and our reality, all of it. The event horizon is a region where the dimensions in which we live, up, down, and around, get squashed and time itself is stretched. It's one of the aspects of black holes where the mathematical principles which govern our universe appear to go wrong. The confounding concept of infinity just keeps rearing its ugly head and breaking all the equations. It's a similar problem with time. We would perceive a spaceship approaching a black hole as eternally slowing down. But what happens once it passes through the event horizon? The event horizon is a region where all of the three-dimensional information about the black hole can be contained on a two-dimensional surface, just like a hologram. What if it is a holographic photo with two sides? This is where entanglements and wormholes come in. ER equals EPR. Recent study in the journal Physical Review Letters has unusual implications for the whole time bit. Would the spaceship come out the other end, slowly speeding up? Backwards? Yes. It's all balanced, fractal, and connected. Perspective. Given the way physicists define the formation of a black hole, event horizons must be aware of the entire history of our universe. So this is where the memory of the universe comes with our Gaia theory and fossils, etc. From Big Bang to Big Crunch, Big Chill, Big Rip, all of it must be etched on that weird, Big Dots too, all of it must be etched on that weird point where light can no longer travel along its merry way. Black holes are stars which have collapsed under their own gravity. A paradox kicks in at this point, throwing our understanding of universal laws into confusion. The event horizon, the point at which light falls into the black hole, cannot know anything about what's deeper inside because light cannot escape. But the location of the event horizon is defined by the matter which is inside it. Yes, holographic theory. As such, the event horizon must know how much matter will ever cross it in the entirety of the universe, to know how big to be. This is called the teleological paradox. It's unlikely to work that way, but it is just a consequence of the idealized way we view black hole formation. The idea of a two-dimensional hologram puts all the massive theoretical constructs into a new perspective by defining black holes in a slightly different way. It's a perspective which fits what we know about space and time, right, because of the holographic principle. And entanglement and wormholes. ER equals EPR. N equals N plus 1. It's a perspective which twists entropy, that immutable force of the universe which sees everything gradually tumble into a state of chaos. Many physicists believe entropy must be part of what causes our perception of time, called thermodynamic time. So, what happens to time at the event horizon? Point difference. The idea is that time is projected backwards once it crosses the event horizon of a black hole. This is like the universe before the Big Bang. Think about it. Maybe it's actually that universe. At black holes, event horizon. Think about something. So if we're connected to the antiverse, maybe our black holes are what connects together. More than one. Or there could be multiple antiverses. Of course, we're talking about superposition and time verses and all that. It could all be different superpositions of the same antiverse. Or other ones. Okay, let me go on. At a black hole's event horizon, entropy from its most active and orderly state at the Big Bang, all the way down to the fuzzy chaos of the end of time, reaches a boundary. It's caught between two regions of very strong gravity, producing a two-sided 2D hologram. The idea is that it's all there, forming a projection that reaches back into the past and forward into the future. Maybe it contains all the data of both universes, all of their different time verses. I think so. This idea shows how the event horizon could know everything there is to know about the past and future, and act accordingly. On one side of this hologram, entropy and time are expanding, going forward. This is time as we know it. On the other hand, they are contracting, going backwards. Entropy and time are reversed. It's like the other side of the Big Bang. An interesting consequence of this would be that if the universe stopped expanding and began to contract towards a big crunch, it implies that time would slow down as the universe got smaller and smaller, until it collapsed into its own universal event horizon. Well, maybe the Big Bang also has been referred in the previous history of the universe on the inside of that event horizon. Something to think about for research in the previous cycle. Sort of like a CMBR for a previous cycle. This would be the holographic opposite of the Big Bang. Great. At that point in time, the universe would reverse. That's a great saying, reverse the universe. Keeping things relative. It's a neat, compact concept which could help solve some of the mind-bending paradoxes black holes present to the mind of physics. In particular, it fits neatly with Einstein's seminal law of relativity. Black holes have long been a thorn in this idea's side. Relativity states that we live in a four-dimensional universe, where space and time are relative to your movement through these dimensions, while the force of gravity curves and warps both space and time in strange ways. It's a theory that has been repeatedly demonstrated in the universe as we know it. But apply it to black holes, the idea falls apart. That's because quantum mechanics hasn't been brought in. Until now, the concept of a two-directional entropy hologram being part of an event horizon appears to preserve relativity's role at the center of our understanding of physics, along with quantum mechanics. But, like all of physics, it needs to be put to the test repeatedly. No tell. I love this idea. It's great. Okay, so I think I am just about done. Okay, so basically I found all these connections. And it all really makes a lot of sense. So, I will just leave it here. This is going to be another, looks like, 20 minutes. And, yeah, that's plenty of time. So basically, everything combined, I did, like 44 minutes, and 8 minutes, that's 52. This is going to be, so it looks like another 20 minutes. So, 20 minutes, let's see, what did I do? So yeah, it's probably a little bit over an hour. But still, shorter than shorter of the two long ones. So that one was an hour 20 minutes, so it's maybe like like an hour 15 minutes, maybe a little less than that. So hopefully you like the discussion, that we got everything done. And I will see you on my social media. Okay, take care, everybody. Okay, this is going to be quick because I actually found some more proof for our cyclic model, so I wanted to go through with it really quick. This is from Cornell University. The first one is the Planck 2013 satellite results, and this is Origin Update 38. And here we go. Okay, we show that the results from the Planck satellite reported in 2013 are consistent with the simplest cyclic models for natural parameter ranges. That is, order unity dimensionless coefficients, assuming the standard entropic mechanism for generating curvature perturbations. With improving precision, forthcoming results from Planck and other experiments should be able to test the parameter ranges by confirming or refuting the core predictions. That is, no observable primordial B-mode polarization, detectable local non-Gaussianity. A new prediction given Planck 2013 constraints on the bispectrum is a sharp constraint on the local trispectrum parameter G underscore sub NL. Namely, the simplest models predicted is negative, with G underscore subscript NL less than minus 17. Okay, and here is the robustness of key features of loop quantum cosmology. Loop quantum cosmology of the k equals 0 FRW model with a Maxwell scalar field is shown to be exactly soluble if the scalar field is used of the internal time already in the classical theory. And analytical methods are then used, one, to show that the quantum bound is generic, and two, to establish that the matter density has an absolute upper bound, which furthermore equals the critical density that first emerged in numerical simulations and effective equations. 3, to bring out the precise sense in which the Wheeler-DeWitt theory approximates loop quantum cosmology and the sense in which this approximation agrees. And 4, to show that discreteness underlying LQC is fundamental. Finally, the model is compared to analogous discussions in the literature. An effort has been made to make the underlying structure transparent and also to those who are not familiar with details of loop quantum cosmology. Two changes from the published version. Use of the scalar field plot already in classical field theory leads to a soluble model without any assumptions. LQC now stands for soluble rather than simplified LQC. Some intermediate steps corrected, also simplified the analysis. Final results unchanged. Now here's the research from Nikodym Poplawski, very popular, figures very strongly into the new models. The Einstein-Cartan-Sciama Kibble theory of gravity removes the constraint of general relativity that the affine connection be symmetric by regarding its asymmetric part, the torsion tensor, as a dynamic variable. The minimal coupling between the torsion tensor and direct spinors generates a spin-spin interaction which is significant in fermionic matter at extremely high densities. We show that such an interaction averts the unphysical Big Bang singularity, replacing it with a cusp-like bounce at a finite minimum scale factor before which the universe was contracting. This scenario also explains why the present universe at larger scales appears spatially flat, homogeneous, and isotropic. Landmark study. Okay, and here is towards a non-singular bouncing cosmology. We present a non-singular bouncing cosmology using a single scalar field matter with non-trivial potential and non-standard kinetic terms. The potential source is a dynamical attractor solution with equiparatic contraction which washes out small amplitude anisotrophies. At high energy densities, the field evolves into a ghost condensate, leading to a non-singular bounce. Following the bounce, there is a smooth transition to standard expanding radiation and matter-dominated phases. Using linear cosmological perturbation theory, we track each Fourier mode of the curvature fluctuation throughout the entire cosmic evolution. Using standard matching conditions for non-singular bouncing cosmologies, we verify that the spectral index does not change during the bounce. We show that there is a controlled period of exponential growth of the fluctuation amplitude for the perturbations, but not for the gravitational waves, around the bounce point, which does not invalidate the perturbative treatment. This growth induces a natural suppression mechanism for the tensor scalar ratio of the fluctuations. Moreover, we study the generation of the primordial power spectrum of curvature fluctuations for various types of initial conditions. For the pure vacuum initial condition on scales which exit the Hubble radius in the phase of equiparatic contraction, the spectrum is deeply blue. For thermal particle initial condition, one possibility for generating a scale invariant spectrum makes use of the special value of the background equation of state during the contracting equiparatic phase if the equiparatic phase is preceded by a period of matter-dominated contraction. The primordial power spectrum is nearly scale invariant on large scales, scales which exit the Hubble radius in the matter-dominated phase, but acquires a large blue tilt on small scales. Okay, and then there's one more. Bouncing cosmologies progress. We reviewed the status of bouncing cosmologies as alternatives to cosmological inflation for providing a description of the very early universe, and a source for the cosmological perturbations which are observed today. We focus on the motivation for considering bouncing cosmologies, the origin of fluctuations in these models. And also, we go forward and compare the models to each other to see which one compares the best with observations that have been made both with visible and infrared data. Okay, so that's basically it. So this is basically not just loop quantum cosmology, it's also string theory and a bunch of other cosmologies. So we were talking about the universe contracting, and as it contracts, we notice that dimensionality goes down to 2 dimensions or 1 dimension. Gravity basically ceases to be an attractive force and repel and upgrade the cycle of the universe. So, that's why there's a critical density. Once it reaches that density, gravity spells it out. Basically causes it to bounce. And it's not just one bounce, it's not singular, meaning it happens over and over again. At least as many times as it would take for the cosmological constant to go from 1 to 0. Okay. Now, is definitely going to be final one for the first book, 38 parts. I did put part 33 and 34 aside because 33 and 34 are very long. I mean, one of them is 4 hours long, the other one is almost an hour and a half. So, if you do want to listen and watch those, I will add them to a separate video. So by the way, when he mentioned, when Nitin Pawlowski mentioned the clutch-like valves, with non-singular valves cosmology, what he's actually talking about is a bounce that occurs without hitting the bottom. In other words, there is no singularity. It goes to a very small size of cusp. It's a U-shape cusp. And then it comes right back. And it makes it all the more interesting. Because parts of the previous universe could still be preserved because of that cusp structure. Since it does not go down to a 0-point size. It's a finite minimum scale factor. And in the sequel, I'll also explain more about what causes the other dynamic and opposite effect, which is when it's all the way 4 dimensions, it bumps up against the second Cauchy horizon of the superverse, and then snaps back like a rubber band and starts contracting. And the time verses start converging. The second temporal dimension combined for the next 6 times. And then emerge again, diverge, second temporal dimension, etc., etc. Maximum separation is achieved in the fourth one. The universe has 4 spatial dimensions, right as it's about to hit the event, the second Cauchy horizon of the superverse inside the black hole that we inhabit, that our universe inhabits. Anyway, that should do it. I guess I will look forward to the comments, and you can also contact me on social media, etc., etc. Okay, alright, take care, guys. Hi, guys, I just wanted to quickly do an update, because I found some more interesting connections, especially with this negative space that I've been talking about, the antiverse. Right, the article that I had recently mentioned. Now we get more confirmation from Penrose diagrams. Now, Penrose diagrams are basically about black holes and the interior geometry of them. As we know, static black holes are not traversable, but either spinning, rotating, or charged black holes can be, which makes it highly interesting. Penrose diagrams are often used to illustrate the hypothetical Einstein-Rosen bridge connecting 2 separate universes in the black hole solution. Now, a time-like wormhole allowing passage into future universes. In the case of the rotating black hole, there is also a negative universe entered through a ring-shaped singularity, still portrayed as a line in the diagram, that can be passed through its entering the hole close to its axis of rotation. Need some careful flying technique here, if we can ever get to one. Now, it's not an exact solution. We really don't know what the exact true character of the series is, but all Hi all. There was a problem with the encoding of part 40 of the Origin series, so I have to redo this part. It was about 40 minutes long, so hold on. I am going to go back to my notes and go back to what I had done in part 40 and redo it so that there is nothing missing from the series. So in part 40, the first thing we discussed was Penrose diagrams and black holes. Now, Penrose diagrams are frequently used to illustrate the causal structure of spacetime containing black holes. Singularities are denoted by a space-like boundary, unlike the time-like boundary found on conventional space-time diagrams. This is due to the interchanging of time-like and space-like coordinates within the horizon of a black hole. Since space is unidirectional within the horizon just as time is unidirectional outside the horizon. The singularity is represented by a space-like boundary to make it clear that once an object has passed the horizon, it will inevitably hit the singularity even if it attempts to take a wave of action. This is only for Schwarzschild black holes, the standard. Penrose diagrams are often used to illustrate the hypothetical Einstein-Rosen bridge connecting two separate universes in the Schwarzschild black hole solution. The Penrose diagrams adds conformal crunching to the regions of flat space-time far from the hole. These introduce the method of aligning the event horizon into past and future horizons oriented at 45 degrees. Since one would need to travel faster than light to cross from the Schwarzschild radius back into flat space-time, and splitting a singularity into past and future horizontally oriented lines. Since the singularity cuts off all paths into the future once it enters the hole. The Einstein-Rosen bridge closes off forming future singularities so rapidly that passes between the two asymptotically flat exterior regions would require faster light travel. In addition, highly blue-shifted light rays called a blue sheet are right at the wall. The maximally extended solution does not describe a typical black hole created from the collapse of a star, as the opening of the collapsed star replaces the sector of the solution containing the past-oriented white hole geometry in other universe. While the basic space-like passage of a static black hole cannot be traversed, the Penrose diagram for solutions representing rotating and electrically charged black holes illustrates these solutions' inner event horizons lying in the future and vertically oriented singularities, which open up what is known as a time-like wormhole on passage into future universes. In the case of the rotating hole, there is also a negative universe, an antiverse, as we have discussed, entered through a ring-shaped singularity, still portrayed as a line in the diagram, that can be passed through if entering the hole close to its axis of rotation. Okay, now, we are going to discuss the curve geometry, or the curve metric. Curve metric is for rotating black holes. The curve metric, or curve geometry, describes the geometry of empty spacetime around a rotating, uncharged, axially symmetric black hole with a quasi-spherical event horizon. The curve metric is an exact solution of Einstein's field equations of general relativity. Okay, so going back into the curve solution. The curve geometry exhibits many noteworthy features. The maximum analytic extension includes a sequence of asymptotically flat exterior regions, each associated with an ergosphere, stationary limit surfaces, event horizons, calculus horizons, closed time-like curves, and a ring-shaped curvature singularity. Very interesting. The geodesic equation can be solved exactly in closed form. The surface on which light can orbit on a black hole is called a photon sphere. The curved solution has infinitely many photon spheres lying between an inner and an outer one. In a non-rotating Schwarzschild solution with A equals O, the inner and outer photon sphere degenerate so that there is only one photon sphere at a single radius. The greater the spin of the black hole, the further from each other the inner and outer photon spheres move. A beam of light traveling in a direction opposite to the spin of the black hole will circularly orbit the hole at the outer photon sphere. a beam of light traveling in the same direction as the black hole spin will circulate the orbit at the inner photon sphere, orbiting geodesics with some angular momentum perpendicular to the axis of rotation of the black hole orbit on photon spheres between these two streams. Okay, so you have the beam of light traveling in direction opposite to the spin of the black hole is at the outer photon sphere, and the beam of light traveling in the same direction, the inner photon sphere. Because the space-time is rotating, such orbits exhibit a precession, since there is a shift in the theta variable after completing one period in this variable. The photon sphere is located further from the center of a black hole than the event horizon. Within a photon sphere, it is possible to imagine a photon that's emitted from the back of one's head, orbited the black hole, only then to be intercepted by the person's eyes, allowing one to see the back of the head. For non-rotating black hole, photon sphere is a sphere of radius 3/2 r sub s. There are no stable free-fall orbits that exist within or across the photon sphere. Any free-fall orbit that crosses it from the outside spirals into the black hole. Any orbit that crosses it from the inside escapes to infinity or falls back in and spirals into the black hole. An unaccelerated orbit with a semi-major axis less than distance is possible, but within the photon sphere, constant acceleration will allow the spacecraft to hover above the event horizon. Another property of the photon sphere is centrifugal force reversal. Outside the photon sphere, the faster one orbits, the greater the outward force one feels. Centrifugal force falls to zero at the photon sphere, including non-free-fall orbits at any speed. That is, U weigh the same no matter how fast you orbit, to become a negative inside it. Inside the photon sphere, the faster you orbit, the greater your felt weight, or inward force. This has serious ramifications for the fluid dynamics of inward fluid flow. A rotating black hole has two photon spheres. As the black hole rotates, it drags space with it. The photon sphere that is closer to the black hole is moving in the same direction as the rotation, whereas the photon sphere further away is moving against it. The greater the angular velocity of the rotation of the black hole, the greater the distance between the two photon spheres. Since the black hole has an axis of rotation, this only holds true if approaching the black hole in the direction of the equator. If approaching at a different angle, such as from the poles of the black hole to the equator, there is only one photon sphere. This is because approaching at this angle, the possibility of traveling with or against the rotation does not exist. In contrast to a short-star black hole, a curved-spinning black hole does not have spherical symmetry, but only an axis symmetry, which has profound consequences for the photon orbits. A circular orbit can only exist in the equatorial plane, and there are two of them, prograde and retrograde, with different radii. There exist other constant coordinate radius orbits, but they have more complicated paths which oscillate in latitude about the equator. Okay, so we are going to now go back to the term metric. Location of the event horizon is determined by the larger root of delta equals 0. When r sub s divided by 2 is less than alpha, g m2, g stands for the gravitational constant, mass squared is less than jc. There are no real value solutions to this equation, and there is no event horizon. With no event horizon, to hide it from the rest of the universe, the black hole ceases to be a black hole, and will instead be a naked singularity. Although the curved solution appears to be singular at the roots of delta equals 0, these are actually coordinate singularities. And with an appropriate choice of new coordinates, the curved solution can be smoothly extended through the values of R corresponding to these roots. The larger of these roots determines the location of the event horizon, the smaller determines the location of a Cauchy horizon. A future directed timeline curve can start in the exterior and pass through the event horizon. Once having passed through the event horizon, the R coordinate now behaves like the time coordinate, so it must decrease until the curve passes through the Cauchy horizon. The region beyond the Cauchy horizon has several surprising features. The R coordinate again behaves like a spatial coordinate and can vary freely. The interior region has a reflection symmetry, so that a future directed timeline curve may continue along a symmetric path which continues through a second Cauchy horizon and through a second event horizon and out into a new exterior region, which is isometric to the original exterior region of the curve solution. So basically you're going through two event horizons and two Cauchy horizons. The curve could then escape to infinity in the new region, or enter the future event horizon of the new exterior region and repeat the process. The second exterior is sometimes thought of as another universe. On the other hand, in the curve solution, the singularity is a ring, and the curve may pass through the center of this ring. The region beyond permits closed timeline curves. Since the trajectory of observers and particles in general relativity are described by timeline curves, it is possible for observers in this region to return to their past. This interior solution is not likely to be physical, and is considered mathematical. While it is expected the exterior region of the curve solution is stable and that all rotating black holes will eventually approach a curve metric. It's like a pencil balanced on its point. Okay, so the curve geometry is often used as a model of a rotating black hole. But if we hold the solution to be valid only outside some compact region subject to certain restrictions in principle, we should be able to use it as an exterior solution to model the gravitational field around the rotating massive object other than a black hole, such as a neutron star or the Earth. This works out very nicely for the non-rotating case where we can match the Schwarzschild vacuum exterior to a Schwarzschild fluid interior, and indeed more general static, spherical, symmetric, perfect fluid solutions. Okay, so we are going to into what a Cauchy horizon is. Cauchy horizon is a light-like boundary of the domain of validity of a Cauchy problem. Particular boundary value problem in the theory of partial differential equations. One side of a horizon contains space-like geodesics and the other side contains closed time-like geodesics. Named after Augustine Louis Cauchy. Under average weak energy conditions, AWAC, Cauchy horizons are inherently unstable. However, cases of AWAC violations, such as the Casimir effect caused by periodic boundary conditions, do exist, and since the region of spacetime inside the Cauchy horizon has closed time-like curves, it is subject to periodic boundary conditions. If the spacetime inside the Cauchy horizon violates AWAC, then the horizon becomes stable and frequency boosting effects will be cancelled out by the tendency of the spacetime to act as a divergent length. Were this conjecture to be shown empirically true, it would provide a counterexample to the strong cosmic censorship conjecture, and this is where we are headed, so that's a heads up. In 2018, it was shown that the spacetime beyond the Cauchy horizon of a charged, rotating black hole exists, but is not smooth, so the strong cosmic conjecture is false. And we are headed here. Simplest example is the internal horizon of a Reisner-Nordstrom black hole. Reisner-Nordstrom is a charged black hole. So, just letting you know where we're headed. Now we're talking about the Kerr-Newman metric. This is basically taking Kerr metric and expanding it to active galactic nuclei and supermassive black holes. So I can go back, and we can now talk about mathematicians disprove conjecture made to save black holes. Mathematicians have disproved the strong cosmic censorship conjecture. Their work answers one of the most important questions in the study of general relativity and changes the way we think about space-time. This is very, very important. Nearly 40 years after it was proposed, mathematicians have settled one of the most profound questions in the study of general relativity. It has been proven that the strong cosmic censorship conjecture, which concerns the strange inner working of black holes, is false. This is a tremendous achievement. The strong cosmic censorship conjecture was proposed in 1979 by Roger Penrose. It was meant as a way out of a trap. For decades, Albert Einstein's theory of general relativity had reigned as the best scientific description of large-scale phenomena in the universe. Yet, mathematical advances in the 60s showed that Einstein's equations lapsed into troubling inconsistencies when applied to black holes. Penrose believed that if his strong cosmic censorship conjecture were true, this lack of predictability could be disregarded as a mathematical novelty, rather than a sincere statement about the physical world. Penrose came up with a conjecture that basically tried to wish this bad behavior away. This new work dashes Penrose's dream. At the same time, it fulfills his ambition by other means, showing that his intuition about the physics inside black holes was correct, just not for the reason he suspected. In classical physics, the universe is predictable. If you know the laws that govern a physical system, and you know its initial state, you should be able to track its evolution indefinitely far into the future. The dictum holds true whether you're using Newton's laws to predict the future positions of a billiard ball, Maxwell's equations to describe the electromagnetic field, or Einstein's theory of general relativity to predict the evolution of the shape of space-time. This is the basic principle of all classical physics, going back to Newtonian mechanics. You can determine evolution from initial data. But in the 1960s, mathematicians found a physical scenario in which Einstein's field equations, which form the core of general relativity, ceased to describe a predictable universe. Mathematicians and physicists noticed that something went wrong when they modeled the evolution of space-time inside a rotating black hole. To understand what went wrong, imagine falling into the black hole yourself. First, you cross the event horizon, the point of no return, though it looks just like ordinary space to you. Here, Einstein's equations still work as they should, providing a single deterministic forecast for how space-time will evolve into the future. Black holes' other horizon. Past the event horizon and black holes' point of no return lies the Cauchy horizon. The second horizon has given mathematicians headaches for decades. Troublesome boundaries. Einstein's equations appear to give many different possible answers beyond the Cauchy horizon, which would suggest that the universe is fundamentally unpredictable. Block it off. The strong cosmic censorship conjecture says that space-time stops at the Cauchy horizon, which absolves Einstein's equations of having to describe the world beyond. Weak but effective. New research shows that space-time does exist beyond the horizon, but it isn't smooth enough to use the Einstein equations, thus saving determinism. For now. Just for now. But as you continue to travel into the black hole, eventually you pass another horizon. known as the Cauchy horizon. Here things get screwy. Einstein's equations start to report that many different configurations of spacetime could unfold. They're all different, yet they all satisfy the equations. The theory cannot tell us which option is true. For a physical theory, it's a cardinal sin. The loss of predictability that we seem to find in general relativity was very disturbing. Roger Penrose proposed a strong cosmic censorship conjecture to restore predictability to Einstein's equations. The conjecture said that the Cauchy horizon is a figment of mathematical thought. It might exist in an idealized scenario where the universe contains nothing but a single rotating black hole, but it can't exist in any real sense. The reason Penrose argued is that the Cauchy horizon is unstable. He said that any passing gravitational wave should collapse the Cauchy horizon into a singularity, a region of infinite density that rips space-time apart. Because the actual universe is rippled with these waves, a Cauchy horizon should never occur in the wild. As a result, it's nonsensical to ask what happens to space-time beyond the Cauchy horizon, because space-time as it's regarded within our theory of general relativity no longer exists. This gives us a way out of this philosophical conundrum. This new work, however, shows that the boundary of space-time established at the Cauchy horizon is less singular than Penrose had imagined. It was proved that the situation at the Cauchy horizon is not quite so simple. Their work is subtle. A refutation of Penrose's original statement of the strong cosmic censorship conjecture, but not a complete denial of its theory. Building on methods established a decade ago, the pair showed that the Cauchy horizon can indeed form a singularity, but not the kind Penrose anticipated. The singularity is milder than Penrose, as they find a weak, light-like singularity where he had expected a strong space-like singularity. This weaker form of singularity exerts a pull on the fabric of space-time but doesn't sunder it. Our theorem implies that observers crossing the Cauchy horizon are not torn apart by tidal forces. They may feel a pinch, but they are not torn apart. Because the singularity that forms at the Cauchy horizon is in fact milder than predicted by the strong cosmic censorship conjecture, the theory of general relativity is not immediately excused from considering what happens inside. It still makes sense to define the Cauchy horizon because one can, if one wishes, continuously extend the space-time beyond it. They proved that space-time extends beyond the Cauchy horizon. They also proved that the same starting point can extend in any number of ways. Past the horizon, there are many such extensions that one could entertain, and there is no good reason to prefer one to the other. Yet, and here's the subtlety in their work, these non-unique extensions of space-time don't mean that Einstein's equations go haywire beyond the horizon. Einstein's equations work by quantifying how space-time changes over time. In mathematical language, it takes derivatives of an initial configuration of space-time. In order for it to be possible to take a derivative, space-time has to be sufficiently smooth, free of discontinuous jumps. It was indicated that while space-time exists beyond the Cauchy horizon, this extent of space-time isn't smooth enough to actually satisfy Einstein's equations. Thus, even with the strong cosmic censorship proven false, the equations would still spare the ignominy of outputting non-unique solutions. It makes sense to talk of the Cauchy horizon, however, you can continue beyond it as a solution of Einstein's equations. We have offered pretty convincing evidence that that is true. You could think of this outcome as a disappointing compromise. Even though you can extend space-time beyond the Cauchy horizon, Einstein's equations can't be solved. But it's precisely the fact that this middle ground seems to exist that makes this work so interesting. This is people really discovering a new phenomenon in the Einstein equations. So now, we are going to talk about this work. the interior of dynamical vacuum black holes. CO stability of the current Cauchy horizon. We initiate a series of works where we study the interior of dynamical rotating vacuum black holes without symmetry. In the present paper, we take up the problem starting from appropriate Cauchy data for the Einstein vacuum equation defined on a hypersurface already within the black hole interior, representing the expected geometry just inside the event horizon. We prove that for all such data, the maximal Cauchy evolution can be extended across a non-trivial Cauchy horizon as a Lorentzian manifold with continuous metric. In subsequent work, we will retrieve our assumptions on data, assuming only that the black hole event horizon geometry suitably asymptotes to a rotating Kerr solution. In particular, if the exterior region of the Kerr family is proven to be dynamically stable, as is widely expected, then it will follow that the CO inextendability formulation of Penrose's celebrated strong cosmic censorship conjecture is in fact false. The proof suggests, however, that CO metric Cauchy horizons thus arising are generally singular in an essential way, representing the so-called weak null singularities, and thus that a revised version of strong cosmic censorship holds. Okay. So, before we go any further, I wanted to introduce these Penrose diagrams. First is the Penrose diagram of a Schwarzschild black hole. Penrose diagram shows that the horizon is really two distinct entities, the horizon and the anti-horizon. The horizon is sometimes called the true horizon. It's the horizon you actually fall through if you fall into a black hole. The anti-horizon might reasonably be called the illusory horizon. In a real black hole formed from the collapse of the core of a star, the illusory horizon is replaced by an exponentially redshifted image of the collapsing star. As the collapsing star settles towards its final no-hair state, its appearance tends to be that of a no-hair black hole. Penrose diagram illustrates that light rays that start from the anti-horizon or from the horizon and hit the observer. The diagram shows that when you look at the black hole from the outside, you are looking at its anti-horizon or illusory horizon. When you fall through the horizon, you fall not through the anti-horizon, but rather through the horizon or true horizon. The horizon becomes visible only after you have fallen through it. The anti-horizon continues to remain ahead of you, and you never fall through it. What is beyond the anti-horizon of a black hole? In a real black hole, the other side of the anti-horizon or illusory horizon is a star that collapsed, redshifted to blackness. However, the Schwarzschild geometry is a simple mathematical form, and that form can be extended analytically. The mathematical extension consists of a second copy of the Schwarzschild geometry reversed in time, glued along the anti-horizon. The complete analytical extension of the Schwarzschild geometry contains not only a universe and a black hole, but also a parallel universe and a white hole. This is a mathematical construction, and it's amazing, although cute, that even the simplest kind of black hole, a Schwarzschild black hole, harbors alien mathematical passageways. Okay, now moving on to charged or Reisner-Nordstrom black holes. Shows on inpolar sees infinitely bright, infinitely blue-shifted bursts of light. On passing inward through the inner horizon, the inpolar sees the infinite past of the universe, reflected in the gravitationally repulsive singularity. On passing back through the inner horizon, the inpolar sees the infinite future of the universe. On passing outward through the outer horizon of the white hole, the infaller sees the infinite past of the new universe. Penrose diagram of an extremal Reisner-Nordstrom black hole. Horizon exists only if the black hole's charge Q is less than or equal to its mass, and in natural units. The extreme case where the charge equals the mass is called an extremal black hole. For an extremal black hole, the inner and outer horizons coincide. As illustrated by its Penrose diagram, the topology of an extremal Reisner-Nordstrom black hole differs from the standard Reisner-Nordstrom topology. For this reason and others, it is thought that an extremal Reisner-Nordstrom black hole cannot be constructed even in principle by adding charge to a standard Reisner-Nordstrom black hole. Indeed, adding charge to a near extremal black hole takes energy, which increases the mass of the black hole, keeping it sub-extremal. Mathematical solutions for super extremely wide Nordstrom black holes, those with charge exceeding mass, have no horizons at all, which is an even more drastic change in topology. Real charged particles, such as electrons and protons, have charge greatly exceeding their mass. For example, an electron has a charge to mass of E divided by ME is equivalent to 10 to the power 21, the ratio of the square root of the fine structure constant of the electron mass in Planck units. However, the character of such particles is dominated by quantum mechanics, not by classical general relativity. Now we're moving on to Kerr spinning rotating black holes. The Penrose diagram of the Kerr geometry for a rotating black hole looks like the Penrose diagram of the Weisner-Nordstrom geometry for a charged black hole, except that it is possible to pass through the disk bounded by the ring singularity of the rotating black hole to an anti-burst. Ah, now the fun begins. The anti-burst. So basically here we have two parallel paths, one to the new universe, one to the new parallel universe, intersected by a white hole, and then you have a parallel antiverse, a parallel wormhole, an antiverse and a wormhole, back through the black hole, and then the parallel universe and the universe. Very interesting. Okay. So, let's see how far we can go with this. The ring singularity or regularity is the gravitational singularity of a rotating black hole or a curved black hole that is shaped like a ring. When a spherical non-rotating body of a critical radius collapses under its own gravitation under general relativity, theory suggests it will collapse to a single point. This is not the case with the rotating black hole, a curved black hole. With the fluid rotating body, its distribution of mass is not spherical, it shows an equatorial bulge, and if it has angular momentum, since a point cannot support rotation or angular momentum in classical physics, the minimal shape of the singularity that can support these properties is instead a ring with zero thickness but non-zero radius, and this is referred to as a ringularity or Kerr singularity. A rotating hole's rotational crane dragging effects described by the Kerr metric cause the space-time in the vicinity of the ring to undergo curvature in the direction of the ring's motion. Effectively, this means that different observers placed around a Kerr black hole are asked to point to the hole's apparent center of gravity, then point to different points on the ring. Falling objects will begin to acquire angular momentum from the ring before they can actually strike it, and the path taken by a perpendicular light ray, initially traveling towards the ring's center, will curve in the direction of ring motion before intersecting with the ring. An observer crossing the event horizon of a non-rotating and uncharged black hole or Schwarzschild black hole cannot avoid the central singularity, which lies in the future world line of everything within the horizon. This is not necessarily true with the Kerr black hole. An observer falling into a Kerr black hole may be able to avoid the central singularity by making clever use of the inner event horizon associated with this class of black hole. This makes it theoretically possible for the Kerr black hole to act as a sort of wormhole, possibly even a traversable wormhole. The Kerr singularity can also be used as a mathematical tool to study wormhole theoretic problem. If a particle is passed through a wormhole, the continuity equation to the electrical field suggests that the field line should not be broken. When electrical charge passes through a wormhole, the particle's charge field line appears to emanate from the entry mouth, and exit mouth gains a charge density deficit due to the Bernoulli's principle. For mass, the entry mouth gains mass density, and the exit mouth gains a mass density deficit. If the Kerr singularity has the same feature, it also allows the issue to be studied. It is generally expected that since the usual classical point singularity under general relativity involves arbitrarily dense conditions, quantum effects may become significant to prevent the singularity from quantum fuzz. Without quantum gravitational effects, there is good reason to suspect that the interior geometry of a rotating black hole is Kerr geometry. The inner event horizon of the Kerr geometry is probably stable due to the infinite blue shifting of infalling radiation. The observed observation was supported by the investigation of charged black holes, which exhibited similar infinite blue shifting behavior. So, a Wormhole-Einstein-Rosen bridge is a speculative structure linking disparate points in space that is based on a special solution of the Einstein field equations. It is a transcendental bijection of the space-time continuum, an asymptotic projection of the Cauchy-Yell manifold in manifesting itself in anti-de Sitter space. A wormhole can be visualized as a tunnel with two ends at separate points in space-time. Different locations, different points in time, or space, or both. Wormholes are consistent with geometry of relativity, and sometimes it's postulated wormholes are projections of a fourth spatial dimension, and analogous to a two-dimensional 2D being only experience only part of three-dimensional space. Theoretically, a wormhole might connect extremely long distances, such as a billion light years, or short distances, such as a few meters, or different points in time, or even different universes. In 1995, it suggested that there may be many wormholes in the universe if cosmic strings with negative mass were generated in the early universe. Some physicists have suggested how to make wormholes artificially. Okay, so four-dimensional space is really interesting. We're talking about a hypersphere, which is a three-dimensional sphere extended into a fourth dimension. Four-dimensional cube, also called a tesseract. You draw two ordinary 3D cubes in 2D space, one encompassing the other separated by an unseen distance, and then draw a line between their equivalent shapes and their vertices. This can be seen in the animation, one of which shows a smaller inner cube inside a larger outer cube. The A-lines connecting the vertices of the two cubes escape rivers in a single direction in the unseen fourth dimension. Higher dimensional spaces have become a way of formally expressing modern mathematics and physics. Einstein's concept of space-time uses such a 4D space, though it has a Minkowski structure that is slightly more complicated than Euclidean 4D space. Coordinates are x, y, z, and then w. So we don't go back to A, it's x, y, z, w. There's only one such location that are linked together into more complicated shapes that the full richness and geometric complexity of higher dimensional spaces emerges. And into that complexity can be seen in the accompanying animation of one of the simplest possible 4D objects, the tesseract, also called a hypercube. The geometry of four-dimensional space is much more complex than that of three-dimensional space due to the extra degree of freedom. Less than 3 dimensions, there are polyhedra made of 2-dimensional polygons. In 4 dimensions, there are 4 polytopes made of polyhedra. In 3 dimensions, there are 5 regular polyhedra known as the platonic solids. In 4 dimensions, there are 6 convex regular polytopes, the analogs of the platonic solids. Relaxing the conditions for regularity generates a further 58 convex uniform for polytropic analogies to the 13 semi-regular Archimedean solids in 3 dimensions. Relaxing the condition for convexity generates a further 10 non-convex for polytropics. A hypersphere is the 4D version of a sphere. A set of points in the Euclidean fourth space having the same distance r from a fixed point PO forms a hypersurface known as a 3-sphere. Hypervolume, the enclosed space, is V equals half pi squared r quadruple. This is part of the Friedman, Lemaitre, Robertson, Walker metric in general relativity, where r is substituted by the function rt, with t meaning the cosmological age of the universe. Remember though, we need scale. Scale is what actually measures the universe. Growing or shrinking orbit time means expanding or collapsing universe depending on the mass, density, and size. Research using virtual reality finds that humans, in spite of living in a 3-dimensional world, can, without special practice, make spatial judgments about line segments embedded in 4-dimensional space, based on their length, 1-dimensional, and the angle, 2-dimensional, between them. The researchers noted that the participants in our study had minimal practice in these tasks, and it remains an open question whether it is possible to obtain more sustainable, definitive, and richer 4D representations with increased perceptual experience in 4D virtual environments. In another study, the ability of humans to orient themselves in 2D, 3D, and 4D mazes has been tested. Each maze consists of 4 path segments of random lines connected with orthogonal random bands, but without branches or loops. Actually labyrinths. The graphical interface is based on John McIntosh's free 4D maze game. The participants had to navigate through the path and finally estimate the linear direction back to the starting point. The researchers found that some of the participants were able to mentally integrate their path after some practice in 4D. To understand the nature of 4-dimensional space, a device called dimensional analogy is commonly employed. Dimensional analogy is the study of how n-1 dimensions relate to n dimensions, and then inferring how n dimensions relate to n plus 1 dimensions. Dimensional analogy was used by our Edwin Abbott in the book Flatland, which narrates the story about a square lives in a 2-dimensional world like the surface of a piece of paper. From the perspective of the square, a 3-dimensional being has seemingly godlike power, such as the ability to remove objects from the same without breaking it open, by moving them across the 3rd dimension. See everything that, from a 2-dimensional perspective, is enclosed behind walls, and to remain completely invisible by standing a few inches away in the 3rd dimension. By applying dimensional analogy, one can infer that a 4-dimensional being would be capable of similar feats from a 3-dimensional perspective. Rudy Rucker illustrates this out of Spaceland, in which the protagonist encounters 4-dimensional beings who demonstrate such power. Three-dimensional object passes through a 2-dimensional plane. 2-dimensional beings in this plane would only observe a cross-section of 3-dimensional object within this plane. For example, if a spherical balloon passed through a sheet of paper, beings in the paper would see first a single point, so that the circle is gradually growing larger until it reaches the diameter of the balloon, then getting smaller again, until it shrank to a point and then disappeared. It is important to note that 2D beings would not see a circle the same way as we do. Rather, only a 1-dimensional projection of the circle on their 1-dimensional web. Similarly, if a 4-dimensional object passed through a 3-dimensional hypersurface, one could observe a 3-dimensional cross-section of a 4-dimensional object. For example, a 3-sphere would appear first as a point of a growing sphere, with the sphere then shrinking to a point and then disappearing. This means of visualizing aspects of the 4th dimension was used in the novel Flatland, and also the several works of Charles Howard Hinton. And in the same way, 3-dimensional beings such as humans with a 2-dimensional retina are unable to see a sphere in its entirety in the same way that 4D beings would with their 3D solid world. A useful application of dimensional analogy in visualizing higher dimensions is projection. A projection is a way of representing an n-dimensional object in n-1 dimensions. For instance, computer screens are two-dimensional, and all the photographs of three-dimensional people, places, and things are represented in three dimensions by projecting the object onto a flat surface. By doing this, the dimensional orthogonal depth of the screen is removed and replaced with indirect information. The retina of the eye is also a two-dimensional array of receptors that the brain is able to perceive the nature of three-dimensional objects by inference from indirect information, like shading, foreshortening, binocular vision, etc. Artists often use perspective to give an illusion of three-dimensional depth to two-dimensional pictures. The shadow cast by a fictional grid model results in a tesseract on a plane surface as shown in the figure is also the result of projections. Similarly, objects in the fourth dimension can be mathematically projected into the familiar three dimensions where they can be more conveniently examined. In this case, the retina of the four-dimensional eye is a three-dimensional array of receptors. The hypothetical being with such an eye would perceive the nature of four-dimensional objects by inferring four-dimensional depth from indirect information with three-dimensional images in the retina. The perspective projection of three-dimensional objects into the retina of the eye introduces artifacts such as foreshortening, which the brain interprets as depth in the third dimension. In the same way, perspective projection from four dimensions produces similarly foreshortening effects. By applying dimensional analogy, one may infer four-dimensional depth from these effects. Column sequence of images comparing various views in three-dimensional cube with analogous projections of the four-dimensional tesseract into three-dimensional space. Okay, let's now go to this. This is an article about wormholes and entanglement, which we already talked about. ER equals EPR. Now we're going to go more in depth into it and how it might combine some quantum mind theories like intuition, empathy, and how we're all connected. Wormholes, shortcuts that in theory can connect distant points in the universe, might be linked with the spooky phenomenon of quantum entanglement, where the behavior of particles can be connected regardless of distance. These findings could help scientists explain the universe from its very smallest to its biggest scales. Scientists have long sought to develop a theory that can describe how the cosmos works in its entirety. Currently, researchers have two disparate theories, quantum mechanics and general relativity, which can mostly explain the universe on its tiniest and largest scales, respectively. These are currently several competing theories seeking to reconcile them. One prediction of theory of general relativity devised by Einstein involves wormholes, also known as Einstein-Rosen bridges. In principle, these warps in the fabric of space and time can behave like shortcuts, connecting any black holes in the universe to become a common staple of sci-fi. Intriguingly, quantum mechanics also has a phenomenon that can link objects such as electrons, regardless of how far apart they are. Quantum entanglement. This is true even when the electrons are light years apart. Einstein derisively called this significantly impossible connection spooky action at a distance. However, numerous experiments have proven quantum entanglement is real, and it may serve as a foundation of advanced future technologies such as incredibly powerful quantum computers and nearly unhackable quantum encryption. Entanglement is one of the most bizarre but important features of quantum mechanics. And if entanglement really is connected to wormholes, that could help reconcile quantum mechanics with general relativity, the two examples of this phenomenon on tiny and deep scales. Recently, theoretical physicists Baldacci and Susskind argued that wormholes are linked with entanglement. Specifically, it suggested that wormholes are each pairs of black holes that are entangled with one another. Entangled black holes can be generated in any number of ways. For instance, a pair of black holes could in principle be made simultaneously, and these would automatically be entangled. Alternatively, radiation given off by a black hole could be captured and then collapsed into a black hole, and the resulting black hole would be entangled with the black hole that supplied the ingredients for it. Lucina and Susskind not only suggested that wormholes are entangled black holes, but they argued that entanglement in general was linked to wormholes. They conjectured that entangled particles such as electrons and photons were connected by extraordinarily tiny wormholes. Yeah, called micro wormholes. So now we're talking about throats of wormholes. Exotic matter, which has less energy than a pure vacuum, does exist, at least in small amounts, thanks to the ghostly virtual particles in certain quantum physics experiments, basically the Casimir effect. Number of theorists have claimed to construct special wormholes that do not require exotic matter. They require quantum mechanical effects. Approaches rigorously define a wormhole throat to the narrowest point and show that because light rays spread out as we emerge from it, there must be a kind of anti-gravity. In the process, they found that time-dependent wormholes actually have two throats, one for each direction of travel. The theoretical traveler could paradoxically pass the middle of the wormhole without actually reaching the throat for a direction. Part of the problem is the lack of a good physical picture for dynamic black hole, which is a complicated four-dimensional object. The usual image is legitimately only for one that doesn't change with time. Okay. So now, we're going to move beyond. Talk about ER equals EPR. Wormholes entangle a black hole paradox. A bold new idea aims to link two famously discordant descriptions of nature. In doing so, it may also reveal how space-time owes its existence to the spooky connections of quantum fluctuation. Physicists are still stuck with perhaps the greatest incompatibility problem in the universe. The smoothly worked space-time landscape that Einstein described is like a painting by Salvador Dali. Seamless, unbroken, geometric. But the quantum particles that occupy the space are more like something from George Seurat. Pointerless, discrete, described by probabilities. At their core, the two descriptions contradict each other. Yet a bold new strain of thinking suggests that quantum correlation between specks of impressionist painter actually create not just Dali's landscape, but the canvases that it sits on, as well as the three-dimensional space around them. And Einstein, as he so often does, sits right in the center of it all, still turning things upside down from beyond the grave. Like initials carved in a tree, ER equals EPR, as the new idea is known, the shorthand that joins two ideas proposed by Einstein in 1935. One involves the paradox implied by what he calls spooky action of a distance between quantum particles, the EPR paradox. The other shows how two black holes can be connected through far reaches of space through wormholes, ER, short for Einstein-Rosen bridges. At the time that Einstein put forth these ideas, and for the most of the 8 decades since, they were thought to be entirely unrelated. But if ER equals EPR is correct, the ideas are disconnected. They're two manifestations of the same thing. And this underlying connectedness would form the foundation for all space-time. Quantum entanglement, the action at a distance that so troubled Einstein, could be creating the spatial connectivity that sews space together. Without these connections, all of space would atomize. This idea was developed by Juan Maltuna along with Leonard Susskind. In other words, the solid and reliable structure of space-time is due to the ghostly features of entanglement. What's more, ER equals EPR What's more, ER equals EPR has potential to address how gravity fits together with quantum mechanics. The road that led to ER equals EPR is a Mobius strip of tangled twists and turns that fold back on itself, like a drawing by Msi Afterburner. A fair place to start might be quantum entanglement. If two quantum particles are entangled, they become, in effect, two parts of a single unit. What happens to one entangled particle happens to the other, no matter how far apart they are. Very much like empathy on the human scale. Maldacina sometimes uses a pair of gloves as an analogy. If you come upon the right-handed glove, you instantaneously know the other is left-handed. There's nothing spooky about that. But in the quantum version, both gloves are actually left and right-handed, and everything between up until the moment you observe them. Spookier still, the left-handed glove doesn't become left until you observe the right-handed one, at which moment both instantly gain a definite handedness. Entanglement played a key role in Stephen Hawking's 1974 discovery that black holes could evaporate. This too involved entangled pairs of particles. Throughout space, short-lived virtual particles of matter and antimatter continually pop into and out of existence. This is the Casimir effect. Hawking realized that if one particle fell into a black hole and the other escaped, the whole would emit radiation glowing like a dying ember. Given enough time, the whole would evaporate into nothing, raising the question of what happened to the information content of the stuff that fell into it. But the rules of quantum mechanics forbid the complete destruction of the information. Hopelessly scrambling information is another story, which is why documents can be burned and hard drives smashed. There's nothing in the laws of physics that prevents the information lost, where the smoke and ashes from being reconstructed, at least in principle. The question becomes, would the information that originally went into the black hole just get scrambled, or would it be truly lost? The argument set off what Susskind called the black hole wars, which would generate enough stories to fill many books. Eventually, Susskind in the discovery that shocked even him realized, with Gerald T. Haas, that all the information that fell into the hole was actually trapped on the black hole's two-dimensional event horizon, the surface that marks the point of no return. This is where the holographic principle comes in. The horizon encoded everything inside, like a hologram. It was as if the bits needed to recreate your house and everything in it could fit on the walls. The information wasn't lost. It was scrambled and stored out of reach. Susskind continued to work on the idea with Maldacuna, whom Susskind called the master, and others. Holography began to be used not just to understand black holes, but any region of space that can be described by its boundary. That, by the way, includes our universe and the black hole on the outside, black hole cosmology inside the superverse, and also the full tetraverse and the octaverse and the 16-verse, by the way, with their own black hole boundaries. Over the past decade or so, the seemingly crazy idea that space is a kind of hologram has become rather humdrum, a tool of modern physics using everything from cosmology to condensed matter. One of the things that happens to scientific ideas is they often go from wild conjecture to reasonable conjecture to working tools. It's gotten routine. Holography was concerned with what happens on boundaries, including black hole horizons. That left open the question of what goes on in the interiors. And answers to that were all over the map. After all, since no information could ever escape from inside a black hole's horizon, the laws of physics prevented scientists from ever directly testing what was going on inside. 2012, The group came up with an idea for Starling. It basically said the physicists told everything. We know nothing. The so-called AMPS paper presented a doozy of an entanglement paradox. One so stark it implied that black holes might not, in effect, even have insides. For a firewall just inside the horizon would fly anyone or anything attempting to find its secrets. Scaling the firewall. Here's the heart of the argument. If a black hole event horizon is a smooth, seemingly ordinary place, as relativity predicts, in the Lagrange condition, the particles coming out of the black hole must be entangled with particles falling into the black hole. Yet for all information not to be lost, the particles coming out of the black hole must also be entangled with particles that left long ago and are now scattered about in a fog of Hawking radiation. If one too many times of entanglement, one of them would have to go. The reason is that maximum entanglements have to be monotonous, existing between just true particles. True maximum entanglements at once, quantum polygamy simply cannot happen, which suggests that the smooth continuous spacetime inside the core of black holes can't exist. A break in the entanglement at the horizon would imply a discontinuity in space, a pilot of energy called a firewall. The AMPS paper became a real trigger, casting sharp relief just how much was not understood. Of course, physicists love such paradoxes because they're fertile ground for discovery. Both Susskind and Valdicina got on it immediately. They'd been thinking about entanglement and wormholes, and both were inspired by work of Mark Van Ramsdonk, a physicist at the University of British Columbia in Vancouver, who had conducted a pivotal thought experiment suggesting that entanglement and space-time are intimately related. Then one day, I received a very cryptic message that contained the equation ER equals EPR. I instantly saw what he was getting at, so from there on we went back and forth expanding the idea. The investigation, which they presented in a 2013 paper, Cool Horizons for Entangled Black Holes, argued for a kind of entanglement that said the ANPS authors had overlooked. The one that hooks space together according to Susskind. ANPS assumed that the parts of space-time inside and outside of the event horizon were independent. But Susskind and Valdicina suggests that, in fact, particles on either side of the border could be connected by a wormhole. The ER equals EPR entanglement could kind of get around the current paradox. The paper contained a graphic that some refer to have jokingly as the octopus picture, with multiple wormholes leading from the inside of a black hole to Hawking radiation on the outside. In other words, there was no need for an entanglement that would create a kink in the smooth surface of the black hole's throat. The particles still inside the black hole would be directly connected to particles that left long ago. No need to pass through the horizon, no need to pass go. The particles on the inside and the far out ones could be connected one and the same, Augustine explained. Like me, myself, and I. The complex octopus wormhole would link the interior of the black hole directly to particles along the departed cloud of Hawking radiation. The ER equals EPR idea posits that entangled particles inside and outside of black holes and horizon are connected via wormholes. Holes in the wormhole. No one is sure yet whether ER equals EPR will solve the firewall problem. At first whiff, ER equals EPR may sound fresh and sweet, but it will have to ripen on the shelf for a while. Whatever happens, the correspondence between entangled quantum particles of geometry of smoothly warped space-time is a big new insight. It's allowed him and his collaborator, a researcher at the University of Advanced, to study to tackle complex problems in quantum chaos through what is called simple geometry that even I can understand. To be sure, ER equals EPR does not get applied with just any kind of space or any kind of entanglement. It takes a special type of entanglement and a special type of wormhole. Recently co-authored a paper describing wormholes with more than two ends. ER equals EPR works in very specific situations. but AMPS argues that the firewall presents a much broader challenge. Mao believes that ER equals EPR modifies standard quantum mechanics. A lot of people are really interested in the ER equals EPR conjecture, but there's a sense that no one but Lenny and Juan really understand what it is. Still, it's an interesting time to be in the field. Cool horizons for entangled black holes. General relativity contains solutions in which two distant black holes are connected to the interior via a wormhole, or Einstein-Rosen bridge. These solutions can be interpreted as maximally entangled states of two black holes that form a complex EPR pair. We suggest that similar bridges might be present for more general entangled states. In the case of entangled black holes, one can formulate versions of the AMPS paradox and resolve that. This suggests possible resolutions of the firewall paradox for more general situations. Bound on chaos. We conjecture a sharp bound on the rate of growth of chaos in a thermal quantum system with a large number of degrees of freedom. Chaos can be diagnosed using an out-of-time order correlation function closely related to the commutator of operations separated in time. We conjecture that the influence of chaos on this correlator can develop no faster than exponentially. With Lyapunov exponents, we give a precise mathematical argument based on plausible physical assumptions establishing this conjecture. Multi-boundary wormholes and holographic entanglement. The Adscft, which is the anti-disorder space conformal field theory conjecture, or correspondence, string theory relates quantum entanglement between boundary conformal field theories and geometric connections in the dual asymptotically anti-de Sitter space. We consider entangled states in the n-fold tensor product of a 1 plus 1 dimensional CFT Hilbert space defined by the Euclidean path integral over a Riemann surface with n-holes. In one region of moduli space, a dual bulk state is a black hole with n asymptotically ADS sub 3 regions connected by a common wormhole, while in other regions the bulk fragments into disconnected components. We study the entanglement structure and compute the wave function explicitly in the functional limit of the Riemann surface in terms of CFT endpoint functions. We also use ADS minimal surfaces to measure entanglement more generally. In some regions of the moduli space, the entanglement is entirely multi-part or not of the GH3 type. However, even when the bulk is completely connected, in some regions of the moduli space, the entanglement is almost entirely bi-part type. Significant entanglement occurs only between pairs of CFTs. We develop new tools to analyze intrinsically n-part entanglement and use these to show that for some wormholes with n similar sized horizons, there is intrinsic entanglement between at least n-1 parties, and that the distillable entanglement between the asymptotic regions is at least n plus 1 divided by 2 parties. Okay. So here's the paper by Mark Ramstock, Building Up Space-Time with Quantum Entanglement. In this essay, we argue that the emergence of classically connected space-time is intimately related to the quantum entanglement of degrees of freedom in a non-determinative description of quantum gravity. This entanglement of degrees of freedom associated with two regions of space-time results in these regions pulling apart and pitching off from each other in a way that can be quantified by standard measures of entanglement. Turning black holes and ADS anti-de Sitter space. We propose a dual non-perturbative description for maximally extending Schwarzschild anti-de Sitter spacetimes. The description involves two copies of the conformal field theory associated to the ADS spacetime and an initial entangled state. In this context, we also discuss a version of the information loss paradox and its resolution. Holographic derivative of the entanglement entropy of ADS CFT. A holographic derivative of the entanglement entropy in quantum conformal field theories is proposed from Adscft Correspondence. We argue that the entanglement entropy in D plus 1 dimensional conformal field theories can be obtained from the area of D-dimensional minimal surfaces in ADS, sub D plus 2. Analogous to the Bekenstein-Hawking formula for black hole entropy. We show that our proposed perfectly reproduces the correct entanglement entropy in 2D CF2 when applied to ABS sub 3. We also compare the entropy computed in ABS sub 5 divided by time s to the fifth exponent with that of the 3 n equals 4 super yang mils. Van Ramstein proposes that the quantum entanglement is the fundamental ingredient underlying space-time geometry. John Wheeler came up with an idea in the 50s that everything is geometry, and one particularly interesting idea we call charge without charge. There are no point-length electrical charges, Wheeler proposed. Rather, electric field lines can thread the mouth of a wormhole. What looks to you like an electron is actually a tiny wormhole mouth. If you are small enough, you could dive inside the electron and emerge from a positron far away. Yes, and it's the antiverse. Okay. Classical physics as geometry. The classical physics can be regarded as comparing gravitation, source-free electromagnetism, unquantized charge, and unquantized mass of concentration of electromagnetic energy, field energy, geons, and classical physics can be described in terms of curved empty space and nothing more. No changes are made in existing theory. The electromagnetic field is given by the Maxwell square root of the contracted curvature tensor of Ricci and Einstein. Maxwell's equations then reduced as shown 30 years ago by Rayleigh to a similar simple statement connecting the Ricci curvature as rate of change. In contrast to unified field theories, one then secures from the standard theory of Maxwell and Einstein already unified field theories. This purely geometrical description of electromagnetism is traced out in detail. Charge receives a natural interpretation in terms of source-free electromagnetic fields that 1 are everywhere, subject to Maxwell's equations for free space, but 2 are trapped in the wormholes of a space with multiply connected topology. Electromagnetism in such a space receives a detailed description in terms of the existing beautiful and highly developed mathematics of topology and harmonic vector fields. Elementary particles and real masses are completely excluded from discussion belonging to the world of quantum physics. Okay. Wow, that's a lot. I'm hoping that I'm close to done on this part 40 because this has stretched on way more than an hour. We conjecture a sharp bound on the rate of growth of chaos in thermal quantum systems with a large number of degrees of freedom. Chaos can be diagnosed using an out-of-time order correlation function closely related to the commutator of operations separated in time. Okay. Let me check this out, see if this is something I need to go over. Okay, so far, I only have a little bit more to go through. This paper presents strong observational evidence of numerous previously unobserved circular spots. spots in the cosmic microwave background sky. The spots have angular radii between 0.03 and 0.04. This is for Penrose's theory on the universe, or for cosmic cyclic cosmology. Angular diameter between 3 and 4 degrees. There was a clear cutoff at that size, indicating that each round spot would have originated from a highly energetic point-like source located at the end of inflation, or else point-like at the conformally expanding Big Bang. If it is considered that there was no inflationary phase. The significant presence of these anomalous spots was initially noticed in the Pine 70 gigahertz satellite data with comparison with 1,000 standard simulations, and then confirmed by extending the comparison to 10,000 simulations. Such anomalous points were then found at precisely the same locations in the W map, Wilkinson microwave anisotropy probe data. Their significance was confirmed by the comparison with 1,000 WMAP simulations. Planck and WMAP have very different noise properties, and it seems exceedingly unlikely that the observed presence of anomalies pointing to the same direction, and both maps may come entirely from the noise. Subsequently, further confirmation was found in the Planck data by comparison with 1,000 FFP 8.1 MC simulations, with L is less than or equal to 1,500. The existence of such anomalous regions resulted from point-like sources at the conformally stretched out Big Bang as a predicted consequence of conformal cyclic cosmology. These sources being the Hawking point of the theory, resulting from the Hawking radiation from supermassive black holes in the cosmic eon prior to our own. CCC and the Fermi paradox. Within the scheme of conformal cyclic cosmology, information can be transmitted from eon to eon. Accordingly, the Fermi paradox and the SETI program of communication by remote civilizations may be examined from a novel perspective, such as information could, in principle, be encoded in the cosmic microwave background. The current empirical state of CCC is also discussed. It was purely an accident byproduct of these developments in gravitational theory that another possibility for time travel was uncovered by a New Zealand mathematician named Roy Kerr. It came from the study of black holes. Schwarzschild's solution had served well for many decades, but it was clearly unrealistic in one respect. A real star would undoubtedly be spinning when it collapsed, and nobody knew the solution to Einstein's equations corresponding to a rotating black hole until Kerr found it. Outside the event horizon, the properties of Kerr's black hole solution are broadly similar to those of the Schwarzschild case, but the interior is structured quite differently. Whereas a particle, not a tachyon, falling into a Schwarzschild black hole necessarily hits the central singularity, after a short time, a particle falling into a Kerr hole may avoid the singularity altogether. Where does it go? Nobody really knows. The Kerr solution gives a possible answer. Just as Schwarzschild's solution can be extended into an anti-world, another universe, an anti-verse, by the way, where time runs backwards, as I suggested, so Kerr's solution extends into an infinity of other universes, both world and anti-worlds. In addition, there is a weird region within the black hole where the light goes over, Gödel light, and permit world lines to form closed loops. A closed time like Kerr's, by the way. Unfortunately for aspiring temponauts, most experts think the Kerr solution will only apply in specific regards throughout the interior of a real black hole. Quite apart from its idealized mathematical form, which may or may not resemble a real spinning black hole, the gateway to the other universes and the time travel region described by this solution turns out to be intrinsically unstable, except for specific cases. Furthermore, the singularity inside the Kerr black hole is naked. This means it can be seen by an observer in the interior region. By contrast, the singularity inside the Schwarzschild hole lies to the future of all observers. They don't know it is there until they hit it. A naked singularity is far more fearsome. Remember, singularities are only the boundaries where space and time cease to exist, because while the physics break down there, it is impossible to know what might come out of a singularity. So long as the singularity remains hidden, we need not worry too much about it, but a naked singularity could influence events in an unknown way, making attempts to draw any physical conclusions, providing an alternative route to dashed lines. Possibility of two routes connecting the same point in space is another example of how, in general, relativity space-time may be bent around far enough to reconnect with itself, thus providing a possibility of loops in both space and time. As shown, the wormhole loop looks longer, but this is because my drawing is largely symbolic. Remember that space-time diagrams can really distort distances. A careful mathematical study shows that wormholes in space 2 points A and B may be connected by a path in normal space, dotted line, or one that connects to the wormhole dashed lines. The length of these two loops may be very different. As shown, the wormhole path looks longer, but under some circumstances it can be much shorter. Wormholes can actually shortcut the distance from A to B. This is made more plausible if the diagram is folded over, where the wormhole now appears on the short tube. Remarkably, Einstein anticipated this type of geometry and work carried out with Nathan Rosen in the mid-30s. For that reason, the wormhole is sometimes known as the Einstein-Rosen bridge. It may happen that an abstract can get from A to B through the wormhole faster than light can get there via the normal route. By outpacing light, in this manner, the abstract can also travel backwards in time. Actually, for him, time is going normally. The distance is shown. If you want to turn the wormhole into a time machine, the wormhole mouths have to be regarded somewhat like our twins Stan and Betty. One and Betty needs to be accelerated somehow close to the speed of light relative to the other end and stopped and accelerated back again. The inert mouth. Okay. So basically, you move one mouth of the wormhole fast at the speed of light relative to the other, and then you create a closed time-like loop in the region in between, and that creates your time travel machine. For both this and for the space travel, you need to have a negative mass or negative energy density canceling effect, and both of those we've already covered. That holds open the wormhole so it remains stable, and it gives a source for anti-gravity. And it's also the opening to the wormhole outside of the event horizon of the black hole. So, you need for both space and time travel. The curved space have a brief introduction. This chapter provides a brief introduction to the curved space and rotating black holes. Touching on the most common coordinate representation of the space-time metric and the key features of geometry, the presence of horizons and ergospheres. The coverage is by no means complete, and so it's chiefly to orient oneself when reading subsequent chapters. Alright, here's the movie, The Journey into the Reisner-Nordstrom Black Hole. There's a map, a clock, and an artificial grid on the black hole's horizon. A Reisner-Nordstrom black hole is a black hole with mass and electric charge but no spin. Real black holes probably spin, but probably have almost no electric charge because the universe appears to be electrically neutral, and the charged black hole is quickly neutralized by attracting charge at the opposite side. Nevertheless, the internal geometry of an electrically charged black hole resembles mathematically that of a rotating black hole. For this reason, the behavior inside a charged black hole is often taken as a surrogate for that inside a rotating curved black hole. The big difference between a charged Reisner-Nordstrom and an uncharged Nordstrom black hole is that the mathematical solution of the charged black hole is inside its horizon is a one-way wormhole that connects to a white hole that propels you to another space-time. Okay. Gravitationally repulsive core. Remember, the no-hair theorem states that an isolated black hole is characterized outside its horizon by the three quantities, mass, charge, and spin. Whereas the geometry for black holes, mass, and charge, the Reisner-Nordstrom geometry was discovered within a few years of Einstein's development of general relativity. It took until 1963 for Roy Kerr discovered the geometry of a Ixs black hole. After that, Newman quickly generalized Kerr's solution of black hole that has both charge and spin. No-hair theorem requires that Kerr-Newman geometry constitutes the most general description of an isolated black hole outside its horizon. As might be imagined, for a long time it took to discover black hole solutions with spin, the Kerr-Newman geometry is technically much more complicated than the comparatively simple Reisner-Nordström geometry. For this reason, as of this 2009 period, I have yet to implement rotating black holes in a black hole flight simulator. Instead, use the Reisner-Nordström geometry as a surrogate for the Kerr geometry. You can be sure that one day to have the opportunity to implement the Kerr-Newman geometry, but it will not be easy and it will take time. Reisner, Nordström, and Kerr-Newman, which is Maxwell's charge and Maxwell's charge plus spin geometry, assume that the black hole is empty except at its singularity, which forms a ring in the Kerr-Newman geometry. Empty here means empty of energy momentum, such as that produced by matter or light, aside from the energy momentum of the electric field produced by electrical charge rotating at the singularity. It may come as a surprise to learn that a Reisner, Nordström, or Kerr-Newman black hole is gravitationally repulsive at its core. Indeed, the singularity is infinitely gravitationally repulsive. In the case of a charged black hole, the gravitational repulsion of the core comes from the tension or negative pressure of the radioelectric field. In relativity, mass is a form of energy, so it is not surprising to learn that not only mass but also energy in any form, including photons, which have energy but no less mass, gravitate. In a rotating black hole, the gravitational repulsion of the core can be explained more simply. It's produced by the centrifugal force. Outside the outer horizon, the orbital structure of the charged Nordström black hole is similar to that of the uncharged Schwarzschild black hole, with regions where circular orbits are stable, unstable, and non-existent. But whereas the uncharged black hole is a single horizon, the charged black hole is two horizons, an outer and an inner horizon. You follow a real free fall trajectory through the charged black hole. The blue line inside the inner horizon marks the periapsis of the trajectory, the radius of the closest approach to the center of the black hole. The clock records the time you left until you hit the inner horizon, which in a real black hole is where you would be vaporized by mass inflation and stability. The time is in seconds if the black hole's mass equals that of the supermassive black hole at the center of the galaxy 5 million times. On your trajectory, it takes 20 seconds to fall from the outer to the inner horizon. The trip to the outer horizon, the Reisner-Nordström black hole, similar to the Schwarzschild black hole. If you pass through the outer horizon, the horizon splits in two, same as for the Schwarzschild black hole. Without the horizon grids, there is no sign that you have crossed the horizon. For a while, the black hole appears to increase in size. For a while, the view inside the Reisner-Nordström black hole continues to look similar to that of the Schwarzschild black hole as you fall deeper inside the horizon bubble enlarges. But then the black hole appears to shrink. But as you approach the inner horizon, the black hole ahead stops expanding and starts to shrink. It looks like you are moving away from the black hole, but that is not true. You are still free falling inwards towards the black hole. The shrinking is caused by relativistic beaming, which concentrates the view ahead. The same relativistic beaming causes light from the outside universe to become brighter and more blue around the black hole. Through the inner horizon, as you fall deeper into the black hole, the inward flow of space is slowed by the gravitational repulsion produced by the negative pressure of the radioelectric field. At a certain radius, the inner horizon, the flow of space goes back down to the speed of light. Down to this point, it has been impossible for light or other information to propagate upwards to you from parts of the black hole below you. For example, if you look at your feet, you do see them below you, but in fact the feet that you see emitted their light at a time when they were outside the current condition of your body. At the inner horizon, you are hit by an infinitely bright, infinitely energetic burst of light. The bright point of light is an image of the outside universe reflected by the gravitationally repulsive singularity. The burst of light contains infinitely, speeded up, the entire history of the universe. The infinitely bright burst of light signals the breakdown of the Reisner-Nordström geometry. The Reisner-Nordström geometry assumes that all matter and charge inside the black hole is concentrated at the central singularity. This assumption leads to the prediction of light from the outside universe concentrates infinitely at the inner horizon, which contradicts the assumption that the black hole is empty, except at the singularity. In reality, if there is such a thing as a charged black hole, as you approach very close to the inner horizon, you would see rapidly growing dispersion of light from the outside universe. Light triggers the mass inflation. The inner horizon on, The horizon motion geometry is not physically realistic despite being an exact mathematical solution to Einstein's equation. Journey through the horizon remotes from black hole. This one keeps it all the way through. Version of the movie at the left includes horizon grids all the way through. The horizon grids are colored with the black body color. You would see if the object sitting at the horizon, emitting at the horizon at a temperature of 4096 Kelvin and with free falling radially from zero velocity in infinity. As you fall inward through the inner horizon, a new grid appears marking the ingrowing inner horizon. The dark red grid marking anti-horizon are temporarily invisible or to turn around inside the wormhole, but then reappear as you approach the inner horizon going outwards. As you pass back through the inner horizon, the third grid appears, the outgoing inner horizon or inner anti-horizon. As the Penrose diagram shows, the outgoing inner anti-horizon is not the same as the ingoing inner horizon. As the white hole catapults you outward into a new universe, a fourth grid appears marking the white hole's outer horizon, through the wormhole. Inside the inner horizon, the flow of space slows down, turns around, and accelerates you back out again, back towards the radius of the inner horizon. This region inside the inner horizon is the wormhole. The wormhole part of the longer movie linked at the top of the page. In the movie, the camera is initially pointed inwards towards the black hole, but as space turns and accelerates back out, the camera turns around and points outward, away from the black hole. Flow of time accelerates back outward, back out through the inner horizon. The place where it accelerates back up to the speed of light marks the inner horizon. As you pass once again through the inner horizon, the time going outward rather than inward, you see a second infinitely bright until the energetic burst of light. Whereas on your inward passage to the inner horizon, you saw the entire history of the universe go by. This time, on your outward passage, you see the entire future of the universe go by. Wow, that's really trouble. The fact that you see the outside universe infinitely bright, that blue shifted as you pass outward through the inner horizon was first pointed out by Roger Penrose. Through a white hole. Accelerating past the speed of light, the outward flow of space deposits you in a white hole, where space is falling outward faster than the speed of light. A white hole is like a black hole, except time reversed in the sense that space in a white hole falls outward faster than light. So basically, for the anti-black hole, this like particle antimatter. So this is a fractal representation of that in the macro world. So instead of electron positron, we have black hole, white hole, universe, antiverse, all connected at different scales. Time reversed in the sense that space in the white hole falls outward faster than light, whereas space in the black hole falls inward faster than light. You, inside the white hole, perceive your own proper time to continue to move forward in the usual way. Basically, in the antiverse, what we consider a black hole would be a white hole in our universe, and what we consider to be a black hole would be a white hole in their universe, and vice versa. Time reversed. You might have thought that since you originally fell through the inner horizon from a black hole, when you pass back out through the inner horizon, you would rejoin the black hole. But this is not true. It cannot be true because space cannot simultaneously fall inward and outward faster than light. The white hole is actually a completely separate piece of space-time. That is occurring in Penrose diagram of horizon or Nordstrom geometry. You need to protect the bubble so that you don't get annihilated by the antimatter. You would need a bubble of our own space-time protection. The white hole continuation of the right and vice versa prevention. The white hole continuation of the horizon or Nordstrom geometry in an exact mathematical solution. Into a new universe. The outflow of space in the white hole has been propelled by the gravitational repulsion produced by the negative radial pressure of the electric field. As you move outward, the gravitational repulsion weakens and the gravitational attraction from the mass of the black hole reasserts itself as the dominant force. The outward flow of space decelerates. The place where space slows back down to the speed of light marks the outer horizon of the white hole. As you pass outward through the outer horizon of the white hole, for the third time you see infinitely bright, energetic bursts of light. This type of light is from the new universe, into which you have been deposited by the white hole. Burst of light contains the entire past history of the new universe. As long as you're inside the white hole, light from the new universe cannot penetrate into the white hole, since space of the white hole falls outward fast as light. Only when you reach the outer horizon of the white hole, where the outflow of space has slowed to the speed of light, do you get to see light from the new universe. The new universe is a two-master. Where is the new universe into which the white hole thrusts you? Since the right-Nordstrom geometry is a mathematical solution, it does not specify who or where or when the new universe is. If you're right, you can imagine that the new universe might be another place and time in our own universe. But in reality, Nordstrom geometry, we have no idea. Looking back at the white hole. Turning around and looking back to see the white hole from which you emerged. You see light from the original universe. Light has traversed the same journey as you, through the black hole, through the wormhole, through the white hole, into a new universe. Okay, we're looking at the rising Nordstrom waterfall. It works equally well for a charged black hole. However, whereas the torch geometry of the waterfall falls at ever-increasing velocity all the way to the central singularity, and the rising Nordstrom geometry of the waterfall slows down thanks to the gravitational repulsion produced by the tenfold negative pressure of the electric field. Centrifugal field. The rising Nordstrom waterfall is described by exactly the same metric as the source child metric, but the mass m and the escape velocity is replaced by the mass m r interior to radius r. The interior mass mr equals the mass m at secant infinity minus the mass energy q2 divided by 2r in the electric field. Electromagnetic mass q2 divided by 2r is the mass outside r associated with the energy density e2 divided by 8 pi of the electric field. E equals q divided by r squared surrounding a charged cube. The inflow velocity v of space has the speed of light at the outer horizon. R plus equals m plus bracket m squared minus q squared bracket half power or square root of. But goes back down to less than the speed of light at the inner horizon. R sub equals m minus m squared minus q squared to the half power or square root. The velocity slows all the way to 0 at the turnaround point. R0 equals q2 divided by 2m inside the inner horizon. At this point, space turns around and accelerates back out, putting the speed of light 1/4 of the inner horizon r. Space now enters a white hole where space is moving outward faster than light. The diagram at left seems to show the white hole in the same place as the black hole, but actually just as a referring to the pendulum diagram, the white hole and black hole are distinct regions of space-time. Where space falls outward in the white hole, The gravitational repulsion produced by the negative pressure of the electric field weakens relative to the gravitational attraction produced by the mass. The outflow in space slows back down to the speed of light at the outer horizon r plus of the white hole. Space then emerges into a new region of space-time, a new universe. The geometry of a rotating black hole is described by the Kerr metric described by New Zealand Roy Kerr in 1963. The Kerr geometry shows with the Reisner-Nordstrom geometry the property of having an inner horizon which connects to a white hole which connects to a new universe. The centrifugal force causes the horizon of the black hole to bulge out into an ellipse. The same centrifugal force opens the singularity into a ring. The outer horizon and inner horizon form confocal ellipsoids with the ring singularity at the focus of the ellipsoid. The rotating black hole drags space around with it. Outside the horizon black hole is a region called the ergosphere, where space is dragged around so fast that nothing can remain at rest there. It's former student once called the ergosphere the place where little children come from, because nothing can remain at rest there. The Kerr antiverse. The antiverse. Favorite subject of mine. If you pass through the distance bounded by the ring singularity of the Kerr black hole, then you enter a different region of space, the antiverse. The antiverse continues the Kerr geometry to negative radius and ellipsoid coordinates. An observer in the antiverse perceives the Kerr geometry to be rotating black hole of negative mass. Opposite of one, as I said. Winding around the ring singularity is a toroidal region, which I call the vicissitude, containing closed tie-like curves. CPC, the observer who circulates retrograde around the torus, shape of the universe, can find themselves joining their old past. By insistence, they are doomed to repeat the same loop of time forever. Sadly, from its inner horizon inward, it is subject to the inflationary instability at its inner horizon. Okay. Bright object that is exactly behind the black hole, the light from the bright object appears a ring on the black hole called the Einstein ring. singularity is not a point, rather it is a three-dimensional spatial boundary where general relativity commits suicide. New physics, presumably quantum gravity, in some form must replace general relativity as singularities. What that new physics is remains a profound unanswered question. May a friend fall into America at the same time, but at different locations in latitude and longitude, you do not approach each other as you approach the singularity. Rather than diverging tidal force channels, the parts of your body along the inward radial direction. So after meeting in front of the singularity, you cannot even put your arms to touch it. Oh, very sadly thought. Extreme limits of black hole entry. Taking the extreme limit of a non-extreme Weisner Nordstrom black hole by externally varying the mass or charge. The region between the inner and outer event horizon experiences an interesting fate. While this region is absent in the extremal case, it does not disappear in the extremal limit, but rather approaches a factor of ADS2 squared times 2 squared. In other words, the approach to extremality is not continuous, as the non-extremal Weisner Nordstrom solution splits into two states times that extremality, an extremal black hole and a disconnected ADS anti-dissimilar state. We suggest that the unusual nature of this limit may help in understanding the entropy of extremal black holes. With ADS sub 2 times x squared. Okay, so we're just going to do a few conformal cyclic cosmology, and then we should be done. Okay. Conformal cyclic cosmology is a cosmological model of the framework of relativity, advanced by the theoretical physicist Roger Penrose. In CCC, the universe iterates through infinite cycles with a future timeline to infinity. Each previous iteration being identified with the Big Bang singularity of the next. And the popular this theory in his 2010 book, Cycles of Time, an extraordinary view. Penrose's basic construction is to connect a countable sequence of FORW spacetime to each representing a Big Bang followed by an infinite future expansion. Penrose noticed that the past conformal boundary of one copy of FORW can be attached to the future conformal boundary of another after an appropriate conformal rescale. In particular, each individual FORW metric is multiplied by the square of the conformal factor GAV and omega, when approaches zero at time like infinity, effectively sloshing down the future conformal boundary of the conformal regular hypersurface with the space-out if there is a positive cosmological constant, as is currently believed. The result is a new solution to Einstein's equations, which Penrose takes to represent the entire universe, and which is composed of a sequence of sectors that Penrose calls eons. The conformal cyclic cosmology hypothesis claims that all massive particles eventually vanish from existence, including those which become too widely separated from all other particles to annihilate with them. As Penrose points out, photon decay is a possible possibility contemplated in very speculative extensions of the standard model that has never been observed. Moreover, all electrons must also determine their charge and or convention mass, and no conventional speculations allow for this. There is no more prior lecture video. Penrose moderated its previous requirements for no mass beginning at 26:30 in the video, allowing some mass particles to be present, as long as the amounts are insignificant with nearly all of the energy being kinetic and in a conformal geometry dominated by photons. The significant feature of this construction for particle physics is that since photons obey the classical laws of conformally invariant quantum theory, they will behave in the same way in the rescaled eons as in their FLW counterparts. Classically, this corresponds to light cone structures being preserved in the conformal rescaling. For such particles, the boundary between eons is not a boundary at all, but just a space-like surface that can be passed across like any other. Fermions, on the other hand, remain confined to a given eon, thus providing a convenient solution to the black hole information paradox. According to Penrose, fermions must be irreversibly converted into radiation during black hole evaporation to preserve the smoothness of the boundary between eons. The curvature properties of Penrose's cosmology also communicate other aspects of cosmology. First, the boundary between eons satisfies the wild curvature hypothesis of a certain kind of low entropy path required by statistical mechanics and by observation. Second, Penrose has calculated this that a certain amount of gravitational radiation can be preserved across the boundary between eons. Penrose suggests this extra gravitational radiation may be enough to explain the observed constant acceleration without appeal to a dark energy matter field. Okay, so they're basically using the conceptual background, which was mapped by the mapped boomerang experiment to show evidence of this in terms of concentric circle in excess of them compared to the simulation in the standard lambda fluidity model, where the inflate sigma gets significant of the result. This is disputed though. Reason for the disagreement was tracked down to the issue of how to construct simulations that are used to determine significance. The three independent attempts to repeat the analysis of all used simulations based on the standard lambda CDM model of Penrose used an undocumented, non-standard approach. In 2015, they published further development of the work introducing a new method they termed the sky twist procedure map based on simulations in which WMAP data is directly analyzed. In 2015, it developed the results of fine-grained analysis confirming those of the do not really homogeneous high distribution of those structures. In 2018, we presented a continued analysis of the C1B data that showed anomalies pointing to a lot of important new input to cosmology in respect to the validity of CCCD. Also suggested that those anomalies could be Hawking point elements, signals from Hawking evaporation of supermassive black holes in the eon prior to ours. This is a look at the of the speed multiplication found by the Adscft team is looking at what indeed Hawking points. This claim was later removed. The 2020 analysis claimed that the anomalies were not statistically significant. However, per the 2020 paper, the Determinism group argued for further evidence for anomalies in the field that could be explained by Hawking points and not by current conventional inflationary picture. New analysis of the CMBs and the remapped data for its earlier indications of non-Gaussian features of concentric circles with low temperature varies. Confirms the cosmology predicts such features of supermassive black hole encounters in its non-preceding our big bang. Significance of low individual low-valence circles in the true data has been disputed. In a recent independent analysis of confirmed CCC's expectation that CMB circles have a non-Gaussian temperature distribution. We examine concentric sets of low-valence circular rings and individual map data, finding a higher non-isotropic distribution. They use chi-twist procedure to represent from the map data without appealing to simulation, shows that the prevalence of these concentric sets depends on the rings being circular rather than being slightly elliptical numbers drop dramatically with increased ellipticity. This is consistent with CCC's expectations, so also the crucial fact that whereas some of the rings radii found to reach around 15 degrees, none exceeds 20 degrees. Non-isotropic distribution and concentric sets may be ranked previously known anomalous and non-Gaussian CMB features. On CCC, predicted concentric low-valence circles in the CMB sky. Okay. This book, Cycles of Time, he talked about CCC, which is essential general relativity. Ryan's implication of technical thermodynamics, retro march towards magnetic entropy. It also illustrates entropy for information state, phase space, and fundamental gravity freedom, where particles end up moving through everlasting strings, grains of this phase space from smaller grains over time due to random motion. Heroes are stable over enormous scales of time beyond 10 to 100 years. Years distance seems to be meaningful as all mass breaks down into extremely small, redshifted photon energy whereupon time has no influence and the universe continues to expand without an end to infinity. This period from Big Bang to infinite expansion primarily defines as an eon. The Eros infinite oblivion of the previous eon, low entropy Big Bang state of the next eon cycle. One leads right to the other. All the formal geometry computes the angles but not distance in the previous eon, allowing the new eon universe to appear quite small at its inception as its phase state starts to move. Penrose has conjectured rings and does not constitute a background survey as preliminary evidence for his model as he predicted black hole collisions from the previous eon. They leave such structures due to ripples of gravitational waves. give it all that. Let's see how far beyond this we can go. Two dimensions versus higher dimensions. The number of independent conformal transformations is infinite in 2 dimensions and finite in higher dimensions. This makes conformal symmetry much more concerning in 2 dimensions. All conformal field theories know the ideas of the base of the conformal bootstrap. The resulting equations are more powerful in 2 dimensions, where they are sometimes exactly solvable, for example, in the case of minimal models, and in higher dimensions, where numerical approaches dominate. Development of conformal field theory has been earlier and deeper in the 2-dimensional case, in particular after the 1983 article development of the Untitled Chapter. The term conformal field theory is sometimes used as the meaning of 2-dimensional conformal field theory, as the title of the 1995 text. High-dimensional conformal field theories have become more popular with the Adscft Correspondence in the late 90s, and the development of numerical conformal bootstrap in the 2000s. Hawking oscillates the black hole on that software, giving the black hole lower degrees of freedom. Previously thought this had permeated at a very low energy state, which is why it didn't come up in previous calculations, the topsoil with no head theorem. This is the subject of Hawking's final paper, which was published posthumously. Ligo provides external evidence to the unique of the non-head theorem. This observation is consistent with Stephen Hawking's theoretical work on black holes in the 70s. Mass electric charge and angular momentum. Okay, I am just finishing up. Black hole. The black hole with a minimal possible mass that can be compatible with given charge and angular momentum. In other words, this is the smallest possible black hole that can exist for virtually a given fixed constant speed. It's a charge. It is the suggestion by the concept of an external black hole is theoretical and none have been proved. Many theories are based on their existence. Supersymmetric theories, extreme black holes are often supersymmetric or invariant under several supercharges. The consequence of the being is found. Such black holes are stable, but with no Hawking radiation. The black hole activity can be calculated in string theory. It has been suggested by Sean Carroll that the black hole is equal to 0. Carroll explains the lack of entropy by creating a separate dimension for the black hole to exist within. Hawking radiation of true black holes are considered non-thermal, non-factor sphere with no associated temperature. Black hole physics and inflationary cosmology tries to tag team problem with the problem of appearance of quantities beyond the Planck scale, which raises doubts on the physical validity of some results in these theories and expects the physical lessons of a radical modification beyond the Planck scale. In black hole physics, the visual derivation of Hawking radiation while field models that near the black hole is at an arbitrarily high frequency, the particular higher than the inverse time, although these cannot appear in the final results. A number of different alternative derivations have occurred to overcome this problem. Transplanting problem continuing to consider the framework of sonic black holes connect matter systems which can be described with similar way as real black holes. In these systems, the analog of the Planck scale is the interatomic scale, where the continuum description resists validity. When considered over in these systems, the analogous process of Hawking radiation still occurs despite the short scale cutoff represented by the interatomic distance. The Transplancian problem also appears in inflationary cosmology. The cosmological scales that we nowadays observe correspond to length scales smaller than the Planck scale at the onset of human inflation. Okay, so further on with the Transplancian problem in Hawking radiation. Now, the Transplancian problem also appears in inflationary cosmology. The cosmological scales that we nowadays observe correspond to length scales smaller than the Planck length at the onset of inflation. The Transplancian problem is the issue that Hawking's original calculations includes quantum particles where the wavelengths become shorter than the Planck length near the black hole's horizon. This is due to the peculiar behavior there where time stops as measured from far away. A particle emitted from a black hole with a finite frequency traced back to the horizon must have an infinite frequency and therefore a Transplancian wavelength. The unreal effect and the Hawking effect both talk about field modes in the superficially stationary spacetime that change frequency relative to other coordinates which are regular across the horizon. This is necessarily so, since the state outside the horizon requires acceleration, which constantly doppler-shifts the modes. An outgoing Hawking radiation radiating photon, if the mode is traced backwards in time, has a frequency which diverges from that which it has at great distance as it gets closer to the horizon, which requires the wavelength of the photon to scrunch up infinitely at the horizon of the black hole. In a maximally extended Schwarzschild solution, that photon frequency is regular only if the mode is extended back into the past region where no observer can go. That region seems to be unobservable and is physically suspect. So Hawking used the black hole solution without a past region, which forms at a finite time in the past. In that case, source of all outgoing photons can be identified in microscopic point right at the moment the black hole first formed. The quantum fluctuations at that tiny point in Hawking's original calculations contain all the outgoing radiation. The modes that eventually contain the outgoing radiation for long times are redshifted by such a huge amount that they will long sojourn next to the event horizon, that they start off as modes with a wavelength much shorter than the time. Since the laws of physics at such short distances are unknown, some find Hawking's original calculations unconvincing. The transplanting problem is nowadays mostly complete with mathematical artifact at horizon calculations. The same effect occurs for regular matter falling into a white hole solution. Matter which falls onto the white hole accumulates on it but has no future region into which it can go. Tracing the future of this matter, it is compressed onto the final singular endpoint of the white hole evolution in the transplanting region. The reason for these types of divergences is the modes at which and at the horizon from the point of view outside coordinates are singular in frequency there. The only way to determine what happens classically is to set some other coordinates that cross the horizon. There exists alternative physical pictures which give the Hawking radiation which transplanting problem is addressed. The key point is that similar transplanting problems can occur when the modes occupied by the radiation are traced back in time. In the Unruh effect, the magnitude of temperature can be calculated for ordinary Minkowski field theory and is not controversial. Hawking radiation is seen in both general and miniaturization. Where does Hawking radiation originate? The common picture is that it arises from excitation very near or at the horizon. A supposed firewall argument and arguments for TO for UV and an entanglement entropy and describing the quantum mechanics of black holes. We're back to Eli Bolivia. Following a closer investigation of both the total emission rate and the stress test of Hawking radiation supports the statement that its source is a near-horizon quantum region or atmosphere, whose radial extent is set by the horizon radius scale. This is potentially important since Hawking radiation needs to be modified to restrain the clarity and is a natural assumption that scales relative to such modifications are comparable to those governing the Hawking radiation. Moreover, related discussions suggest a resolution of questions regarding extra energy flux in non-violent scenarios that does not spoil black hole thermodynamics as governed by the Adscft Hawking entropy. Alright, back to wormholes. Geometrically, wormholes can be described as regions of space-time that constrain the incremental deformation of closed surfaces. For example, Enrico Rodriguez, the physics of stargates, the wormhole is defined informally as a region of space-time containing a world tube. The time evolution of a closed surface that cannot be continuously deformed, shrunk to a world line, the time evolution of a point. First type of wormhole solution described as a Schwarzschild wormhole, which would be present in the Schwarzschild metric, described the internal black hole that it was found that it would collapse too quickly, breaking across one or two of them. Wormholes that could be crossed in both directions in the traversable wormholes were thought to only be possible if the dark matter is negative energy density could be used to stable. Our physicists later reported that microscopic traversable wormholes may be possible and not require any exotic matter. Instead, requires only electrically charged fermionic matter with small enough mass that it cannot collapse into a large black hole. Oh, this is E equals EPR. Also, wormholes are possible may be limited to transfers of information. Human transfer wormholes may exist if reality can be broadly described as a random subgrid model 2, a brain-based theory consistent with string theory. Is interesting. First shell wormholes are connections between areas of space that can be modeled as vacuum solutions to the Einstein field equations and are now understood to be intrinsic parts of the maximally extended version of the Schwarzschild metric, describing an external black hole with no charge and no rotation. Here, maximally extended refers to the idea that the space-time should not have any rotation. It should be possible to continue this path arbitrarily, following the particle's future or past, or any possible trajectory of a free-falling particle, following a geodesic in the space-time. Researchers demonstrate model wormholes that do not require residing matter. The researchers show the concept of the simple from the classical approach to combine relativity with quantum theory classical electrodynamics. They consider certain elementary particles such as electrons and the electric charge as matter that is passed through the wormhole. The mathematical description which shows a Dirac equation equivalent that describes the probability density function of a particle according to quantum theory and relativity, so-called Dirac seed. As a physicist reporting their study, it is the Dirac equation model that permits the existence of a wormhole traversable by matter, provided that the ratio between the electric charge and the mass of the wormhole exceeds a certain limit. In addition to matter, signals, for example, electromagnetic waves, could also traverse the tiny tunnels in space-time. A microscopic wormhole postulated relativity would probably not be suitable for interstellar travel unless humans can be sized out. Moreover, the model would have to be further quantified whether such unusual structures could actually exist. We also think that wormholes could exist in complete bodies. Peripheral wormhole means an active nuclear radiation colliding accreting flows. The underlying hypothesis of this work is that the active galactic nuclear wormhole mouths open supermassive black holes under some called general assumptions that wormholes may emit gamma radiation as a result of a collision of accreting flows inside the wormholes. This radiation is a distinctive spectrum much different from those of depth accretion disks of AGNs. Observation of such radiation serves as evidence of the existence of wormholes in AGNs. Radiation produced by a wormhole will be confined to a giant sphere. states in the galactic would be more traversable because the temperatures would not be so high. Unlike the black hole, wormholes will leak some gravity from the objects located around the other side. This weak gravitational action would add a tiny kick to the motion starting of the galactic center. Quantum's aesthetic specific effect should be measurable in observations in the near future, once the sensitivity of our instruments gets a little bit more advanced. Coincidentally, in a way we can study how to repair the discovery of some odd radio circles in the sky. These circles are strange because they are enormous and yet not associated with any visible object. But now we define any conventional explanation for wormholes have been advanced as a possible cause. Wormholes are an interesting topic in physics. However, the idea of trying to produce theoretical pathways with regions of space-time debatable, but the very existence is unclear. The paper suggests a method to look for wormhole inside a black hole. These observations could occur within a decade. On the pre-Ixs astrophysicists need to attempt to determine whether Sagittarius A supermassive black hole or the galaxy harbors of wormhole black holes are thought to be potential holes of wormholes because of the extreme conditions both types of objects have in common. If the wormhole does exist, then certain stars looking at the other side would conceivably exert a subtle but detectable gravitational influence of those of our end. The research paper has been accepted for publication in physical review feeds. Particles can go through them, the fields can go as well, like the electromagnetic field and the gravitational field. When I'm sitting on one side, I can feel what's on the other side. In order for it to work, any wormhole within Sagittarius A must lack an event horizon of the boundary given which gravity control will allow for nothing, not even light to escape. So it will be different from the Einstein-Rosenberg the black hole on one side and the white hole on the other. Basically, there is no event horizon. Here is just a gate where you can go to the other side and come back. It is true in some cases a black hole can be a wormhole, but in this case we are talking about traversable wormholes. With a wormhole to be traversable, its mouth must be larger than the black hole event horizon. So outside of the wormhole would just be a black hole that skirts the structure of the wormhole. If the mouth is small or equal to the event horizon, the wormhole is not traversable because nothing can come out of the horizon. Using a very large telescope in chiller to detect wormhole-induced perturbation. Of course, also is ideal sooner rather than later. All we have to do is a little bit better statistical analysis. Let's say 10 years. It's not crazy. We're almost there. Gravitational echoes could reveal colliding wormholes. A unique signature in gravitational wave observation could show that hypothetical tunnels through space-time exist. When two wormholes collide, they could produce ripples in space-time that ricochet off themselves. Future instruments could detect these gravitational echoes, providing evidence that these hypothetical tunnels through space-time actually exist. Using LIGO. While LIGO's search images for many observations for the existence of black holes, these exotic objects still pose theoretical problems. For instance, they seem to be inconsistent with the laws of quantum mechanics. The only way to resolve these problems is if black holes were actually wormholes. One of the main features of black holes is the event horizon. The region of space-time beyond which nothing can escape out of the light. If we throw anything into a black hole, it's lost forever. Stephen Hawking discovered that the extra phenomenon known as quantum chocolate. Black holes can actually produce a tiny bit of radiation which would come to be known as Hawking radiation. Over a long period of time, black holes even evaporate away due to this radiation. What comes out is random. Radiation becomes so cool as to what went into the black hole. In quantum mechanics, if you know everything about a system, then you should be able to describe its past and future. But because any information that goes into a black hole is not recorded, the horizon doesn't drive your quantum mechanics. Some physicists have suggested that event horizons don't exist. Instead of a system with the term black holes, could be a host of speculative black hole-like objects that lack event horizons, boson stars, gravitars, puzzles, and even wormholes. Physicists hypothesize that if two wormholes collided, they would produce gravitational waves very similar to those generated from merging black holes. The difference in the signal would be the last stage of the merger called the ring down when the newly combined black hole and wormhole would into its final state. Because wormholes don't have event horizons, gravitational waves that hit these objects would bounce back, producing an echo during the ring down. We ensure that the object is sort of cavity where gravitational waves are reflected. Production of gravitational echoes is not very different from ordinary sound echoes. In the paper published in January, the team of physicists developed a distinct anomalous wormholes that rotate, which was very realistic for the non-spinning variety study in 2016. If the result of gravitational wave signal will look like, it's the wormholes merge. Because the strength of the signal judged during the ring down, that section of the signal would be too weak for LIGO's current configuration. But that will change in the future. Researchers continue to update and fine-tune the instrument, the researchers said. By the time we are running at full design sensitivity, I believe it will be possible to resolve the ring down phase where the echoes are predicted to be. The gravitational wave ring down a probe of the event horizon. It is commonly believed that the ring down signal from the binary coalescence provides a conclusive proof of the formation of event horizon after the merger. This expectation is based on the assumption that the ring down waveform at intermediate times is dominated by the quasi-normal mode of the final object. We point out that this assumption should be taken with great care and that very compact objects with the light ring will display a similar ring down stage, even when the quasi-normal mode spectrum is completely different from that of a black hole. In other words, universal ring down waveforms indicate the presence of light rings rather than horizons. Only precision observations of the late ring down signal where the differences in the quasi-normal mode spectrum eventually show up can be used to rule out exotic alternatives to black holes. plus quantum effects at the horizon scale. Echoes at chloride wormholes. Signatures at the horizon scale of black holes would give rise to echoes of the gravitation wave signal associated with post-merger ring bound phase and binary coalescence. We study the waveform of echoes in static and stationary traversable wormholes, which perturbations are governed by a symmetric effective potential. We argue that echoes are dominated by the wormhole quasi-normal frequency nearest to the fundamental black hole frequency that controls the primary signal. We put forward an accurate method to construct the echo waveforms from the primary signal and the quasi-normal frequencies of the wormhole, which we characterize. We illustrate this in static, the more Lucan wormhole and an immediate rotating generalization that approximates a curved black hole outside the probe. Rotation gives rise to a potential with the intermediate small-fill region that breaks the degeneracy of the quasi-normal frequencies. Rotation also leads to rate time instabilities that however fade away from small angular momentum. Reversible wormholes were a double trace deformation. After turning on an interaction that coupled with two batteries of an eternal VTZ black hole. Because the quantum matter stretched outside with negative average null energy was gravitational, back reaction renders the Einstein-Rosen-Bridge reversal. Such a reversible wormhole has an interesting interpretation in the context of ER equals EPR, which we suggest that might be related to quantum teleportation. However, it cannot be used to follow causality. We also discussed the implication for the energy and holographic entropy of the dual CO2 description. So, reversible wormholes and Einstein direct Maxwell theory. We construct a specific example of the fact that reversible wormholes and Einstein direct Maxwell theory of four states have dimension without using any form of exotic matter. Restricting to a model of two mass fermions of a single four state, we show the examples of spherically symmetric, asymptotically flat configurations which are free of singularities, representing Lagrange states. These solutions satisfy a generalized Mara relation being connected with the extreme horizon nodes from black holes. We also possess a finite mass n, electric charge QE, with E divided by n equaling 1. The exact wormhole solution with unthought massless fermions is also recorded. Nearly traversable wormholes. We point out that there are continually traversable wormholes and some previously considered theories for physics span the standard model and then the random Sunstrom model. and a traditional wormhole solution that requires no exotic matter. The two models are wormhole using a semi-classical framework in which matter is filled for a set of Meanwhile, the wormhole using semi-classical framework in which matter is treated as a set of genetic fermion spin half particles with electrons and positons. By quantum wave functions. Matter interacts through classical electromagnetic fields which simplifies the equation. There are varying parameters including the functions, charge and mass. How much the rest of the wormhole exists when the ratio between charge and total mass the wormhole exceeds the theoretical limit that applies to black holes. Researchers speculate that the solution can be followed in a more complete model where the fields correspond to matter interactions at once. The wormholes and its colleagues of vision are microscopic. One model team has explored wormholes that are state samples to an coupled ray shift. This model assumes that wormholes form a five-dimensional spacetime with occurs in some string theory cosmologies. Researchers show that a human-friendly wormhole with accelerations less than 20 g could allow a cross-galaxy journey in less than a second. The duration will be applied to the person in the wormhole as an outside observer can measure the distance as lasting thousands of years. Requires at least 9 spatial dimensions. The proponents only claim that all the 3 of them are compactified and only accessible. They have to be part of the equation. An alternative to compact dimensions, Lisa Randall and Raman syndrome describe this ability with an extra infinite dimension to remain undetected. Other researchers have pointed out that extra dimensions exist, the strong, weak, electromagnetic forces that were associated particles might operate within a 3-dimensional subspace on the high-dimensional level. Like beads on a wire that lie on the table, the particles are restricted to their own set of dimensions, unable to move beyond them. But gravity is different and consists of the motion of space-time, which includes all dimensions simultaneously. So in the assumption, imagine a world with 4 spatial dimensions where gravity exists in all 4, but the other forces of our experience exist in 3. Basically, we live in a 2-world which is a point along the 4 spatial dimensions. Following Einstein's general relativity equation for this arrangement, it seems that gravity would not exist everywhere in the universe. Areas of the gravitational force in this graviton would be restricted to the extra dimension and could only roll straight from the neighborhood near our 3 brain, making gravity weaker far away. But the important result is that according to Roman substance, relations, experiments, and Q brain will be very closely with meaning of gravity because the graviton can observe with a very little experience of the extra dimension. Observing the effects of such an extra dimension is difficult, which in account are still hoping to come up with a way to look for it. Because in things how the theory evades experimental detection. If we were to change our perspective, if there are extra dimensions in this context, thought it would be obvious in experiments, and they were surprised by the result. It's a very clever idea, and as it's so simple, the wonders why it can come up with it first. Okay. Large mass hierarchy from a small dimension. We propose a new high-dimensional mechanism for solving the hierarchy problem. The weak scale is generated from the time scales with exponential hierarchy. However, this exponential is not from Gauss interaction, but from the background metric. which is the size of AB of 5 and the center of space-time. To demonstrate a simple explicit example, this mechanism with two free-branes, one of which contains the standard model fields. The phenomenology of these models is new and dramatic. None of the current constraints on theories with very large extra dimensions apply. Monitoring the motions of stars in our sector as to a known star orbiting 17 light-years from Sagittarius A, we can look for tiny but perceptible accelerations caused by a wormhole's presence. Telescopic observation of whose motion reach a position of 1 millionth of a meter per second squared, we do a calculate such measurements to reveal the present star. Now the flight of the sun pulling out as 2 from the wormhole's far side. If wormholes do exist, there is the question of whether they exist 2 points in their own universe or in 2 different parallel universes. The difference is accidental because either scenarios should produce similar predictable effects. It will also be providing hints that unseen smaller black holes nearby that is unknown nature. Wormholes may even be time machines provided a ways to travel backwards, as suggested by Stephen Hawking in his final book. Wormholes also represent quantum mechanics, which rules the world of atoms and particles, particles can pop out of empty space only to disappear a moment later. This knows in Hawking's experiment that a particle can be created by not wormholes. Statistically, wormholes may have formed in the early universe from the form of particles popping in and out of existence. Some of these primordial wormholes may still be around today. Recent experiments on quantum teleportation disembodied transfer of quantum information from one location to another has turned out to work in a very similar way the two black holes connected to a wormhole. These experiments appear to solve the quantum information paradox, which suggests physical information could permanently disappear in a black hole. But they also reveal a deep connection between the notoriously incompatible quantum physics and gravity, wormholes being relevant to both. VR equals EPR, which will be instrumental in the construction of the theory of everything. The fact that wormholes play a role in fractal developments is unlikely to go unnoticed. We may not have seen them, but they could certainly be out there. They may even help us understand some of the deepest cosmic mysteries of whether our universe is the only one. acidic particle falls into a newly forming canvas that has high enough energy spontaneously decay into two new particles. One of these particles can escape through the wormhole, while the other can go reflected back through the opening due to the strange physics operating inside these tunnels. If a new particle enters the wormhole and collides with the reflected particle, the author of the paper found that this collision can reach arbitrarily high energies. This means that what we see on our end of the wormhole can be shallow high-energy radiation, an unstable burst of energy. And we know these kinds of particle showers are possible for opening wormholes. We can look around the universe to see if anything fits the bill, and if we can travel through it. Experimental proposals go. This one certainly doesn't lack ambition. First, take a black hole. Now, make a second black hole that is quantum entangled with it, which means that anything that happens to one of the black holes will seem to have an effect on the other, regardless of how far apart they are. So that sounds a bit easier, but a lot weirder. Feed some information into the first black hole encoded in a quantum particle. It falls beyond the event horizon, a point beyond which not even light can escape. The information is rapidly smeared throughout the black hole, experiment seemingly beyond recall. But have patience. If you link the two black holes in the right way, after a short wait, the quantum information will pop out of the second one, fully refocused to a readable form. To get there, it will travel through a shortcut in space-time that links the two objects of wormhole. That at least is what physicists have predicted. Now, a group by Safir Nizam of the California Institute of Technology has suggested have actually performed this extraordinary experiment, and they are beginning to work with collaborators to put the idea to the test. As the predictions are borne out, the work can offer clues about where to look for the most elusive theory in physics, one that unites quantum mechanics, the theory of general relativity that describes gravity. And for good measure, it would support the idea that space-time is not the fundamental backdrop against which the universe plays out, but is itself woven from the interconnections between particles described by quantum entanglement. ER equals EPR again. Death and resurrection of information. This experiment, as you might have guessed, only requires black holes in the usual sense, meaning massive stars that are collapsed by their own gravity to an infinitesimally small body. The researchers say it can be done on a lab benchtop using just a few atoms or ions. All the same, the ideas rise out of theoretical research and astrophysical black holes struggling to resolve the deep and unsettling question. Do these all-devouring monsters destroy information irreversibly? It's widely thought that information like energy should obey conservation. The total amount of information in the universe will always stay the same. That's what quantum mechanics seem to imply. The wave function that describes quantum entities always evolves smoothly in an information-conserving way and can't be suddenly snuffed out. But black holes do seem to remove information from the universe. If say a quantum bit or qubit falls into a black hole, it can no longer be observed from outside the event horizon. One possible resolution of of this black hole information paradox can be found within the radiation that black holes emit from their event horizons. Hawking radiation, predicted by Stephen Hawking in the 70s, will cause a black hole to lose gravitational energy and thus mass. In effect, black holes are not determined, they slowly evaporate. Hawking initially believed that even if a black hole fully evaporated, the information it consumed would remain lost forever. But an idea known as the Adscft Correspondence, strangely, shows how the photons of Hawking radiation might be able to encode information about the interior of a black hole, thereby carrying that information back up to the universe at large. The Adscft Correspondence was postulated by people physicist John Malvitino in 1997 as widely regarded as one of the most promising directions in which to pursue theories of quantum gravity. It suggests that the physical structure of space-time in, say, 4 dimensions is equivalent to the operation of quantum theory at a 3-dimensional boundary. The holographic principle. This connection is strange, deep, and surprising. It shows that if you construct a space-time with a particular kind of curvature of this gravity known as anti-de Sitter space, that's the ADS part, mathematical description turns out to be equivalent to the description of part of quantum field theory, called the conformal field theory. That's the CFT part. In one fewer dimension. In other words, the correspondence works like a hologram. All of the information in the higher dimension of space-time projection is encoded within the lower dimensional quantum interactions. The holographic principle was first proposed by the physicist Nobel laureate Joel Hoff and Malvitino as the CFT correspondence provided the first concrete proof and picture of how it might work for a particular form of space-time. In this view, what looks like continuous space in the ADS universe manifests in the CFT quantum view as entanglement, the interdependence of quantum bits. Here, said Malvitino, the emergence of space-time is supposed to happen in systems with a large number of qubits that are highly entangled and highly interacting. In other words, quantum entanglement can produce a space-time that seems to have gravity in it. Gravity, you might say, is from quantum effects. Very gravity entanglement emergent. And so what does all this have to do with black holes? The black hole information paradox asks what happens to the information that gets tossed into a black hole. The Adscft correspondence is a key component of one proposed solution since it supplies the means by which quantum entanglement would encode the information in Hawking radiation and prevent it from being irrevocably lost. In 2004, Hawking explained, assuming the Adscft conjecture is true, you could recover this information by capturing every single Hawking photon of black hole radiance in its entire lifetime before it's fully evaporated. If you were a god, you could collect all the Hawking photons, then in principle some ungodly calculation you could use to extract the information in each swallowed qubit. Maybe generate a whole new universe. Up until the halfway point of the black hole evaporation, information inside it remains concealed. After that point, however, the black hole starts to reveal its information of Hawking radiation. So you have a long way to wait before you can start to get at it. For a closing argument made in 1993, it will then seep out gradually at a constant rate. In 2007, they revised this picture by showing that in fact, after the halfway point, the information emerges more rapidly than that. Weirdly enough, once the black hole is half evaporated, any further quantum information passed into it, it literally bounces right back. That is because the black hole has by that stage become so quantum entangled that the Hawking radiation is already emitted, that any more information involved is effectively registered at once in any further radiation emits. The black hole then acts like the information mirror. How does gravity work in the quantum regime? A holographic duality and string theory offers a powerful tool for unraveling the mystery. ADS CFT. Get out a connection between black hole thermodynamics and quantum information theory that invokes a phenomenon called quantum scrambling. This effect is rather like the way heat gets evenly distributed in the system over time and comes into equilibrium, a process called thermalization. Imagine creating two systems containing localized pockets of energy and then bringing them into contact. The energy will spread throughout both systems until they have lost the memory of the initial starting state, and you can no longer distinguish them. Scrambling is the same in essence, but much stronger. You can distinguish two scrambled systems, even if you want to do not just locally, with correlations across both systems. Scrambling is a very strong form of thermalization. It is the delocalization of quantum information. It's a quantum analog of shuffling. If you start with an older type of card, you say shuffled, you look at the card and think there's an obvious pattern with it. This is not the same thing that you've made it entirely random. It's sufficiently mixed up that you have to be very sophisticated to know that it's not random. It happens much sooner than genuine random. Almost any main-body quantum system is eventually going to scramble. The black holes are special with the rate at which the pack of cards get shuffled. Depending on the technique you use to spread the rate of the system depends on the details of how the particles in that system interact. These details are described mathematically by a function called Hamiltonian. It appears every time the spinning from a black hole means to spread the quantum information at the fastest rate possible. And that's what leads to the conclusion. Black holes act like fast quantum scrambled circuits, so once they are sufficiently entangled with their own Hawking radiation, information entered them shows up very quickly in that radiation. All of a sudden, you have to read up the black hole, and this Hawking radiation are entangled whether they are until they're half evaporated before they happen. If there is a faster alternative for getting at information, entangle that black hole maximally with something else, like another black hole. That's the information prepared in 2019 or 2016 at Princeton. To entangle a pair of black holes this way, they say that a cheaper style for the first black hole will be registered in the other. Showed that adding further couplings between the black holes, you can make the transfer of quantum information between them formally identical to the process called quantum teleportation. Where the entanglement between two particles is used to transfer the quantum state of one of them to the other. The target particle ends up looking identical to the initial one. In fact, there is a meaningful way to say that it is not the same particle. Vanished for one part of space and reconstituted in another. Their entanglement acts like a bridge for the information. Systems with the dynamics of black holes allow teleportation on the fastest possible timescale. That's because any information that enters one of them is quickly shared from all its particles and thus, because of the entanglement of the second black hole, it's shared quickly with that one too. Quantum teleportation has been demonstrated experimentally many times and is already being used to send securely encrypted information to a quantum device. It does not, however, allow for messages instantly because the signal can't be decoded. It looks red, but they're adding additional information sent by the classical mechanism, which means it can't follow faster. The scheme requires an additional means beyond impact couplers of black hole. The real coupler is to send the essential classic data with which the entanglement teleports the signal from one black hole to another. For these power quantum information theorists review the process according to the Adscft Correspondence. The channel between the black holes created by the entanglement equivalent in description based on general relativity to a wormhole in space-time that connects them. In this way, qubits enter one black hole and travel down the wormhole to the other. Notice that wormholes, while created by general relativity, have been thought to be non-traversable. You couldn't actually set anything down them, but it showed how quantum information theory teleportation could be used with an Adscft to make a wormhole that is traversable. If the Adscft correspondence is real, it allows a radical change in perspective. principal researchers to construct systems entirely equivalent to one light branching black holes with tiny quantum circuits in the right line and teleporting qubits between them. You have come up with a practical proposal for how to do that. What you need to make is a group of quantum particles act like a black hole. In this context, they say, is to assign their interactions to a Hamiltonian that makes them very rapid scramblers. On whose scrambling was in fact only demonstrated unambiguously for the first time last year, adding to an experimental proposal, created a quantum circuit made from electrically charged ions whose quantum states had been entangled in real systems. Like this, scrambling can be hard to spot among other unruly processes such as classical noise and quantum decoherence. Like scramble, decoherence arises from the interaction and confluence of entanglement of particles. But in this case, they are particles of the environment and the quantum systems themselves. As decoherence proceeds, information leaks into the environment and essentially lost for good. Decoherence is impossible to avoid entirely, which makes it above both quantum computers. Any quantum calculation has to be completed before decoherence randomizer condition. Usually decoherence has effect on so it has been very hard to see the latter clearly. The real scheme figured out how to distinguish the two with quantum teleportation operating on encoded a circuit made from 7 coupled ytterbium ions held in a row, each acting as a single qubit. To process the quantum computation effect, teleported a single qubit from one end of the row to the other. To measure the rate of scrambling, the researchers compared the teleportation process and the algorithm of all forward, and then in reverse. As to what happened backward. Without scrambling, the two processes remain correlated. But if scrambling disperses the information initially encoded to qubits among the others, the outcomes of the forward and backward computations became less correlated. The system has changed in its initial state, and so the teleportation can be precisely reversed. If we're correlated, not much is happening. But if we're scrambling, correlation goes to zero. That's what we call as time compressed. While the highly consequent the quantum circuits during which the third use can be used to construct a simple analog of the situation vision or a traversable one that could teleport a qubit. In this version, we map each of the two black holes is made of just qubits, all of which are maximally entangling with one another. Their protocol introduces a further interaction between the two groups of qubits which act as the additional channel needed by dial and colleagues to improve the teleportation process. Intuition tells us that a handful of ions in a electromagnetic trap is nothing like a collapsed star and there's no life to escape. But here's the mind-bending thing: if the Adscft Correspondence is right, then the experiment is more a laboratory analog of black holes. These two types of systems is the entirety equivalent. The coupled ions are precisely what in an ADS space a very tiny black hole would look like. With the illustration of how Martinez conjecture tells us something real about the way the universe is constituted, our intuitions about what things are would be shattered. Described as world-wide quantum circuit, Monroe recognized that it was more or less precisely the kind of circuit that people used to demonstrate quantum scrambling. Although Monroe had been aware of universalist ideas of using quantum entanglement because of quantum information for black hole, he said to his team had chosen their circuit to illustrate quantum scrambling with a very different connection to gravity. If the circuit is also single, the colleagues could indeed be built and should be rather straightforward to look for the effect they predict. Can that be done? Absolutely no. What one would expect to see is that freshly quantitative information owing to one of the two black holes qubit systems would be scrambled in a period of time, but after a predictable amount of time it would pop out again, unscrambling the other qubits, and it jumped down the wormhole. But is not so much that the information is transferred, but the two systems are coupled after all. If the information reappears in a readable form, needing no decoding, even though the first black hole is fully scrambled. At this stage, experiments using quantum circuits can hopefully create only a simplified toy model of the space-time we inhabit, described by general relativity. goal is to get a space that is governed by Einstein's equation of longitude, and the only system that are known to produce it are very special. It's probably hard to make in the lab, but you have the goal of these authors is to create a system complex enough to have some features of gravity, though not all, but simple enough to could actually be done. If the results of such an experiment bear out the predictions with ADS findings to be proved correct, that depends on what point to do. For example, the theoretical analysis of these quantum circuits is fully consistent with standard quantum theory. It is simpler and more economical to describe what is going on in the language of gravity as a passage through a wormhole. One could explain it all using the Schrödinger equation. There is a much simpler explanation that invokes black holes. Then is the goal of physics to look for such a common and describe a meaningful reality for a description. You could take one to describe superconductivity and other quantum phenomena purely in terms of electron wave functions. So it's much simpler to use a quasi-particle picture to consider so-called superpairs for entangled electrons. We don't question the reality of these quasi-particles, and so why should we deny the reality of two-bit wormholes? For this reason, from observation patterns, we might learn something that has nothing to do with namely black holes. More ambitious versions of the experiment using many qubit systems could reveal interesting properties of space-time itself. These experiments can be done with the possibility to create more and more complex mechanical systems that detect more aspects of the emergence of space-time from quantum systems. For experiments of this type, we even provide an experimental code of the mathematics of string theory. That's the process. We take an experiment, somebody is talking to their experimenters and adapting quantum scrambled circuits into the field effect of the far out ideas. All their kinds of plans appear to emerge, but the conversations themselves are something of a cocktail. Using a theoretical physics and quantum gravity talking to experimental atomic physicists. Historically, they have been about as far apart as any two groups in the physics department. So this is amazing, and it's great. The rest of the wormholes are double-trace deformation. After turning on the interaction that closes two boundaries of the eternal BTZ black hole, we find the quantum matter stress tensor with limited average null energies, gravitational backreaction renders Einstein-Rosen-Rich traversable. Such a traversable wormhole is an interesting interpretation in the context of ER equals EPR, which we suggest might be related to quantum teleportation. However, it cannot be used to violate causality. We also discussed implications for energy and holographic entropy in the dual CFP description. Quantum gravity in the lab, teleportation by size and traversable wormhole. With the long-term goal of studying models of quantum gravity in the lab, we propose holographic teleportation protocols that can be readily executed in tabletop experiments. These protocols exhibit similarities that see the recent traversable wormhole constructions of 1-2. Information will experiment that the one half of an entangled system will follow will be coupled between the two halves and scrambled to the other half. We introduce the concept of teleportation by science to capture how the physics of operations close naturally leads to information transmission. The transmission of a signal to a semi-classical holographic wormhole corresponds to another special property of the operator size distribution we call size widening. For more general systems, we have not clean emergent geometry, we argue that imperfect size widening is a generalization of traversable wormhole phenomena. In addition, upon the singular and continuous function of high temperatures with large time for general periodic systems, even though it does not correspond to a signal going through a geometric wormhole. Or rather to an interference effect involving macroscopically different emergent geometries. Finally, we outline implementations feasible with current technology into experimental platforms, like atomized and trapped particles. H-curve of Hawking radiation from semi-classical geometry. We consider a gravity theory coupled to matter where the matter is a higher dimensional holographic dual. In such a theory, finding quantum extremal surfaces become equivalent to finding the RT surfaces in a higher dimensional theory. Using this, we come purity of entropy of Hawking radiation and argument follows the Page source. Suggested by recent computations of the entropy and entanglement limits for all black holes. The higher dimensional geometry connects the radiation to the black hole interior in the spirit of PR equals BPR. The black hole interior then becomes part of the entanglement wedge of the radiation. Inspired by this, we propose a new rule for computing the entropy of quantum systems entangled with the gravitational systems, which involves searching for islands and determining the entanglement wedge. Virtually working by a double trace deformation. Okay, I will continue this later because this is good. It's going to be the next section. It's going to be de facto part 47. I will continue it in a little bit because it's very intriguing. Okay, this is really part 47 of the Origin Msi series, but because I am adding on to part 40, which the original version was corrupted, I saved this. It's labeled as 40C. So we were talking about holographic theory and quantum entanglement, in which there have some new breakthrough discoveries. Currently, I'm reading with paper aspects of holographic entanglement. This is an extended version of a full report where an holographic interpretation of entanglement entropy in conformal field theories is proposed from Adscft and Determinism, conformal field theory correspondence, in addition to a concise review of relevant recent progress on entanglement entropy details noted in the earlier letter. This paper includes the following new results. We give a thorough and correct derivation of our claim which relates the entanglement entropy with the minimal area surface in the ADS3 CSP2 case, as well as some further discussions on higher dimensional cases. Also, the relation between the entanglement entropy and central charges, and fluidity conformal field theory is examined. We check that the logarithmic part of the fluidity entanglement entropy computed in the CSP side agrees with the ADS5 result, at least for a specific condition. Finally, we estimate the entanglement entropy of massive series in generic dimensions by making these proposals. Now let's get to the articles. Notice this is about neutron wormholes allowing information to black holes. Physicists theorize that a new traversal behind the wormhole could resolve the Doppler paradox and rescue information that falls into black holes. The first theoretical wormholes immediately collapse and disappear before anything can get through. Kip Thorne wondered whether it might be possible for an advanced sci-fi civilization to stabilize a wormhole long enough for something or someone to traverse it. He figured out that such a civilization could in fact align the flow of a wormhole with the chaotic maturity. He calculates the tendency to collapse. Material is the representative energy, which would reflect radiation and repulse space-time apart from itself. Reagan used this trick in his contact attributing the invention of chaotic material to an area of lost civilization to avoid getting into the water. Meanwhile, those particulars enthralled Thorne with students and many physicists spent years exploring traversable wormholes and their theoretical implications. They discovered that these wormholes can serve as time machines and multi-time travel paradoxes, which were evidence that dark material is forbidden in nature. Maybe not. Now, decades later, a new species of traversable wormholes emerged through the black material with their potential for helping physicists resolve the fractal paradox of black holes. Things that fall into black holes seem to vanish without a trace. This polarization of information breaks the rules of quantum mechanics and it so puzzles experts in recent years. Some argue that black holes really don't really exist, but space and time strangely end at the horizons. Where your findings started last year, paper. Okay, so this is part 47, also part 40D. So we're continuing off from 40. So consider either way. This may or may not be the last version of this series. I'm not sure because there's a lot more that I need to go through. Anyway, the first paper I'm going to read from is talking about holographic theory and randomness combined. This is an extended version of the short report where holographic interpretation of entanglement, entropy, and conformal field theory is proposed from ADSC and are considered conformal field theory correspondence. In addition to a concise review of relevant recent progress on entanglement, entropy, and details omitted in the earlier letter, this paper includes the following several new results. We have a more direct derivation of our code which relates the entanglement entropy with the minimal area differences in the ADS3 CFD2 case, as well as some further discussions on higher dimensional cases. Also, the relation between the entanglement entropy and central plugins and purely component theory is examined. We expect that the logarithmic part of the 4G entanglement entropy computed in the CFT side agrees with the ADS5 result at least under a specific condition. Finally, estimate the entanglement entropy of massive theories in generic dimensions by making use of our proposal. Okay, let's get back to that first article where I was reading about traversable wormholes, which have just been discovered while information to escape black holes. Physicists theorize that a new kind of traversable wormhole could resolve a baffling paradox and rescue information that falls into black holes. While the simple theoretical wormholes immediately collapsed, it's for anything to get through, Kip Thorne wondered whether it might be possible for an infinitely advanced sci-fi civilization to stabilize the wormhole long enough for something or someone to traverse it. He figured that such a civilization could in fact line the field of the wormhole with exotic material, but counteracts its tendency to collapse. The material would possess negative energy, which would deflect radiation and repulse space-time apart from itself. Carl Sagan used a trick of contact attributing the invention of the exotic material to an earlier lost civilization to avoid getting into particulars. Meanwhile, those particulars enthralled Kip Thorne, his students, and many other physicists who spent years exploring traversable wormholes and their theoretical implications. They discovered that these wormholes can serve as time machines invoking time travel paradox, with evidence that exotic material is forbidden in nature, but maybe not. As referenced from earlier articles. Now, decades later, a new species of traversable wormholes emerged, free of exotic material and full of potential for helping physicists resolve a baffling paradox about black holes. Paradox is a very problem that plagued the early draft of Contact. There's left Thorne who contemplates traversable wormholes in the first place. Things that fall into black holes seem to vanish without a trace. The sort of erasure of information breaks the rules of quantum mechanics, and it so puzzles experts that in recent years some of our group black hole theories don't even exist. But space and time strangely in at horizons. Earlier findings started last year's paper that reported the first traversable wormhole that doesn't require the insertion of exotic materials to still open. They have found that the repulse of negative energy the wormhole's approach can be generated from the outside by a special quantum connection between the pair of black holes that form the wormhole's two mouths. When the black holes are connected in the right way, something tossed into one will shimmy along the wormhole and, following certain events in the outside universe, exit the second. Remarkably, it was noticed that their scenario is mathematically equivalent to a process called quantum teleportation, which is key to quantum cryptography and can be demonstrated in laboratory experiments. Very interesting. I will say groundbreaking. Black hole and quantum gravity for Caltech resolution of principal wormhole comes as a surprise, with implications for the black hole information paradox and black hole interior. An observer can enter the black hole and then escape can tell about what she saw. This suggests that black hole interiors really exist, and that what goes in must come out. How to get a traversable wormhole? The wormhole can exist in locations. The simplest theoretical wormholes immediately goes off because the throat is attracted to itself. A quantum connection between the mouths or a throat collapse allows something to travel through the wormhole. The cryptic equation. The new wormhole work began in 2013 when Jeffries attended an extremely popular strength conference. Speaker Juan Lagutina, professor of physics at the Institute of Advanced Study in Princeton, recently concluded based on early system arguments that ER equals EPR. That is wormholes between this point in space-time, the simplest of which are called Einstein rules, and ER versions are equivalent in an ill-defined way to entangled quantum particles, also known as Adscft Rosen or EPR pairs. The ER equals EPR conjecture posed by Baldacchino, Leonard Stepstein, Stanford, that accepts all the modern incarnation of the infamous black hole information paradox of tiny space-time geometry governed by general relativity, with the instantaneous quantum connection between particles and Einstein called spooky action physics. Paradox is used since 1974 when Stephen Hawking determined that black holes evaporate, so giving off heat in the form of particles now known as Hawking radiation. After black hole that is heat is completely random, it contains no information of the black hole's contents. As the black hole brings out of existence, so does the universe is record of everything that went inside. This violates a principle called unitarity, the backbone of quantum theory, which shows that as particles interact, information about them is never lost. Moments scramble so that if you reverse the arrow of time in the universe's quantum evolution, you see things unscramble into an exact recreation of the past. Almost everyone believes in unitarity, which means information must escape black holes, but how? In the last 5 years, some theorists at the University of California have argued that black holes are empty shells with no truth at all. Joseph Koczynski, upon hitting a black hole derivative would fizzle into a firewall and radiate out again. The theorists believe in black hole theories and form a transition across the horizon, but in order to understand them, we must discover the field of information that falls in time. Critical to building a working quantum theory of gravity belongs something with the quantum and space descriptions of nature that come into sharpest relief in black hole interiors, where extreme gravity acts on quantum scale. The quantum gravity connection is what drew Maldacena and later Jeffries to the ER equals EPR idea and to wormholes. The implied relationship between space-time and quantum entanglement implies that ER equals EPR resonated with the popular recent group that space is initially stitched into existence by quantum entanglement. Seems that wormholes had a role to play in stitching together space-time and in letting black hole information worm its way out of black holes. But how might this work? When Jeffries heard Maldacena talk about a specific equation and the evidence for it, he was aware that a standard ER wormhole is unstable and non-traversable. He wondered what Maldacena's duality would mean for a traversable wormhole after one and others played with decades ago. Many years after that talk, Jeffries and his collaborators presented their answer. The work extends ER equals EPR idea by equating not a standard wormhole and a pair of entanglement particles, but a traversable wormhole and quantum teleportation. A protocol discovered in 1993 that allows a quantum system to disappear and reappear unscathed somewhere else. Maldacena read the paper and viewed it as a very nice idea, but the idea after someone tells you it's obvious. Maldacena and two collaborators immediately began exploring the new wormhole ramifications for the black hole information paradox. Their paper appeared in April. The study of Stanford followed this with a paper about wormhole teleportation. In July, the wormhole gives an interesting geometric picture of how teleportation happens simultaneously. The message actually goes through the wormhole. In their paper diving into traversable wormholes published by Maldacena, Stanford began to consider a wormhole in the Yukon that connects two black holes. Parent black hole and daughter one, formed from half of the quantum radiation given off by the parent as a evaporates. Two systems are as entangled as they can be. Here, the fate of the older black hole's information is clear. It worms its way out of the protocol. During an interview this month in his office, Msi observed Argentine American's track record of influential insights, described as radical music. On the right side, when he talked just the black hole, Msi drew a third picture of two black holes connected by an irreversible wormhole. On the left, he sketched a quantum teleportation experiment formed by the famous fictional experiment with Alice and Bob were in possession of the titled quantum particles A and B. Say Alice wants to teleport huge box. She proposed a combined state of the field A, measures that combined state, reducing it to pair of 6, 1, or 0, and sends the result of this measurement to Bob. We can then use this as a key for operating on B in a way that recreates the state pool. Voila! A unit of quantum information is teleported from one place to the other, while the Seymour turned to the right side of the black hole. You can do operations with a pair of black holes that are nearly equivalent to what I discussed about quantum teleportation. And in that picture, this message really goes through the world. The Alice goes through the healing to black hole A. She then measures a particle of its Hawking radiation A and transmits the results of the measurement to the external universe to Bob, who can use this knowledge to operate on B. The Hawking particle comes out of black hole B. Bob's operation reconstructs Q, which appears to pop out of B, a perfect match for the particle that fell into A. This is why some physicists are excited. Geologists and wall wormhole allows information to be recovered from black holes in their paper that sets up their wormhole in negatively curved space-time geometry that often serves as a useful pleasure for quantum gravity. However, the wormhole ideas seem to extend to the real world as long as two black holes are coupled in the right way. They have to be causally connected, and with the nature of the direction that we took, it's the simplest thing you can imagine, Jeffrey. If you allow the Hawking radiation from one of the black holes to fall into the other, the two black holes become entangled, and the quantum information falls into one and exits the other. The quantum teleportation format includes using these reversible wormholes as time machines. Anything that goes through the wormhole has to wait for Alice's message to travel to Bob in the outside universe before it can exit Bob's black hole. So the wormhole doesn't offer any support or boost that could be exploited for time travel. It seems reversible wormholes might be permitted in nature as long as they offer no speed advantage. Reversible wormholes are like throwing a basketball. Where you can only get one if you are rich enough not to need it. The naive optimist. While traversable wormholes will revolutionize space travel, according to Preston, the new wormhole discovery provides a promising resolution to the black hole firewall question, thus suggesting that there is no firewall at black hole horizon. The discovery rescues what we call black hole complementarity, which means the interior and exterior black holes are not really two different systems, but rather two very different complementary ways of looking at the same system. The complementarity holds that we widely assume they will passing across the black hole horizon from one rock to the other. Contacts every hour wouldn't notice anything strange. It seems more likely if under current conditions, she could even slide all the way through a Dow-Jeffries wall wormhole. The wormhole also safeguards unitarity. The principle that information is never lost, at least for the time of black hole study. Whether it falls into one black hole, eventually exits the other, as Hawking radiation, Preston said, which can be thought of in some way as a very thermal copy of the black hole interior. Looking at the findings to their logical conclusion, Preston thinks it ought to be possible at least for infinitely advanced civilization to influence the interior of one of these black holes by manipulating its radiation. This sounds crazy in an email, but it might make sense if you consider the radiation which is entangled with the black hole EPR as being connected to the black hole interior by wormholes, ER. Then tickling the radiation can send a message which can be read from inside the black hole. Huh. Wow. He added we still have a ways to go before we can flesh out this picture in more detail. Indeed, obstacles remain in the quest to generalize the new wormhole findings to a statement about the fate of all quantum information, or the meaning of ER equals EPR. In Malvicina and Sunskine's paper proposing ER equals EPR, they included a sketch that became known as the octopus. The black hole with tentacles, wormholes meaning distant Hawking particles that are evaporated out. The author explained that the sketch illustrates the entanglement pattern between the black hole and the Hawking radiation. We expect that this entanglement leads to the interior geometry of the black hole. Wasn't that Mr. a mathematician and general relativity expert at the University of Wellington, New Zealand, will say wormholes since the 1990s, the most literal reading of the octopus picture doesn't work. If the orbs of wormholes formed from single Hawking particles would be so thin that cubics could never fit through. A traversable wormhole fluid is transparent only to wave packets. Its size smaller than the throat radius. Big wave packets will simply bounce off any small wormhole throat without crossing to the other side. Stanford co-wrote the recent paper Malvicina and Mack found that this is a problem with a simple interpretation of the ER equals EPR in which each particle Hawking radiation and its own tentacle-like wormhole. However, a more speculative interpretation of EPR that he and others on the lines of not Hawking is failing. The idea is that in order to recover the information from the Hawking radiation using the traversable wormhole, one has to gather the Hawking radiation together and act on it in a complicated way. This complicated collective measurement reveals information about the particles that fell in. He has the effect instead of creating a large traversable wormhole out of the small and unhelpful octopus tentacles. The information will then propagate through this large wormhole. Malvicina added that simply put, the theory of quantum gravity might have a new generalized notion of geometry for which ER equals EPR. We think quantum gravity should obey this principle, he said. We view it more as a guide to the theory. In his 1994 popular science book, Black Holes and Time Warps, Kip Thorne celebrated the style of reasoning involved in wormhole research. The new type of thought experiment pushes the laws of physics harder than the type triggered by Carl Sagan's phone call to me. He wrote, thought experiments that ask what things do the laws of physics permit and infinitely advanced civilization to do, and what things do the laws forbid. Very interesting. Okay, so these are some of the papers associated with this article. Teleporting an unknown quantum state by geographical and Einstein-Podolsky-Rosen channels. An unknown quantum state can be disassembled into and later reconstructed from purely classical information to purely non-classical Einstein-Podolsky-Rosen EPR correlations. And so the sender Alice and the receiver Bob must prearrange the sharing of an EPR correlated particle. Alice makes a direct measurement on the EPR particle, and the unknown quantum system returns Bob the classical result of this measurement. So with this, Bob can convert the state of his EPR particle to the exact replica of the unknown state, which Alice destroyed. Teleportation through the wormhole. Leonard Susskind. ER equals EPR allows us to think of quantum teleportation as communication of quantum information. Space-time wormholes connected in time systems. This condition for teleportation renders the wormhole traversable so that a quantum system entering one end of the ERB will, after a suitable time, appear at the other end. Teleportation requires the transfer of classical information outside the horizon. The classical bit string carries no information about the teleported system. The teleported system passes through the ERB, leaving no trace outside the horizon. In general, the teleported system will retain memory of what it encountered in the world. This phenomenon can be observable in a laboratory equipped with quantum computers. Very interesting. Okay, so now we are talking about quantum pairs and how they stitch space-time. There is an unexpected duality between tensor networks, the physics properties of exotic materials and string theory that goes to black hole physics and quantum gravity. Both something profound. Tensors crop up all over physics. They're simply mathematical objects that represent multiple numbers at the same time. A vector velocity is a simple tensor. The factor value for both speed and direction of motion. More complicated tensors come together into networks and used to simplify calculus for complex systems made of many different interacting parts, including the intricate interactions of the vast number of subatomic particles that make up matter. Adapting tensor networks to cosmology, among other benefits, both could help resolve an ongoing debate about the nature of space-time itself. It is critical for the deep connection between quantum entanglement, Einstein's projection of distance in space-time geometry at a small scale. Since the physicist John Wheeler first described the latter as a doubly false decades ago. So geometry of scale complements the time scale, the shortest possible distance, but it looks less and less like space-time. It's not really geometry anymore, it's something else. An emergent space that arises from something more fundamental. Now the problem of what the sort of fundamental picture might be. If they strongly suspect there is little with the quantum information. We talk about information being encoded, we mean that we can split a system into parts and there is some correlation among the parts. But if we learn something about one part, we're observing another part. This is the essence of entanglement. This is how I used to answer questions on tests, so I wrote down the answer. I would use one question to get information from it to answer another question. So I guess those questions were also entangled. It worked very well. It's very well on those tests when I was able to do that. It is common to speak of fabric of space-time, a metaphor that evokes the concept of weaving individual threads together to form a smooth, continuous form. That thread is fundamentally quantum. Entanglement is the fabric of space-time. It's the thread that binds the systems together that makes the collective properties different from individual properties. See the interesting collective media where you need to understand how that entanglement is distributed. Tensor networks provide a mathematical tool capable of doing that. Space-time arises out of a series of interlinked nodes in a complex network, with individual morsels of quantum information fitted together like Legos. Entanglement is the glue that holds the network together. If we want to understand space-time, we must think geometrically about entanglement. Since that is how the information is encoded between the immense number of interacting nodes in the system. Many bodies one network. Not an easy feat to model a complex quantum system. Making with more than two interacting parts poses a challenge. For example, Earth, Moon, and Sun, three-body problem. Turns a relatively straightforward problem with an exact solution into one that is inherently chaotic. The long-term predictions require powerful previously simple and approximations of the system's evolution. The more objects in the system, the more difficult the calculations and less difficulty reasoning for the world. From here, we start using physics. Now imagine a quantum system with many billions of atoms, all of which interact with each other according to complicated quantum equations. That's the other difficulty of chemistry physics, but actually we can put particles in the system so a brute force approach to calculations just so far. Consider a lump of gold. It is comprised of many billions of atoms, all of which interact with one another. When those interactions emerge the various properties of gold, such as current, chemical conductivity. Atoms are tiny little quantum mechanical things, and you put atoms together in real wonderful things. But at this scale, the rules of quantum mechanics apply. Physicists need to precisely calculate the wave function that will fulfilled, which describes the state of the system. That wave function is a many-noted hydra of exponential complexity. The individual lump of gold has just 100 atoms each, with a quantum spin that can move up or down with a number of possible states, whether it's 2 to the 100th power or a million trillion trillion. With every added atom, the probability goes, problem grows exponentially worse. Worse still if you care to start anything in addition to the atomic spins, which any realistic model would. If you take the entirety of this universe and fill it up with our best storage material, the best hardware that we can buy to only store the state of about 300 spins. So this information is good, but it's not all physical. No one has ever measured all these numbers. Tensor networks enable physicists to compress all the information contained within the wave function and focus on just those properties physicists can measure in experiments. How much material bends light, for example, or how much it absorbs sound, or how well it conducts electricity. Tensor is a black box, a little source that takes in one collection of numbers and spits out another. So it's possible to plug in a simple wave function to provide our remaining non-interacting electrons, each in its lowest energy state, and run tensors on the system over and over until the process produces a wave function for a large, complicated system of the billions of interacting atoms in a lump of gold. The result is a flow diagram that represents this complicated lump of gold as innovation, much like the development of finite diagrams in the mid-20th century, which simplified out physicists, represent particle interaction. A tensor network and geometry just baseline. The key to achieving this simplification is a principle called locality. Any given electron only interacts with its nearest neighboring electrons. Entangling each of many electrons with its neighbors produces a series of nodes in the network. These nodes are the tensors or entanglement links them together. All those interconnected nodes make up the network. Complex calculation thus becomes easy to visualize. Sometimes it even reduces to much simpler counting problem. There are many different types of tensor networks, but among the most useful is the one run by the acronym NER, Multi-Scale Entanglement Renormalization Ansatz. Here's how it works in practice. Imagine a one-dimensional line of electrons with groups of 8 individual electrons designated A to H with fundamental units of quantum information sequence and entangled with a bunch of nearest neighbors properties. A entangled with B, C entangled with D, entangled with F, and G entangled with H. This produces a higher level of the network, now entangled AB with C, D, and E, F, and G, H. We get to the next level of the network, finally, ABCD, entangled with D, F, G, H, form the highest layer. In other words, we could say that one uses entanglement to both up to many body wave functions. Observed in a paper last year. Alright, so physicists are excited about the potential of the tensor network, especially NERA, to eliminate attacks to quantum gravity, because the networks demonstrate how a single geometric structure can emerge from complicated interactions between many objects. It makes use of this emergent geometry by showing how to explain the mechanism by which a smooth continuous space-time can emerge from discrete bits of quantum information. Sometimes mathematics inadvertently find an emergent extra dimension, once they develop tensor networks. The technique yields a two-dimensional system out of one dimension. Meanwhile, gravity deals with subtracting a dimension, going from 3 to 2, with the development of what's known as the holographic principle. It all joins together, with lead in the middle. The two concepts might connect for a more sophisticated understanding of space-time. In the 1970s, a physicist named Jacob Bekenstein showed that the information about black holes' material is encoded in a two-dimensional surface, the boundary, rather than in its three-dimensional volume, the bulk. Years later, Leonard Susskind and Joe P. Huff extended this notion to the entire universe, likening it to a hologram. Our three-dimensional universe and all its code emerges from a two-dimensional source code. In 1997, Ron Wamachina found a concrete example of holography in action, demonstrating that a trade model describing a flat space without gravity is equivalent to a description of a solid-shaped space with gravity. Its connection is what physicists call a duality. This is the Adscft Correspondence. Malcolm Armstrong in Springfield at the University of British Columbia, Vancouver, likens the holographic concept to a two-dimensional computer chip that contains the code for creating a three-dimensional virtual world of a video game. We live within that 3D game space. In one sense, our space is illusory and ephemeral image projected into thin air. But as Armstrong emphasizes, there is still an actual physical thing in your computer that stores all the information. The idea of gaining broad acceptance among theoretical physicists that can still grapple the problem of precisely how a lower dimension would store information about the geometry of space. And Ransdorf imagines entanglement creating space-time gradually. Along the outside of the figure, the individual particles, dots, become entangled with each other. Even tangled pairs then become entangled with other pairs. As more particles become entangled, the three-dimensional structure of space-time emerges. Sticking point is that our metaphorical memory chip has to be a kind of quantum computer, where the traditional 1 and 0 used to encode information are replaced with qubits capable of being zeros, ones, and everything in between simultaneously. Those qubits must be connected via entanglements, whereby the speed of one qubit is determined by the speed of its neighbor. For any realistic 3D world can be encoded. Similarly, entanglement seems to be fundamental to the existence of space. This was the conclusion reached by a pair of postdocs in 2006, who shared the 2015 New Horizons of Physics Prize for this work. The idea was that the way that geometry of space-time is encoded has a lot to do with different parts of this memory chip and how they are entangled with each other. Von Ransdorf explained. Part of their work as well as those subsequent from Malmesino, in 2010, Van Ramsden proposed a thought experiment to demonstrate the critical role of entanglement in the formation of space-time, pondering what would happen if one cuts the memory chip in two, and then remove the entanglement between qubits and opposite halves. He found that space-time begins to tear itself apart. In much the same way that stretching a wad of gum at both ends yields a pinched-looking point in the center as the two halves move further apart. Continuing to split that memory chip into smaller and smaller pieces and unravel space-time until only tiny individual fragments remain that have no connection to one another is sad. Take away the entanglement, your space-time just falls apart, said Van Ramsden. Similarly, if you wanted to build up a space-time, you'd want to start entangled qubits together in particular ways. Combine those insights Swindel's work connecting the entangled structure of space-time and the holographic principle to tensor networks, another crucial piece of the puzzle snaps into place. Curved space-time emerges quite naturally from entanglement in tensor networks via holography. All connected. Space-time is a geometrical representation of this quantum information. It is like a hologram. Think the matrix. Then what does that geometry look like? In the case of how the human satellite space-time, it looks like one of Msi Escher's circle limit figures in the late 50s and early 60s. Escher had long been interested in order and symmetry, incorporating those mathematical concepts into his art ever since 1936 when he visited the Alhambra in Spain, where he found inspiration in the repeating tiling patterns typical of Moorish architecture known as tessellation. The circle limit will cut out illustrations of hyperbolic geometries negatively curved spaces represented in two dimensions, as a distorted disk. Once the flattening of goes into a two-dimensional map of the Earth disturbs the continent. For instance, the circle of the floor, heaven and hell features many repeating figures of angels and demons. In truth, hyperbolic space, all the figures would be the same size. The actual two-dimensional representation, those near the edge appear smaller, and more pinched, with the figures in the center. The diagram of a tensor network also bears a striking resemblance to the circle limit series. The visual manifestation of these will be noticed when you take that fateful string theory class. Today, tensor analysis has been limited to models of space-time like model sequence that don't describe the universe we inhabit. A non-fellowship universe whose expansion is accelerating. Physicists can only translate to dual models in a few special cases. Ideally, they would like to have a universal dictionary, and they would like to be able to derive that dictionary directly rather than make close approximations. We have a funny situation with these dualities because everyone tends to agree that it's important before they know how to derive them. Maybe the tensor network approach will make it possible to deploy them. I think it would be a sign of progress if we could say even with just a toy model, aha, here is the derivation of the dictionary. That would be a strong hint that we are on to something. Over the past year, Single and Ron Stork have collaborated to move their respective work in this area beyond the static picture of space-time to explore how space-time changes over time and how it occurs in response to these changes. Thus far, they will have to derive Einstein's equation, specifically the equivalence principle, evidence of dynamics of space-time as well as geometry, and emerge from entangled qubits. What is the opposite stuff? What is space-time sounds like a completely philosophical question right for us. We actually have some answer to that. One that is concrete, that allows you to calculate space-time is kind of amazing. Advances on tensor network theory, symmetries early on entanglement holography, for the start of the research. This is a short review on selective theory development on tensor network space with only correlated systems. Specifically, we briefly review the statistical symmetry, the Msi state, Fermi calculation of entanglement, Hamiltonian from projective entanglement, pair state steps, and the relation to multi-scale entanglement renormalization on submira, and the ADS-CO2 or Dodge gravity duality. We stress the role of total entanglement in relation of several physical properties and objects to the key language. Other recent results along these lines are also discussed. Universality of gravity from entanglement. The entanglement first law in conformal field theories relates the entanglement entropy of all shaped regions to an integral over the same region involving the expectation value of the CFG stress energy tensor and an entanglement perturbations to CFG vacuum state. In a recent work, this was exploited at V N, and in the context of large N holographic CFT should that any geometry equal to a perturbed CFT state must satisfy Einstein's equations. We derive about pure EDX anti-visitor space. In this result, we investigate the implications of the leading 1 and 1 divided by n corrections the exact CFT conformal field theory result. We can show that these corrections derive the source term for the gravitational equation for some classical bulk states. The expectation value of the bulk stress energy tensor appears as a source in the linearized equation. In particular, the CFT first law leads to Newton's law of gravitation and the fact that all sources of stress energy source the gravitational field in our derivation. The universality of gravity comes directly from the universality of entanglement, the fact that all these appear in the subsystem indicated to entanglement and entropy. Alright, so most of this is done. Now, we're going to move on to space-time, quantum error correcting code. Same code means report errors of quantum computers may also appear for fabric of space-time intrinsic robustness. 1994, mathematician A.T. instituted quantum computers that discovered these devices could quickly capture large numbers in a great much of modern cryptography. Fundamental problem with that is the innate frailty of the physical components. Unlike binary bits, quantum particles have some probability of being each of these states designated 0 and 1, fading. For the cumulative derived a possible states that are independent, each one cancel with all times 1, hinging on poles of the other. The contingent possibilities proliferate as the qubits become more and more entangled with each operation. Considering the equation with exponential growing number of contingent possibilities are what makes quantum computers so powerful. Qubits are laterally error-prone. The field of string microwave pulses, causing them to undergo bit slips that switch to a chance of being 0 and 1 relative to other qubits. These slips that invert the mathematical way to qubit states. For quantum computers to work scientists must see the detecting range even when individual qubits get corrupted. But more these people detect their errors without directly measuring the qubits. This measurement collapse coexisting possibilities instead of realities, creating all zeros and ones that can't sustain quantum combinations. The 1995 profile of this factoring algorithm never started, but the quantum error correcting codes exist. Computer scientists talk about and like and other researchers working together prove the overall that these codes theoretically push error close to 0. This was the central discovery of the 90s, which people at scalable quantum computers should be possible. And it is merely a cycle problem of engineering. Now even as small quantum computers are materializing in labs around the world, useful that will outlast ordinary computer remain years or decades away. Far more efficient quantum error correcting codes are needed to cope with the daunting code error rates of real computers. The efforts to design better code is one of the major threats of the field, along with improving hardware. The dogged pursuit of these codes in the past quarter-century funding happened in 2014 when tools found evidence of the connection between quantum error and the field of static gravity. Relativity gravity is defined as the fact that the space-time bending around massive objects. All bonds in the air travels along a straight line, with space-time is itself bends back towards the earth. The powerful Adscft theory is physically gravity must go deeper, quantum relativity to somewhat of a space-time fabric of oscillations. By the year 2014, 3 young quantum gravity researchers came to astonishing realization. They were working in the overall play around the choice. In a toy universe called anti-dissonant space, that looks like a hologram. The bendy fabric of space-time is a clear universe of the world that emerges from untitled quantum particles living on its outside boundary. The calculations of this program space-time works just like a quantum error correction code. It's structured for high-energy physics, space-time itself is a code, just like the Matrix, and again by the considered universe of ADS. Research over the wave of activity in the quantum gravity community and new quantum error correcting codes have been discovered that capture more properties of space-time. Quantum error correction explains how space-time achieves its intrinsic robustness despite being woven out of fragile quantum stuff. We're not walking on eggshells to make sure we don't make the geometry fall apart. And I think this correct connection with quantum error correction is the deepest explanation we have for why that's the case. The language of quantum error correction is also starting to enable researchers to probe the mysteries of black holes, historical regions in which space-time curves deeply inward towards the center that not even light to escape. Everything traces back to black holes. We started out to the place where gravity reaches its conceded that Einstein's general relativity theory fails. There are some indications, but when considered which curve space-time implements, provide help us to understand the black hole theory. As a bonus, researchers hope that space-time might also consider the scalable quantum computing, considering longer vision for sure on others. Space-time is a lot smarter than us, the kind of quantum error correcting code which is implemented in these constructions is a very efficient code. So, how do quantum error correcting codes work? The trick is to protect information in jittery qubits to store it not in individual qubits but in patterns of entanglement among many. As a simple example, consider a 3-qubit code. It uses 3 physical qubits to a single logical qubit of information that it controls. The code isn't really useful for quantum error connection because it can protect against phase burst, but it is not less instructive. The zero state of the logical qubit corresponds to all 3 physical qubits being in their zero states, and the 1 state corresponds to all 3 being 1s. The system is a superposition of these states designated 000 plus 111. So we run the qubits bit first. How do we detect and correct the error without directly measuring any of the qubits? The qubits can be fed through 2 gates in a quantum circuit. One gate checks the parity of the first and the second physical qubit whether they are the same or different, and the other gate checks the parity of the first and third. First and second, and the first and third. If there is no error, meaning the qubits are in the state 000 plus 111, the parity measure gates for the first, second, and the first and third qubits are always the same. However, the first qubit qubits in state 100 plus 011. Gauge detects the difference in both of the pairs. Second qubit yielding 010 and the 101, the parity measure gauge detects the first 30 qubits are different and the first and third qubits are the same. For the third qubit first, the gauge indicates the same difference. The outcomes reveal which corrected circuits any need to be an operation that puts back the first, second, and third physical qubit without collapsing the logical qubit. Quantum error correction to me is like magic. These qubits are basically building block of quantum computers can exist in multiple states simultaneously but are susceptible to errors. Quantum error correction codes can detect and correct these errors by collapsing the superposition of states needed for quantum computations. Okay, so multiverse mini-world theory. This is why the superposition doesn't collapse, because the environment of each respective universe becomes entangled with itself, so it separates along the second dimension of time, and so there is no interaction between the universes. That's why it doesn't collapse. So it travels from one to the other, but there is no causal connection with the universe. The environmental noise can penetrate a qubit and corrupt the message it carries, so we can directly see whether a qubit has split or collapsed into superposition. Finding and fixing errors. 3 physical qubits of elementary particles can be used to represent one logical qubit of information while protecting it against error. For example, if there is an error, 2 quantum qubits indirectly check whether they are different, so the physical qubits match. For the speed, we know which qubit has split first, if any. When we first are put to one unique example of magnetic pulse, we go back to the erroneous qubit, choosing the logical qubits stable. The best error corrected codes can typically recover all of the code information from a slightly more than half of the utility qubits, even if the rest are corrupted. But this fact is what printed to Mary Don Harlow and the qubit quantum error correct codes largely related to the anti-nuclear space-time arises from quantum entanglement. For the fourth part, the ADS space is different from the spatial geometry of our considered universe. Our universe is infused with positive vacuum energy that causes it to expand without bonds, and the considered space has negative vacuum energy which gives the Bohr geometry of form of Msi Afterburner circular design. After separated creatures are smaller and smaller, moving outward from the circle's center, eventually vanishing from Adscft. Similarly, spatial energy moving away from the center of ADS space gradually shrinks and eventually disappears. The universe is out of boundary. ADS space made popularity among quantum theorists in 1997. After the renowned physicist Juan Alpina discovered that the empty space had gravity and theory is holographically dual. The quantum theory of particles living on lower dimensional gravity-free down. Here we go. All the principle again. And exploring how the duality works as hundreds of physicists have in the past 2 decades. Amiri and colleagues noticed that any point in the interior of ADS space could be constructed from slightly more than half of its boundary, just as an optimal quantum error correcting code. In their major conjecture that holographic space-time and quantum error correction are one and the same, it is described even a simple code could be understood as a 2D hologram, and it consists of 3 tricks or particular particles that exist in any of these states, sitting at equidistant points on a circle. The entangled 3 of 2 tricks declare one logical feature corresponding to a single space-time point in the circle's center. The code protects the point as the erasure of any of the 3 cubes. For a short time, in the universe, in 2015, they found another holographic code, nicknamed happy code. Captures all properties of ADS space. The code ties space by the building blocks little synchrotron. Each synchrotron represents a single space-time code. These tiles would be playing the role of fish in an exceptional tile. In the happy code and other holographic or correcting schemes that have been discovered, everything inside a region of the interior space-time called the entanglement wedge and then reconstructed for people on indeed the region of the boundary, where the overlapping regions of the boundary will have overlapping entanglement wedges. It is a logical fit qubit in a quantum computer is reproducible from many different subsets of physical qubits, as will the error and correcting property. Quantum error correction gives us a more general way of thinking about geometry in this code line. The language you said are applicable, in my opinion, to more general situations, in particular to consider universe like ours. That a distant space lacking a spatial boundary has so far proven much harder to understand as a hologram. For now, researchers are sticking with ADS space, which shows many key properties of the considered world but even simpler to study. Those space-time geometry combined with Einstein's theory with some curve in different directions. Perhaps supposedly both kinds of universes contain black holes. The fundamental property of gravity that there are black holes. It makes gravity different from the other. But quantum gravity is hard. The only use of quantum error corrections provided here describing black holes' presence of a black hole defined by the breakdown crackability. So there are so many errors that you can no longer keep track of what's going on in the bulk space-time anymore when you get a black hole. When the same rate of ignorance. Ignorance is invariably found when it comes to black hole interiors. Stephen Hawking, 1974, attempted to let black holes radiate heat, and this eventually evaporate away, the black hole intermission paradox, and that's what happens to all the information in black holes. Physicists in the quantum gravity understand how all black holes also get out. The issue related to cosmology and the birth of the universe. The expansion out of a Big Bang scenario with one gravitational collapse. The black hole in reverse. The weird information flowing out from the black hole. Very interesting reality right there. How does gravity work in the quantum machine? Holographic duality constrictly offers a powerful tool for unraveling the mystery. ADS simplifies the information question. Gravity in ADS universe is holographic reveals everything in it, black holes and all. The information will fall into a black hole. It's guaranteed never to be lost. It's always holographically encoded on the universe's boundary. Which is less that can be constructed information about a black hole. Even from the boundary, you need to access and I can see it throughout roughly 3/4 of the boundary. Slightly more than half is not sufficient anymore. However, the need for 3/4 seems to say something important about quantum gravity, but why that fraction comes up, still an open question. I think it's something to do with the ratio of surface area to volume. 3/4. The inverse which is 1 or the surface area of a sphere. 4/3 pi r². So that 4/3, the inverse of that is 3/4. So 3/4 is very important number. I'm going to have to look afterwards. With surface area versus volume, which is basically what the holographic principle is all about. The Calgary's first thing in 2012, called an Amirati physicist and 3 kilometers deep into the information product. The reasoning suggested that information might be tangled in the falling black hole in the first place by a firewall and the black holes. Then Enterprise. Like most physicists, mirrors of the blue black hole firewall to this, but finding the way around them proving that allowing things quantum error corrections but stops firewalls from forming. Protecting information even as it crosses black hole horizons. If it was soul work, we refer to quantum error correction code. It is essential for maintaining the fluidness of the horizon with 2 black holes. Called a wormhole. We said that quantum error correction will prevent firewalls and also allow people to create a black hole after falling asleep. We strands of entanglement between the inside and outside that are themselves like miniature wormholes. This would involve Hawking's paradox. This year, the Department of Defense was funding research in holographic space-time at least only in case of death who there might be more efficient error correction codes for quantum years. On the physics side, it remains to be seen whether considered universes like ours can be described holographically in terms of qubits and codes. But management is known for a world that is manifestly not our world. But in paper last summer,